Hey there, fellow Earth dwellers. You probably think you know this planet pretty well by now. Blue marble, 7 continents, maybe a few fun trivia facts to impress people at parties. Yeah, here's the thing. You've barely scratched the surface. There are rivers hot enough to cook you alive with no volcano in sight. A continent the size of 2 Indias hiding underwater that scientists only officially recognized in 2017. Places where rocks move by themselves and gravity literally gives up. Our planet is wilder than any sci-fi movie ever dared to imagine, and tonight we're covering 100 facts that prove it. Before we dive in, drop a comment and let me know. Where in the world are you watching from right now? And what time is it there? I'm genuinely curious how far across this crazy planet our little community stretches tonight. Now dim those lights, get comfortable, and prepare to have everything you thought you knew about Earth completely demolished. Let's go. So let's start our journey with something that sounds like it belongs in a fantasy novel rather than actual geography. Bodies of water that can kill you faster than you can say, I probably should have read the warning sign. When we think of dangerous water, most of us picture rip currents, sharks, or perhaps the slightly greenish pool at that budget motel. But what if I told you there are rivers hot enough to cook you like a lobster, lakes that can suffocate entire villages in their sleep, and pools so corrosive they can turn animals into what essentially amounts to creepy natural statues? Our planet has apparently been hiding some seriously homicidal bodies of water, and it's time we had a proper introduction. We'll begin in the heart of the Peruvian Amazon, where a river exists that most scientists dismissed as pure legend until remarkably recently. The Timpishka, known more commonly as the Boiling River, sounds exactly like something your grandfather might have invented to make his stories more interesting. A river in the middle of the jungle that runs hot enough to kill anything that falls into it? Sure, Grandpa. And yet here we are, in the 21st century, forced to admit that Grandpa was right all along. The Boiling River stretches approximately 6 kilometers through the dense Amazonian rainforest, and calling it merely warm would be like calling the surface of the sun slightly toasty. At its hottest recorded point, the water has reached temperatures of 99.1 degrees Celsius, which for those keeping score at home is basically boiling point at sea level. The average temperature along the thermal sections hovers around 93 to 95 degrees Celsius. To put this in perspective, most hot tubs are set to around 40 degrees, and even the most dedicated hot spring enthusiast would tap out long before reaching 50. This river operates at temperatures that would cause severe third-degree burns with just a second of contact. You could quite literally make yourself a cup of tea in it if you were somehow impervious to being poached alive in the process. What makes the Timpishka particularly fascinating from a scientific standpoint is that it shouldn't exist at all. Hot springs and geothermal features typically require volcanic activity, and the nearest volcano to this river sits more than 700 kilometers away. That's roughly the distance from London to Edinburgh, which is quite a commute for any reasonable heat source. For decades, scientists assumed the river was either mythological or, if it did exist, must be connected to some undiscovered volcanic system beneath the Amazon basin. Neither assumption proved correct. The story of the river's modern scientific discovery belongs to Andrés Rousseau, a geothermal scientist who grew up hearing tales of a boiling river from his Peruvian grandfather. As a child, Rousseau understandably filed these stories in the same mental folder as tales of El Dorado and other legendary South American wonders. But during his graduate studies at Southern Methodist University in Texas, while creating a geothermal map of Peru, Rousseau noticed something peculiar, a massive thermal anomaly in the Amazon, precisely where his grandfather's stories had placed it. In 2011, accompanied by his aunt, who happened to know the wife of the local shaman protecting the area, Rousseau finally witnessed the boiling river with his own eyes. The journey to reach it involved a flight to Pucallpa, followed by a 2-hour drive along dirt roads, a 45-minute canoe ride up the Pachitea River, and finally an hour-long hike through muddy jungle paths. This is not exactly a casual day trip, which perhaps explains why it remained largely unknown to the outside world for so long. The first recorded sighting by outsiders came in 1870, when 2 Englishmen working in the region stumbled upon it, though their accounts were largely dismissed by the scientific community. The local Ashaninka people naturally had known about it for centuries and had their own explanation. The river was home to Yakumama, the Mother of Waters, a mythical serpent spirit responsible for the extreme temperatures. The headwaters are even marked by a boulder that resembles a snake's head, which certainly doesn't hurt the legend's credibility. The current scientific consensus, though still being refined, suggests that the river's heat comes from what's called the geothermal gradient. Rainwater falling on the Amazon basin seeps deep into the earth through a network of fault lines, where it's gradually heated by the natural increase in temperature that occurs the deeper you go into our planet's crust. This superheated water then rises back to the surface through other fault lines, emerging as the thermal springs that feed the Shanay Timpishka. It's essentially the same process that creates hot springs elsewhere in the world, but at an unusual scale and in an unusual location. The fact that this process operates without any volcanic assistance makes the river one of the largest non-volcanic geothermal features on any continent. The river's name, Shanay Timpishka, translates from the local Ashaninka language as boiled by the heat of the sun, which is technically incorrect but poetically understandable. When you're standing next to a river sending clouds of steam into the jungle canopy, the sun seems like as reasonable an explanation as any. The water itself has been described by researchers as having a milky blue-green colour, often shrouded in mist, creating an almost otherworldly atmosphere that feels distinctly inappropriate for a rainforest setting. As for the wildlife situation, it's about what you'd expect. Animals that fall into the river do not have pleasant experiences. Researchers have witnessed small creatures accidentally tumbling into the water and emerging, well, cooked. Birds lose their feathers, frogs become immediate casualties, even approaching the heated mud along the riverbanks can cause burns. One researcher noted that the water would strip the ink off his Kodak film boxes within seconds, which gives you some idea of just how aggressive this water can be. Yet paradoxically, the surrounding area supports an unusually diverse ecosystem, with the thermal features creating microclimates that host unique species of insects, amphibians, and plants. Sadly, the river that survived centuries of obscurity is now facing modern threats. When Russo first visited in 2011, reaching the boiling river required that elaborate multi-stage journey. By 2014, deforestation had advanced so rapidly that the entire trip could be completed by a 3-hour direct drive from Pucallpa. The jungle that once protected this natural wonder is being carved away by logging, cattle farming and oil exploration, with the irony being that the area sits adjacent to Peru's oldest active oil field. Russo has since dedicated himself to protecting the river, establishing the Boiling River Project to promote research while working with the Peruvian government to secure official protection for this unique geothermal feature. The outcome remains uncertain, but the fact that we nearly lost this place before science even acknowledged its existence should give us pause. Now, the boiling river isn't the only body of water on Earth that operates at temperatures usually reserved for cooking pasta. Thousands of miles away, on the tiny Caribbean island of Dominica, sits another thermally aggressive body of water known simply as Boiling Lake. Located within Morne Trois Pitons National Park, a UNESCO World Heritage Site, this natural feature is exactly what it sounds like, a lake that is actively boiling. At approximately 60 to 75 metres across, Boiling Lake holds the distinction of being the second largest hot lake in the world, surpassed only by Frying Pan Lake in New Zealand, which sounds like it was named by someone who had just watched a cooking show and gave up trying to be creative. The water temperature at the edges of Dominica's Boiling Lake ranges from 82 to 92 degrees Celsius, which is already firmly in the do not touch under any circumstances category. But here's the part that really captures the imagination. Scientists cannot measure the temperature at the centre of the lake because the water is actively boiling too violently to allow any instruments near it. The centre of Boiling Lake is so aggressively hot that approaching it would essentially be volunteering to become soup. The lake presents a dramatic visual, a cauldron of bubbling greyish-blue water perpetually shrouded in clouds of rising vapour and sulphurous steam. Surrounded by the lush green tropical vegetation of the Dominican rainforest, it looks remarkably like something from a fairy tale, specifically one of those fairy tales where the witch has a cauldron and things don't end well for visitors. The contrast between the verdant jungle surroundings and this hellish pool of boiling liquid is genuinely striking, though perhaps not in a way that encourages swimming. Unlike the boiling river, scientists have a pretty good idea of what's going on beneath Boiling Lake. The lake is what's called a flooded fumarole, which is essentially a crack in the Earth's surface through which volcanic gases escape. Imagine a vent connected to the molten interior of our planet, then fill that vent with accumulated rainfall and water from nearby streams. The result is a natural basin where water seeps down through the porous bottom to encounter magma-heated rocks below, becomes superheated, and then boils back up to the surface in an endless cycle of geological violence. The lake was first officially recorded by Europeans in 1870, when Edmund Watt and Henry Alfred Alford Nichols, two Englishmen working in Dominica at the time, stumbled upon it during an expedition. 5 years later, a government botanist named Henry Prestow was commissioned to investigate the phenomenon properly, which involved hiking through dense jungle terrain to reach a lake that could potentially flash steam anyone who got too close. The dedication to science in the 19th century was truly remarkable, if occasionally life-threatening. What makes Boiling Lake particularly unpredictable is its occasional habit of draining and refilling without warning. Records show that the lake has gone through at least 8 documented emptying events since 1876. During the most recent significant episode between December 2004 and April 2005, the lake level dropped dramatically, then refilled, then dropped again, all within a matter of weeks. On one particularly dramatic day in February 2005, the lake was observed to be almost completely empty in the morning and almost entirely full by the following day. This wasn't someone misremembering things. Park rangers documented both states within 24 hours. During these draining events, the water temperature can drop from its usual scalding temperatures to around 20 degrees Celsius, which is almost pleasant by comparison, though authorities strongly advise against using these opportunities for a quick dip. Getting to Boiling Lake requires a rather grueling hike, which in some ways serves as a natural filter preventing people from making foolish decisions at the water's edge. The trail spans approximately 8 miles round trip, takes 6 to 10 hours to complete, and involves navigating steep terrain, mud that could swallow small children, and the sulphurous Valley of Desolation along the way. This neighbouring area, which lives up to its cheerful name, features its own collection of hot springs, steaming vents, and mineral-stained rocks that create a landscape looking distinctly extraterrestrial. Hikers who make the journey often boil eggs in the thermal pools along the way, which is either a charming travel tradition or a sobering reminder that these same waters would do exactly the same thing to human flesh given the opportunity. Local authorities have repeatedly issued warnings about approaching the lake, particularly during draining events when the risk of sudden steam explosions increases. The University of the West Indies Seismic Research Centre monitors the lake as part of its volcano monitoring programme and recommends that visitors exercise extreme caution, avoid descending to the water's edge under any circumstances, and absolutely refrain from swimming, no matter how hot and tired they might be after the hike. This advice might seem obvious, but the fact that it needs to be explicitly stated suggests that someone, somewhere, once thought about it. Now, speaking of bodies of water that will happily kill you through entirely different mechanisms, let's discuss the Dead Sea. Located between Jordan, Israel, and Palestine, this famous lake operates on a completely different principle of lethality. Rather than cooking you, it simply makes traditional survival impossible through sheer chemical hostility. The Dead Sea sits at the lowest land-based elevation on Earth, approximately 430 metres below sea level, which already marks it as geographically unusual, but its real claim to fame is its extraordinary salt content. At around 34% salinity, the Dead Sea is approximately 10 times saltier than typical ocean water. To visualise this, imagine dissolving over 300 grams of salt into every litre of water, which creates something that doesn't behave like normal water at all. NASA researchers have described the sensation of entering the Dead Sea as feeling like olive oil mixed with sand, which sounds unpleasant but turns out to be reasonably accurate. This extreme salt concentration creates the Dead Sea's most famous feature: you cannot sink in it. The water's density, at around 1.24 kilograms per litre, compared to the human body's average density of about 1.07 kilograms per litre, means that you float whether you want to or not. People famously pose for photographs reading newspapers while bobbing on the surface, which never stops being surreal regardless of how many times you've seen the image. Traditional swimming becomes essentially impossible because you can't submerge yourself enough to execute proper strokes. Instead, you bob about like a cork, which is amusing for approximately 5 minutes before becoming genuinely frustrating. However, the Dead Sea's hostility extends well beyond simply making swimming awkward. The salt concentration is so extreme that virtually no complex life can survive in its waters, hence the somewhat grim name. No fish swim through its waters. No plants grow along its bottom. No birds paddle on its surface hunting for prey. The only organisms that can tolerate these conditions are certain extremophile bacteria and fungi that have evolved specifically for such harsh environments. In 1992, an unusually rainy period diluted the surface layer enough to allow a bloom of Dunaliella parva, a type of algae, which briefly turned the Dead Sea red due to high concentrations of the pigment bacteria ruberin. This was essentially the Dead Sea throwing a rare life party, and it still managed to make things look like a horror movie. For humans, extended exposure to the Dead Sea's water creates its own set of problems. The salt stings any cut or wound with impressive intensity, irritates eyes with remarkable efficiency, and burns nasal passages if you're foolish enough to get splashed in the face. Swallowing the water is a genuinely dangerous proposition, as the extreme salt content can cause rapid dehydration and potentially serious medical complications. Despite the impossibility of sinking in the traditional sense, people have drowned in the Dead Sea, typically after being flipped by waves, swallowing the hypersaline water, and becoming incapacitated before they could right themselves. The recommended time for actually being in the water is 15 to 20 minutes at most, followed by a thorough freshwater rinse to remove the salt residue that would otherwise continue attacking your skin. The Dead Sea is also slowly dying, which creates an unusual situation where one of the world's most famous dead bodies of water is becoming progressively more dead. Water levels have been dropping by approximately 1.2 metres per year since the 1970s, primarily due to human diversion of the Jordan River for agricultural and domestic use. As the water evaporates in the hot, dry climate, salt concentrations increase further and the shoreline recedes, leaving behind crystallized salt formations that look beautiful but represent an ecosystem in terminal decline. The deeper layers of the lake are now so saturated with salt that crystals precipitate directly out of the water and accumulate on the lake bed, growing about 10 centimeters thicker each year. Scientists have discovered a phenomenon they call salt fingering, where warm surface water carrying dissolved salt descends through cooler layers, depositing its mineral payload on the bottom. The Dead Sea is essentially building itself a salt grave from the inside out. But perhaps the most terrifying water body we'll discuss today operates on a completely different principle of destruction, one that requires no heat and no corrosive chemistry. Lake Nyos, located in the northwestern region of Cameroon, looks like an ordinary volcanic crater lake, with deep blue waters surrounded by lush tropical vegetation. It's the kind of scene that would make an excellent desktop wallpaper. On August 21, 1986, this picturesque lake killed over 1,700 people in a single night, without any warning and without any visible cause. The Lake Nyos disaster represents one of the strangest and most horrifying natural catastrophes in recorded history. On that August evening, residents of the villages surrounding the lake heard a low rumbling sound, like distant thunder, that lasted about 20 seconds. Shortly afterward, a fountain of water and foam shot approximately 100 meters into the air above the lake's surface. What followed next was invisible and almost silent. A massive cloud of carbon dioxide gas, released from the lake's depths, rolled across the surrounding landscape like a deadly fog. Carbon dioxide is heavier than air, which meant this toxic cloud didn't rise and disperse. Instead, it hugged the ground, flowing downhill through valleys and into villages at speeds of up to 50 kilometers per hour. Because carbon dioxide is colorless and odorless at normal concentrations, most victims had no warning that anything was wrong until they collapsed from oxygen deprivation. Within a radius of approximately 23 kilometers from the lake, people simply fell asleep and never woke up. Farmers died in their beds. Entire families were found in their homes, positioned as though they had simply laid down to rest. Cattle dropped in their fields, wildlife vanished, insects stopped making sounds. The silence that greeted rescue workers 36 hours later was described as absolute. Survivors, of whom there were only a few hundred, reported regaining consciousness after periods of unconsciousness lasting anywhere from 6 to 36 hours. Many had no memory of what had happened, waking confused and disoriented to find their families dead around them. One survivor described walking through his village to find the destruction. "I managed to go over to my neighbours' houses. They were all dead. I decided to leave because most of my family was in Wum. I got my motorcycle. A friend whose father had died left with me for Wum. As I rode through Nyos, I didn't see any sign of any living thing. The total death toll reached 1,746 humans and approximately 3,500 livestock, making it the deadliest known natural release of carbon dioxide in history. The phenomenon responsible for this catastrophe is called a limnic eruption, and Lake Nyos was only the second time scientists had ever documented one. 2 years earlier, in 1984, the smaller Lake Manoon, located about 100 kilometers southeast of Nyos, had released a similar carbon dioxide cloud that killed 37 people. At the time, the mechanism wasn't fully understood. After Nyos, scientists finally pieced together what was happening. Lake Nyos sits in a volcanic crater, and beneath the lake lies a pocket of magma that continuously releases carbon dioxide into the water. Under normal circumstances, this gas dissolves into the cold, deep water at the bottom of the lake, where high pressure keeps it in solution, much like the carbonation in a sealed bottle of soda. Over time, the concentration of dissolved carbon dioxide builds up, turning the lake's depths into what scientists now call a limnic bomb. All it takes to trigger an eruption is something to disturb this unstable equilibrium: a landslide, a small earthquake, heavy rain mixing the water layers, or even just the concentration reaching a critical point where the gas begins to spontaneously escape. When the eruption happens, it's essentially a massive underwater burp. The gas escaping from the deep water creates a chain reaction, with rising bubbles causing more gas to come out of solution, which creates more bubbles and so on. The result is a catastrophic release of all the accumulated carbon dioxide in a matter of minutes. At Lake Nyos, scientists estimated that between 100,000 and 300,000 tons of carbon dioxide erupted in the 1986 event, creating a gas cloud approximately 50 meters thick that traveled up to 23 kilometers from the lake. The water itself changed color after the eruption, shifting from its normal deep blue to a reddish-brown as iron-rich deep water was brought to the surface and oxidized. This color change, combined with the strange silence and the mysterious deaths, led to wild speculation in the immediate aftermath. Some survivors reported smelling gunpowder or rotten eggs, which scientists later attributed to trace amounts of sulfur compounds in the gas release. The entire event seemed supernatural in its scope and strangeness, which only added to the psychological trauma experienced by survivors. Since 1986, engineers and scientists have worked to degaz Lake Nyos and prevent a recurrence. The solution is elegantly simple in concept. Install pipes that reach from the lake's surface down to the carbon dioxide-saturated depths, then allow the pressure differential to drive a self-sustaining fountain of gas-rich water. As the water rises through the pipe and pressure decreases, the dissolved gas comes out of solution and creates an upward flow that requires no external power once initiated. The first pipe was installed in 2001, with additional pipes added in 2011. By 2019, monitoring confirmed that a single pipe could maintain the degassing indefinitely, keeping carbon dioxide concentrations at safe levels without any further intervention. However, Lake Nyos isn't the only limnic time bomb on our planet. Lake Kivu, situated between the Democratic Republic of Congo and Rwanda, is approximately 2,000 times larger than Lake Nyos and sits atop even greater concentrations of dissolved gases, including both carbon dioxide and methane. An estimated 2 million people live in the immediate vicinity of Lake Kivu, meaning a large-scale limnic eruption that could potentially become one of the worst natural disasters in human history. Scientists monitor the lake closely, and companies have begun extracting methane for power generation, which has the dual benefit of producing energy and reducing the gas concentrations. But the threat remains, a reminder that some of the most dangerous places on Earth look entirely peaceful until they aren't. Speaking of lakes that can kill through means other than gas or heat, let's venture to northern Tanzania, where Lake Natron awaits with its own particularly unsettling method of dealing with living creatures. This lake has earned a reputation for turning animals into stone, which sounds like the work of a particularly dedicated Gorgon from Greek mythology, but is actually just chemistry being dramatic. Lake Natron sits in the eastern branch of the East African Rift Valley, at the base of Oldoinyo Lengai, an active volcano that holds the distinction of being the only volcano on Earth that erupts nitrocarbonatite lava. This unique type of lava is extremely rich in sodium and potassium carbonates, which sounds like a geology lecture but becomes relevant when you realize that millions of years of volcanic runoff have turned Lake Natron into something resembling industrial-strength cleaning solution. The lake's pH levels regularly exceed 10, and can reach as high as 12, putting it on par with ammonia. For reference, battery acid sits at around 1 on the pH scale, pure water is 7, and household bleach is about 12.5. Lake Natron's waters are caustic enough to burn human skin and eyes on contact. Water temperatures can reach 40 degrees Celsius in the shallows, adding thermal discomfort to chemical aggression. The lake frequently turns blood red due to salt-loving bacteria and cyanobacteria that thrive in these extreme conditions, producing pigments that make the entire body of water look like something from a horror film. What made Lake Natron internationally famous, however, was photographer Nick Brandt's haunting 2013 photo series, showing what happens to animals that die in and around the lake. The images depict birds and bats preserved in startlingly lifelike positions, their bodies covered in a crusty white mineral coating that makes them look like they were turned to stone mid-flight or mid-perch. The chemical compound responsible is natron, the same sodium carbonate compound that ancient Egyptians used in their mummification processes. Animals that fall into the lake and die become pickled and calcified by the mineral-rich water, preserved in eerily perfect detail as natural statues. The exact cause of death for these animals isn't the water itself in most cases. Scientists theorize that the lake's highly reflective surface confuses birds, causing them to crash into the water like they might crash into a glass window. Once in the water, the extreme alkalinity quickly overwhelms them. Those that die in or near the lake are then naturally preserved by the same chemicals that killed them. Brandt found the calcified creatures washed up on the shoreline and posed them in lifelike positions for his photographs, which created the misleading impression that animals simply dropped dead wherever they stood. The reality is slightly less dramatic, but no less macabre. The lake acts as both executioner and taxidermist, killing animals and then preserving the evidence. Remarkably, Lake Natron is not entirely hostile to all life. It serves as the primary breeding ground for the lesser flamingo, with up to 3 million of these birds gathering there each year. The flamingos are adapted to the harsh conditions and actually depend on them, feeding on the spirulina algae that thrives in the alkaline water. The same chemistry that kills most creatures also keeps predators away, creating a safe haven for flamingo nests. It's a strange ecological arrangement, one of the most toxic lakes on Earth serving as a nursery for one of Africa's most distinctive bird species. Now, if chemical lakes that preserve dead animals sound disturbing, allow me to introduce Spain's Rio Tinto, a river that looks like it belongs on Mars rather than Earth. For approximately 50 kilometers, this river in southwestern Spain runs a vivid red and orange colour, so strikingly unusual that NASA has used it as a testing ground for Mars exploration technology. The Rio Tinto, which translates as stained river or red river, owes its appearance to extreme acidity and high concentrations of dissolved metals. The water maintains a pH of around 2 to 2.5, which places it firmly in the more acidic than vinegar category. Dissolved iron gives the water its characteristic rusty red colour, while copper, zinc, arsenic and various other heavy metals contribute to its toxic cocktail. No fish swim in its waters, no amphibians breed along its banks. No insects buzz above its surface. The river is so hostile to conventional life that it's been described as a flowing wound in the Spanish landscape. The chemistry responsible for the Rio Tinto's condition comes from the Iberian Pyrite Belt, one of the largest deposits of sulfide ore in the world. When these sulfide minerals are exposed to air and water, they undergo chemical reactions that produce sulfuric acid and release dissolved metals. This process, called acid mine drainage, occurs naturally but has been dramatically accelerated by human activity. People have been mining copper, silver and gold from the Rio Tinto region for approximately 5,000 years, with evidence of metallurgical activity dating back to the Copper Age and Bronze Age. The Romans extensively exploited the deposits, and large-scale industrial mining continued from the mid-19th century through the 20th century. Whether the river was always this acidic or became so due to human mining remains a subject of scientific debate. Some researchers argue that natural processes alone could create these conditions given the enormous sulfide deposits in the area. Others point to historical records showing that the river was actually used for irrigation and drinking water in some periods, suggesting that mining dramatically worsened what might have been a naturally unusual, but not necessarily lifeless, waterway. A 16th century priest exploring the region documented that no fish or other life existed in this river, neither do people or animals drink it, which suggests the damage was already significant by that point. What makes the Rio Tinto scientifically fascinating rather than simply environmentally tragic is the extremophile life that does manage to survive there. The river hosts communities of bacteria, algae, and even some single-celled eukaryotic organisms that have adapted to thrive in conditions that would kill virtually any other form of life. These extremophils extract energy from the chemical reactions occurring in the acidic, metal-rich water, essentially eating the very substances that make the river toxic to everything else. The diversity of these organisms has surprised scientists who expected bacterial dominance but found unexpected variety among the microscopic inhabitants. NASA's interest in the Rio Tinto stems from the river's similarity to conditions that may exist or may have existed on Mars. The iron-rich sulfate minerals found around the river, particularly jarosite, have been identified on the Martian surface by rovers exploring the Red Planet. If life can survive in the Rio Tinto's extreme conditions, the thinking goes, then similar life might have survived in comparable Martian environments billions of years ago. Scientists have conducted extensive studies at the river site, testing remote-controlled drilling systems and life detection technologies that might one day be deployed on Mars. The river that mining destroyed has become a window into potential extraterrestrial biology, which is either ironic or poetic depending on your perspective. Of course, when discussing the most dangerously polluted bodies of water on Earth, we eventually have to address Lake Karachay in Russia, which held the distinction of being the most contaminated place on the planet for several decades. Located in the southern Ural Mountains near the city of Ozyorsk, this small lake was used as a dumping ground for radioactive waste from the nearby Mayak nuclear facility from 1951 onwards. The result was a body of water so lethally irradiated that simply standing on its shore for an hour could deliver a fatal radiation dose. The Mayak Production Association was constructed in total secrecy between 1946 and 1948 as part of the Soviet atomic bomb program. Built under tremendous pressure to match American nuclear capabilities, the facility prioritized speed over safety to a degree that seems almost incomprehensible by modern standards. The original reactors used an open-cycle cooling system that discharged contaminated water directly into nearby waterways. When measurements taken downstream revealed dangerous radiation levels, engineers needed a new place to dump their waste. Lake Karachay, small and conveniently close to the facility, became the solution. The lake's name means black water in the local Turkic languages, which proved grimly appropriate. Between 1951 and the 1990s, Mayak dumped an estimated 120 million curies of radioactive material into Lake Karachay, primarily consisting of cesium-137 and strontium-90. For perspective, the entire Chernobyl disaster released approximately 85 million curies, spread over a much larger area. Lake Karachay concentrated comparable levels of radioactivity into a body of water measuring only about 900 meters long and 500 meters wide. At its most dangerous, in 1990, radiation levels at the lakeshore measured 600 roentgens per hour. A lethal dose for humans is generally considered to be around 400 to 500 roentgens, meaning that 30 to 60 minutes of exposure would be enough to kill. The Natural Resources Defense Council described the lake as the most polluted spot on Earth, a distinction it maintained until concerted cleanup efforts began in the 1990s. The situation became even worse in 1967, when a drought caused the lake's water level to drop significantly. As the contaminated sediment at the bottom became exposed and dried, wind carried radioactive dust across the surrounding region, irradiating an estimated 500,000 people. This was essentially a dirty bomb distributed by natural weather patterns, and it came on top of the Kishtim disaster of 1957, when an underground storage tank at Mayak exploded and released approximately 20 million curies of radioactive material into the atmosphere. The existence of Mayak and its environmental crimes remained entirely secret until the Soviet Union collapsed. The facility and the surrounding closed city didn't even appear on maps until 1989. When Western scientists finally gained access in 1992 following Boris Yeltsin's decree opening the area, they found radioactive contamination on a scale that defied easy comprehension. The sediment at the bottom of Lake Karachay was estimated to consist almost entirely of high-level radioactive waste to a depth of approximately 3.4 meters. Cleanup efforts have been ongoing since the mid-1990s, with the primary strategy being to simply fill in the lake with special concrete blocks, rock, and dirt. The goal was to prevent further wind dispersal of contaminated sediment and to stabilize the radioactive material in place. The filling was completed in 2015, with monitoring confirming reduced surface contamination afterward. However, the legacy of Lake Karachay will persist for generations. The radioactive contamination has seeped into groundwater, creating a plume of polluted water spreading outward at approximately 100 meters per year. The lake may be gone, but its poison continues to migrate through the Russian landscape, a slow-motion disaster that will take centuries to fully unfold. Finally, let's end our tour of deadly waters with something that looks entirely inviting until you make one wrong decision. Jacob's Well in the Texas Hill Country appears to be nothing more than a pleasant natural swimming hole, its crystal-clear water maintaining a refreshing 68 degrees Fahrenheit year-round. Locals and tourists alike gather at this artesian spring to escape the brutal Texas heat, floating in the turquoise water and jumping from surrounding rocks into the inviting pool below. What they might not realize is that beneath this innocent-looking surface lies one of the most dangerous underwater cave systems in the world. The opening of Jacob's Well measures only about 4 meters across, but this modest entrance leads to a vertical shaft that plunges 30 feet straight down, before continuing at an angle through multiple chambers extending to depths of over 40 meters. The cave system stretches for more than a mile underground, with mapped passages totaling over 1.5 kilometers. The main tunnel alone runs approximately 1.3 kilometers, with a secondary tunnel branching off for another 400 meters. All of this exists beneath what appears to be a simple swimming hole. At least 12 divers have died attempting to explore Jacob's Well, earning it a reputation as one of the deadliest dive sites in the United States. The cave system features everything that makes underwater cave diving dangerous. Narrow passages that require divers to remove their equipment to squeeze through, silty floors that can reduce visibility to zero with a single wrong kick, false exits that appear to lead to the surface but actually terminate in dead ends, and the constant pressure of knowing that any mistake could prove fatal with no possibility of rescue. The layout of Jacob's Well is divided into 4 distinct chambers, each more dangerous than the last. The first chamber extends from the surface to about 55 feet and remains relatively safe for trained divers. The second chamber reaches down to approximately 80 feet and starts to require more experience. The third chamber, between 80 and 90 feet, features the notorious false chimney, a passage that looks like it might lead upward to safety, but actually goes nowhere. At least one diver has died following this false exit, running out of air while searching for a way out that didn't exist. The fourth chamber, extending beyond 90 feet, has been sealed off with a metal grate after multiple fatalities, though determined divers have historically found ways around such barriers. The most famous tragedy at Jacob's Well occurred on September 9, 1979, when 20-year-old Kent Maupin and 21-year-old Mark Brashear decided to explore the deepest reaches of the cave without proper equipment or planning. Both were experienced divers, but cave diving requires specialized training, redundant equipment, and careful preparation that neither had arranged. Around midnight, the 2 men entered the final passage on impulse, removing their tanks to squeeze through a tight restriction and disappearing into the darkness beyond. Their bodies were not recovered for years. A professional diver named Don Dibble attempted to reach them shortly after the accident and nearly died himself when loose gravel shifted and trapped him in the same passage. He ran out of air while stuck, accepted that he was about to die, and was freed only at the last moment when convulsions from oxygen deprivation caused him to thrash loose. He had to swallow air on his way up, which expanded and ruptured his stomach, requiring surgery. One of the victims' bodies was eventually flushed out of the cave naturally in 1981. Kent Maupin's remains weren't discovered until 2000, 21 years after he died, found by divers conducting a mapping expedition. Despite this grim history, Jacob's Well continues to attract thrill-seekers. The deceptive appeal of the site lies in its accessibility. Anyone can swim in the opening, and the crystal-clear water makes the vertical shaft visible and seemingly inviting. Freedivers regularly descend as deep as they dare, sometimes capturing their adventures on camera. One widely shared video shows a young man named Diego Adame freediving deep into the cave in 2015 when his flipper slipped off at around 100 feet. He lost his flashlight while pushing off the walls in his rush to return to the surface, cutting away his weight belt and barely making it back before losing consciousness. He later said that for a split second he thought about dying that day. Today, only specially permitted divers are allowed to explore the cave system beyond the surface swimming area, and the deepest chambers remain sealed to prevent further tragedies. The Jacob's Well Exploration Project has mapped the cave extensively and continues to study this geological feature, though they describe it as a challenging, unforgiving environment that demands the utmost respect. What all these deadly water bodies share, from the boiling rivers to the radioactive lakes to the deceptive swimming holes, is a fundamental lesson about our planet. Earth contains countless features that don't care about human survival. We evolved in a narrow range of conditions, and the natural world offers no guarantees that any given environment will accommodate us. The waters we've explored in this chapter kill through heat, chemistry, invisible gases, radiation, and simple geometry. Some look dangerous and are dangerous, others look inviting and are deadly. The planet operates according to its own rules, and those rules occasionally include eliminate all life in this specific location. Yet there's something fascinating about these places beyond their danger. They represent extremes, boundaries of what's possible in terms of temperature, chemistry, and geological activity. They host unique life forms that have adapted to conditions we would find lethal. They provide windows into planetary processes that operate on scales of time and space that dwarf human experience. The boiling river shows us how water cycles through the Earth's crust. Lake Neos reveals the hidden dangers of dissolved gases. Lake Natron demonstrates chemistry that resembles ancient mummification. Rio Tinto offers a preview of Martian conditions. Even Lake Karachai, despite being a human-caused disaster, teaches us about the persistence of radioactive contamination and the challenges of environmental remediation. As we continue our journey through 100 geography facts that prove our planet is stranger than fiction, remember that the bodies of water we've just discussed exist right now, somewhere on this planet, doing exactly what we've described. Rivers are boiling, lakes are acidifying, caves are waiting in the darkness. The Earth, it turns out, has a rather creative approach to being inhospitable, and we're just fortunate that most of us never have to experience these places firsthand. From the deadly waters that can end lives in seconds, we now descend into a realm that operates on an entirely different scale of mystery. If the surface of our planet has managed to hide boiling rivers and killer lakes for centuries, imagine what lies beneath the waves, where even our most sophisticated technology has only scratched the surface. Beneath the ocean's surface exist entire worlds that humanity had no idea about until remarkably recently. We have mapped the face of Mars with greater precision than we have charted our own ocean floors, which is either a testament to our ambition for space exploration or a rather embarrassing admission about how little attention we pay to what's directly beneath our feet, or rather beneath our boats. The oceans cover roughly 71% of Earth's surface, yet we have explored less than 5% of them in any meaningful detail. That means 95% of our planet's underwater realm remains essentially unknown territory, hiding geological formations, ecosystems, and yes, even entire continents that cartographers forgot to mention. For most of human history, we assumed the ocean floor was a flat, featureless desert of mud and darkness. We were spectacularly wrong, naturally, but discovering just how wrong required technology that would have seemed like pure fantasy to explorers of previous centuries. Consider this remarkable fact. A continent the size of India has been lurking beneath the Pacific Ocean for approximately 80 million years, and scientists only officially recognized its existence in 2017. Not 1917, not 1817. The year 2017, when smartphones had already been around for a decade and we could video call someone on the other side of the planet without thinking twice about it. Yet somehow a landmass stretching nearly 5 million square kilometers managed to escape formal acknowledgement until then. The planet, it seems, still enjoys keeping secrets from us. This hidden continent goes by the name Zealandia, or Te Rua Maui in the Maori language, and its story reads like geological detective fiction, spanning centuries of missed clues and overlooked evidence. The first European to stumble upon hints of its existence was Dutch navigator Abel Tasman, who arrived at the shores of what would become New Zealand in 1642. Tasman was searching for what Europeans called Terra Australis, the hypothetical southern continent that mapmakers had been drawing for centuries, despite having absolutely no evidence of its existence. Upon reaching New Zealand's South Island, Tasman believed he had discovered this great southern landmass. He was both right and wrong simultaneously, though he had no way of knowing it at the time. Tasman named one bay Mordanair's Bay, which translates to Murderer's Bay, after a violent encounter with the local Maori population left several of his crew members dead. He sailed home without exploring further, never to return to these waters, though he remained convinced he had found something significant. What Tasman could not possibly have known was that the islands he had glimpsed were merely the highest peaks of an enormous submerged plateau, like seeing only the tip of an iceberg and assuming you understand its full dimensions. The underwater portion of this landmass would remain hidden for another 375 years. The hints continued accumulating over the following centuries, though nobody quite managed to assemble them into a coherent picture. Geologists noticed that New Zealand's rocks bore striking similarities to those found in Australia and Antarctica, suggesting some ancient connection. The seafloor around New Zealand appeared unusually elevated compared to typical oceanic crust. But these observations remained scattered puzzle pieces until the late 20th century, when advancing technology finally allowed researchers to peer beneath the waves with unprecedented clarity. In 1995, American geophysicist Bruce Luyendyk proposed the name Zealandia for this submerged region, though his suggestion met with skepticism from colleagues who questioned whether it qualified as anything more than a collection of continental fragments. The academic debate continued for over 2 decades, with researchers painstakingly gathering evidence through rock samples, gravity measurements, and satellite imagery. Finally, in February 2017, a team of 11 geologists from New Zealand, New Caledonia, and Australia published a landmark paper in the Geological Society of America's journal GSA Today, formally arguing that Zealandia met all the criteria to be considered Earth's 8th continent. The criteria for continental status are surprisingly specific and rather demanding. A continent must be elevated above the surrounding oceanic crust, possess distinct geological structures, have a defined area, and contain crust thicker than typical ocean floor. Zealandia checks every box, though with some unusual characteristics that explain why recognition took so long. Most notably, 94% of Zealandia lies submerged beneath the Pacific Ocean, with only New Zealand, New Caledonia, and a scattering of smaller islands poking above the surface. This makes it the most drowned continent on Earth, which is not a phrase one expects to encounter in geological literature, but is nonetheless accurate. The submerged portions of Zealandia rest between 1 and 2 kilometres below sea level, hidden from view but very much present. The continental crust averages about 20 kilometres thick, substantially more than the 7 kilometres typical of oceanic crust, but thinner than most other continents. This relative thinness explains why Zealandia sank beneath the waves in the first place. Continental crust floats on the denser mantle below, much like ice floating on water, and thinner crust simply floats lower. Zealandia stretched and thinned as it separated from other landmasses, eventually settling at elevations where ocean water covered most of its surface. Zealandia's origin story begins approximately 100 million years ago, when the supercontinent Gondwana was still intact. Gondwana contained what would become Antarctica, Australia, South America, Africa, India, and Arabia, all joined in a massive southern landmass. Zealandia was part of this assembly, connected to both Antarctica and Australia along the edge of what would become the Pacific. Then the rifting began. Tectonic forces started pulling Zealandia away from Antarctica around 100 million years ago, and from Australia roughly 80 million years ago. The separation was not clean or rapid. It stretched over tens of millions of years, during which the crust thinned and subsided. By approximately 23 million years ago, most of Zealandia may have been completely submerged, though this remains a subject of ongoing research. Some scientists believe portions remained above water throughout, providing refuges for the unique flora and fauna that evolved in isolation on what remained of the continent. The discovery of fossil mammal jaws in New Zealand, dating to a time when Zealandia was supposedly entirely underwater, has complicated this picture considerably. Either the continent was not as submerged as previously thought, or small mammals proved more aquatically inclined than anyone expected. The mystery remains partially unsolved. What scientists have established with greater certainty is Zealandia's role in forming the Pacific Ring of Fire, that horseshoe-shaped zone of volcanoes and earthquakes that encircles the Pacific Ocean. Around 50 million years ago, dramatic tectonic changes affected northern Zealandia, an area roughly the size of India. Rock layers buckled, underwater volcanoes formed, and the region experienced the geological equivalent of a particularly turbulent renovation project These events coincided with the formation of the Ring of Fire itself, suggesting that Zealandia's transformation was part of a much larger reorganization of the Pacific's tectonic plates. In 2017, shortly before the formal recognition paper was published, an international team of 32 scientists from 12 countries set sail on the research vessel Joides Resolution for a 9-week expedition to drill into Zealandia's underwater terrain. They extracted sediment cores reaching over 1,250 meters into the seabed, retrieving samples that contained microfossils, pollen grains, and evidence of shallow marine environments. More than 8,000 specimens were studied, revealing hundreds of fossil species that proved Zealandia was not always so deeply submerged. The geography and climate of this hidden continent were dramatically different in the past, with land bridges and shallow seas that allowed plants and animals to disperse across the South Pacific in ways that modern maps would suggest impossible. The expedition's findings rewrote Zealandia's geological history in significant ways. Researchers discovered evidence of 2 distinct tectonic events that shaped the continent. First, its separation from Gondwana, then its transformation during the formation of the Ring of Fire. The sediment cores provided sensitive records of climate changes and sea level variations stretching back millions of years, offering data that will help refine computer models predicting future climate patterns. If the models cannot accurately predict conditions that existed in the past, their forecasts for the future become considerably less reliable. Zealandia has now achieved another distinction. It became the first continent to have its geology, volcanoes and sedimentary basins fully mapped from edge to edge. A 2023 study completed the mapping of North Zealandia, building on earlier work that had charted the southern regions. Among the discoveries was a giant volcanic region that ignited along the edge of Gondwana between 160 million years ago, before the continent even separated. The mapping revealed the extent of stretching, twisting and thinning that the continental crust underwent during its long separation from Gondwana. The implications of Zealandia's recognition extend beyond pure geology. For New Zealand, Australia and France, demonstrating that Zealandia constitutes a continental shelf offers potential economic rights under the United Nations Convention on the Law of the Sea. The seabed of a nation's continental shelf can contain valuable resources, from oil and gas deposits to mineral reserves. Proving that these underwater territories form part of a genuine continent, rather than merely oceanic crust, strengthens claims to those resources. Science and sovereignty intersect in ways that would have baffled Abul Tasman, though he certainly understood the importance of claiming new lands for one's nation. But Zealandia is merely the largest of the ocean's hidden worlds. The depths conceal other remarkable features that challenge our assumptions about what can exist beneath the waves. Consider, for instance, the discovery that beneath the Black Sea flows a genuine underwater river, complete with banks, floodplains, and even waterfalls. This is not a metaphor or a poetic description. It is a literal river of highly saline water flowing through a channel carved into the seafloor, discovered in 2010 by scientists from the University of Leeds. The Black Sea underwater river stems from Mediterranean water flowing through the Bosphorus Strait into the Black Sea. The Mediterranean has higher salt content than the Black Sea, making its water denser. When this saltier water enters the less saline environment of the Black Sea, it does not simply mix and disappear. Instead, the dense water sinks and flows along the bottom, carving a channel as it goes. The physics is straightforward enough, but the results are anything but ordinary. The underwater river measures approximately 60 kilometers in length, reaching depths of up to 35 meters in places and widths approaching 1 kilometer. Its flow rate is substantial. Roughly 22,000 cubic meters of water pass through per second, moving at speeds around 6 kilometers per hour. If this river flowed across dry land instead of beneath the sea, it would rank as approximately the 6th largest river on Earth by volume, more powerful than the Rhine, and comparable to many of the world's famous waterways. The only difference is that nobody can see it without sophisticated submersible technology. Scientists exploring the channel discovered features remarkably similar to those found in surface rivers. The underwater river has defined banks where the flow meets the surrounding seawater. It has floodplains where water spreads during periods of higher flow. Most remarkably, it has cascades and what can only be described as underwater waterfalls, where the channel drops suddenly and the flowing water tumbles downward before continuing its journey. The entire system operates like a river on land, except that both the river and its surroundings consist of water. The discovery was made using a robotic submarine equipped with instruments capable of measuring water velocity and imaging the three-dimensional structure of the system. The research team found that the underwater river behaves differently from surface rivers in several important ways. In normal rivers, the highest velocities occur near the surface. In the Black Sea's underwater river, the fastest flow can occur near the bottom, where the densest water concentrates. The currents also spin in the opposite direction when rounding bends compared to their surface counterparts, a quirk of the different physics involved. The river system formed approximately 7,500 years ago, when the Bosphorus developed its characteristic two-way flow pattern. The strait functions as a hydraulic barrier between two bodies of water with different salinities, allowing less dense water to flow outward near the surface, while denser Mediterranean water enters at depth. This continuous exchange maintains the underwater river's flow, with dense water cascading into the Black Sea and carving its channel through the sediment. The implications of this discovery extend beyond mere curiosity. Similar underwater channels exist in other parts of the world, though none had been found with water actively flowing through them before the Black Sea discovery. One of the largest known underwater channels runs from the mouth of the Amazon River into the Atlantic Ocean, though it formed when sea levels were much lower and now sits dormant. The Black Sea River proved that these mysterious seafloor channels can indeed function as active waterways, just as researchers had suspected but never confirmed. Understanding underwater rivers has practical applications for marine biology and resource management. The currents deliver nutrients and sediments to the abyssal plains, regions that scientists have compared to deserts of the marine world. These channels function as arteries providing ingredients essential for life in the deep ocean, transporting materials from continental margins to the remote depths. Without such flows, the deep sea would be even more barren than it already appears. The Black Sea itself holds additional secrets beyond its underwater river. The water body has a peculiar chemistry that has made it a treasure trove for underwater archaeology. Below approximately 150 to 200 meters, the Black Sea becomes anoxic, meaning it contains virtually no oxygen. This dead zone, which comprises roughly 90% of the sea's total volume, creates conditions that prevent the biological decay that normally destroys shipwrecks within years or decades. Ancient vessels that sank into the Black Sea's anoxic depths have remained remarkably preserved for millennia. In 2018, archaeologists discovered a Greek merchant vessel dating to around 400 BCE, more than 2,400 years old, lying at a depth of roughly 2 kilometers off the Bulgarian coast. The ship rests on its side with its hull, rudder, mast and decking almost completely intact. The preservation is so extraordinary that even rope remains visible wrapped around the mast. This is the oldest intact shipwreck ever discovered, a vessel that was already ancient when the Roman Empire was just beginning its rise. The Black Sea Maritime Archaeology Project has documented over 60 historic shipwrecks during surveys of Bulgarian waters alone, representing a span of 2,500 years of maritime history. The collection includes vessels from the Ottoman and Byzantine empires, Roman trading ships still laden with amphorae, and craft from the era of Greek colonization. Each wreck provides archaeological evidence that would have been lost entirely in oxygen-rich waters, where wood-boring organisms and bacterial decay would have reduced the ships to unrecognizable debris centuries ago. Researchers have created detailed three-dimensional models of these wrecks using advanced photogrammetry techniques, preserving digital records of ships that cannot safely be raised from such extreme depths. The environmental conditions that protect the wrecks also complicate their study. Bringing artifacts to the surface exposes them to oxygen, triggering rapid deterioration that can destroy objects within months if they are not immediately placed in conservation treatments. The Black Sea has thus become a kind of underwater museum, its exhibits viewable only through the eyes of remotely operated vehicles. The ocean holds still more optical illusions and aquatic deceptions beyond these hidden features. Off the southwestern coast of Mauritius, near the Le Morne Peninsula, lies what appears to be an enormous underwater waterfall, a spectacular cascade of ocean water plunging into an abyss. Photographs taken from aircraft show what looks like a massive drainage channel, as if the entire island is being sucked down into an enormous drain. The image has captivated millions who have seen it reproduced in travel magazines and on social media. The reality, however, is considerably more mundane yet still fascinating. The Mauritius underwater waterfall is an optical illusion created by the movement of sand and silt along the seafloor. Mauritius sits on an underwater plateau that rises approximately 150 metres above the surrounding seabed. At the southwestern tip of this plateau, the seafloor drops away abruptly into depths exceeding 4,000 metres, a vertical descent nearly 5 times the height of the Burj Khalifa. Strong ocean currents sweep sand and sediment off the shallow shelf and down this steep slope, creating visual patterns that mimic flowing water. The illusion depends entirely on viewing angle. From the surface or from a boat, the phenomenon is essentially invisible. Only when observed from above, whether from a helicopter, seaplane, or mountain summit, do the contrasting colours of the shallow turquoise lagoon and the deep blue ocean combine with the flowing sediment to create the waterfall effect. The lighter coloured sand streaming over the dark drop-off produces exactly the visual impression of water cascading into an abyss. The brain, accustomed to interpreting such colour gradients as depth and motion, fills in the rest. The geological formation responsible for this illusion dates back approximately 8 million years, when volcanic activity created Mauritius and the surrounding islands. The young island sits on an ocean shelf that ends in a dramatic escarpment, the underwater equivalent of a coastal cliff. Currents flowing around the island gather sand eroded from the beaches and coastal formations, carrying it toward the edge of the shelf where gravity takes over. The continuous movement of sediment maintains the illusion even though no actual waterfall exists. Visitors seeking to witness the phenomenon must either take aerial tours or hike to elevated viewpoints like the summit of Le Morne Brabant, a UNESCO World Heritage Site that rises dramatically from the peninsula. The mountain offers panoramic views of the surrounding waters, though the illusion is most striking from directly overhead. Swimming or diving in the area reveals nothing unusual, merely different depths of water and the normal activity of currents moving sand across the seafloor. The magic exists only in the eye of the observer, or rather in the observer positioned at precisely the right altitude. Yet the ocean does contain genuine underwater waterfalls, even if the one at Mauritius is not among them. The largest waterfall on Earth, in fact, exists entirely beneath the ocean's surface, hidden in the Denmark Strait between Greenland and Iceland. The Denmark Strait cataract makes every surface waterfall seem modest by comparison. It drops approximately 3,500 metres from top to bottom, more than 3 times the height of Angel Falls in Venezuela, which holds the title of tallest waterfall on land. The volume of water involved is equally staggering, roughly 175 million cubic metres per second, compared to a mere 2,000 times less for Niagara Falls during peak flow. This underwater colossus forms through the interaction of water masses with different temperatures and salinities. Cold, dense water from the Nordic seas flows southward through the Denmark Strait, meeting the warmer, less dense water of the Erminger Sea. The cold water, being heavier, sinks below the warmer layer and cascades down the underwater slope, much like water pouring over a conventional waterfall. The strait narrows to roughly 300 miles at this point, concentrating the flow and accelerating it over the submerged ridge that forms the cataract's lip. The Denmark Strait Cataract was first confirmed by oceanographers tracing temperature and salinity profiles through the region decades ago. Sensors revealed a dense ribbon of Nordic seawater sliding into the Atlantic basin, gathering momentum as it approached the ridge that forms the underwater cliff. When the cold water reaches this tipping point, it spills over and plunges toward the ocean floor, widening as it falls until the sheet of descending water stretches roughly 500 kilometers across. Despite its enormous scale, the Denmark Strait Cataract produces no roar, no mist, and no rainbows. It cannot be visited by tourists, and no tour guide offers expeditions to witness its majesty. The entire phenomenon occurs between 1 and 3 kilometers beneath the ocean surface, invisible to anyone without access to sophisticated scientific equipment. Even instruments positioned in the area record only subtle changes in water movement. According to researchers, being physically present at the cataract would be thoroughly anticlimactic. The water moves at roughly half a metre per second, slow enough that a person suspended in the current would barely notice anything happening. The importance of the Denmark Strait Cataract extends far beyond its impressive statistics. The flow of cold water it produces forms a crucial component of the Atlantic meridional overturning circulation, the system of currents that moves heat and water throughout the world's oceans. Sometimes called the global conveyor belt, this circulation pattern helps stabilize global climate by distributing thermal energy across thousands of kilometres. The Denmark Strait Cataract functions as one of the major pumps driving this system, pushing cold water toward the equator while warmer surface water flows northward to replace it. Climate change poses potential threats to this circulation system. As Arctic temperatures rise and ice caps melt, the salinity of polar waters decreases. Less salt means less density, which means the water may not sink as readily when it reaches warmer regions. A weakening of the Denmark Strait's flow could reduce the efficiency of the entire Atlantic circulation, with consequences for weather patterns, marine ecosystems, and even the mild temperatures that Western Europe currently enjoys. The invisible waterfall beneath the Arctic waves may thus have more influence on human affairs than any of its more photogenic cousins cascading down tropical cliffs. The sunken worlds beneath our oceans remind us how much remains unknown about our own planet. We have discovered hidden continents, underwater rivers flowing through carved channels, optical illusions that fool pilots and photographers, and waterfalls that dwarf anything on land yet produce no sound whatsoever. Each discovery raises new questions. What other features lie waiting in the unexplored 95% of the ocean floor? What geological processes operate in places we have never observed? The deep ocean, it turns out, is not a static, featureless void, but a dynamic environment where the usual rules of geography apply in unexpected ways. From the hidden worlds beneath the ocean, we surface to confront places where reality itself seems to malfunction. Every schoolchild learns the basic laws of physics. Objects fall downward, heavier things require more force to move, and gravity pulls everything toward the centre of the Earth with predictable reliability. These rules have governed human understanding of the physical world for centuries, forming the bedrock of engineering, architecture, and basic common sense. Yet scattered across our planet are locations where these fundamental principles appear to take an unexpected holiday. Objects roll uphill, massive stones wander across desert floors without any visible assistance. Entire regions weigh less than they should according to every measurement that matters. Science has, fortunately, provided explanations for these apparent impossibilities, though the explanations sometimes prove nearly as fascinating as the mysteries themselves. Consider Death Valley, California, a place that has already earned its ominous name through relentlessly hostile conditions. Summer temperatures regularly exceed 50 degrees Celsius, rainfall barely exists, and the landscape consists primarily of salt flats, barren mountains, and the bleached bones of those who underestimated the terrain. One might assume that this environment has revealed all its secrets by now, given that it has been explored, mapped, and studied for over a century. One would be quite wrong. At a remote location called Racetrack Playa, flat slabs of dolomite and syenite rock sit scattered across a remarkably level dry lake bed. These rocks range from a few hundred grams to several hundred kilograms, with some weighing as much as an adult human. None of this would be particularly remarkable, except for one perplexing detail: the rocks move. They leave trails behind them etched into the clay surface, tracks that sometimes stretch for hundreds of meters and occasionally change direction abruptly. The rocks with rough bottoms tend to leave straight tracks, while those with smoother undersides wander in more erratic patterns. The phenomenon was first documented in 1915, when a prospector named Joseph Crook visited the site and noticed the mysterious trails. Over the following decades, scientists proposed dozens of theories to explain how rocks weighing hundreds of kilograms could travel across a flat surface without any apparent force moving them. Some suggested powerful winds might push the stones, though the velocities required would have been exceptional even by Death Valley's gusty standards. Others proposed magnetic forces, gravitational anomalies, or the intervention of pranksters with too much time on their hands. A few inevitably blamed extraterrestrial visitors, because certain corners of the speculation market never pass up an opportunity. The rocks seem to mock every attempt at explanation by refusing to move when anyone was watching. Scientists installed cameras, only to capture nothing but stillness. Researchers embedded GPS tracking devices in some stones, then waited years for movement that stubbornly refused to occur. The sailing stones, as they came to be called, moved perhaps once every few years, and only under conditions that apparently excluded human observation. The breakthrough finally came in December 2013, when researchers Richard Norris and his cousin James Norris, working with the Scripps Institution of Oceanography, managed to be in the right place at precisely the right time. They had established a high-resolution weather station at the southern end of Racetrack Playa, and fitted 15 rocks with GPS tracking devices capable of recording movement and velocity. Then they settled in for what they expected might be a very long wait. The previous suspected movement had occurred in 2006, suggesting that rocks might move only about 1/1,000,000th of the time. Fortune, however, favoured the patient. A rare series of winter storms deposited enough rain to form a shallow pond across the playa. The water was deep enough to form floating ice during cold winter nights, but shallow enough that the rocks remained exposed above the surface. When nighttime temperatures plummeted, the pond froze into thin sheets of what the researchers called windowpane ice, delicate enough to move freely but just strong enough to maintain structural integrity. Then, on December 21, 2013, the ice began to break up. Richard Norris later recalled hearing popping and cracking sounds coming from all over the frozen pond surface as the ice fractured around noon. He turned to his cousin and said what any scientist would say at such a moment: "This is it." Large sheets of ice, tens of meters in size, began drifting across the playa, driven by light winds. As these ice panels encountered the rocks protruding from the shallow water, they accumulated behind them and gently pushed. The GPS devices recorded the movement, stones shifting at speeds of 2 to 5 meters per minute, far too slow to notice at a distance but undeniably real. The solution to the century-old mystery proved elegantly simple, yet remarkably specific in its requirements. First, the playa must fill with water to an exact depth, enough to form ice but not enough to submerge the rocks. The temperature must then drop sufficiently to freeze this shallow pond into ice, thin enough to move but strong enough not to shatter against the stones. Then the sun must rise and warm the ice until it breaks into large panels. Finally, a light wind must push these panels across the wet, slippery mud. If any element is missing, the rocks remain stationary. Strong winds would break the ice against the rocks rather than pushing them. Too much sun would melt the ice before it could accumulate enough force. Too little water and no ice forms. Too much water and the rocks disappear beneath the surface. This precise combination of conditions explains why movements are so rare and why no one had observed them directly for nearly a century. Climate change may be making such events even less frequent, as warmer winter nights reduce the likelihood of ice formation even during wet periods. Statistical analysis of historical movement reports suggests an apparent decline in rock activity between the 1990s and the 21st century, possibly linked to changing regional weather patterns. The sailing stones of Death Valley may eventually become entirely stationary, their famous trails a relic of cooler times. The researchers documented 5 separate movement events during the 2.5 months their monitoring equipment was active, with some events involving hundreds of rocks moving simultaneously across the playa. The ice sheets pushed multiple stones in coordinated patterns, their tracks converging and diverging according to the direction of the wind and the position of the ice panels. Rocks that had sat motionless for years shifted multiple times in quick succession, before settling into new positions where they might rest for another decade or more. The sailing stones demonstrate how natural phenomena can appear supernatural when the conditions required to produce them are sufficiently rare and specific. For a century, scientists searched for exotic explanations when the actual mechanism involved nothing more exotic than ice, water, and wind combining in a particular sequence. The explanation is almost disappointingly mundane, except that it required patient observation over years to confirm. Nature, it seems, enjoys its little jokes on human curiosity. From rocks that slide mysteriously across desert floors, we travel to locations where vehicles appear to roll uphill in direct defiance of gravitational law. Magnetic Hill, located on the outskirts of Moncton in New Brunswick, Canada, has been attracting puzzled visitors since the 1930s. The experience is simple. Drive to a marked spot at what appears to be the bottom of a hill, shift into neutral, release the brake, and watch your vehicle roll backward toward the top. Every instinct and visual cue insists that the car is rolling uphill, against gravity, pulled by some invisible force embedded in the landscape. The phenomenon drew attention after local farmers noticed their vehicles behaving strangely on what was then a dirt road near their properties. Word spread, and by the 1930s, enterprising locals had begun capitalizing on the curiosity. A young woman named Muriel Lutz, who lived nearby, named the site Magnetic Hill and started selling ice cream and souvenirs to the growing crowds of visitors. By the 1950s, Magnetic Hill had become Canada's 3rd most popular tourist destination, trailing only Niagara Falls and Banff National Park in visitor numbers. The explanation, however, has nothing to do with magnetism, despite the name that has stuck for nearly a century. Magnetic hill is what geologists call a gravity hill, a type of optical illusion created when the surrounding landscape obscures the true horizon and tilts visual reference points in misleading ways. The road that appears to run uphill is actually sloping gently downward. The trees, fence posts, and other features that the brain uses to calibrate its sense of level are themselves tilted, making a slight decline appear to be an incline. Human spatial perception relies heavily on the horizon line to establish what is level and what is not. When the horizon is hidden by hills, trees, or buildings, the brain must rely on other cues: the angle of trees, the pitch of nearby structures, the general lay of the land. At Magnetic Hill and similar locations around the world, these secondary cues consistently mislead rather than inform. The brain interprets the downslope as an upslope, and when a vehicle in neutral begins rolling in the expected gravitational direction, the visual system insists this is impossible. The car appears to be rolling uphill because the downslope has been misidentified as an upslope. The illusion affects more than just vehicles. Water flowing through ditches alongside the road appears to run uphill as well, defying one of the most basic observations in hydraulics. Golf balls placed on the pavement roll in what seems to be the wrong direction. Even people walking along the road report feeling disoriented, their inner ear and their eyes sending contradictory information to a confused brain. Similar gravity hills exist throughout the world, though few have achieved the fame of Moncton's version. Canada alone has several others, including locations in British Columbia near Maple Ridge and Vernon, one near Swan River in Manitoba, and additional sites in Ontario's Oshawa, Burlington, and Caledon regions. The United States has dozens scattered across various states. Italy, the United Kingdom, Australia, and numerous other countries each claim their own examples. The phenomenon apparently requires only the right combination of landscape features to fool human perception, and such combinations occur with surprising frequency. The persistence of these optical illusions, despite rational explanation, reveals something important about how perception works. Knowledge that the road actually slopes downward does not correct the illusion. Even after being told exactly what is happening and why, visitors still experience their vehicles rolling uphill. The visual processing systems that interpret spatial relationships operate largely independently of conscious knowledge, delivering conclusions that the higher brain cannot override simply by understanding they are wrong. Magnetic Hill works the same way today as it did in the 1930s, not because science has failed to explain it, but because explanation does not change how eyes and brain cooperate to deceive. The phenomenon has been stable enough that when a road near Abbotsford, British Columbia was repaved, a formerly popular gravity hill ceased to exist. The slight changes in road grade and surrounding features were apparently sufficient to disrupt the precise configuration that had created the illusion. This fragility suggests that gravity hills represent a kind of geological coincidence, places where erosion, construction, and vegetation have accidentally conspired to create exactly the wrong visual environment for accurate perception. From illusions that make things appear to move against gravity, we turn to a place where gravity genuinely behaves differently than everywhere else on Earth. The Hudson Bay region of Canada experiences gravitational pull approximately 0.004% weaker than the global average. This might seem like an impossibly small variation, and indeed it is undetectable by any human sense. You could stand in Hudson Bay and jump without noticing any increased hang time. You could drop objects without observing them fall more slowly. Yet the difference is real, measurable, and has been puzzling scientists since it was first detected in the 1960s. Gravity is fundamentally a function of mass. The more mass an object possesses, the stronger its gravitational attraction. Earth's mass is not distributed uniformly. Variations in rock density, thickness of the crust, and structures in the mantle below all create slight differences in gravitational strength from location to location. These differences are minuscule by everyday standards, but significant enough to be detected by sensitive instruments, and more recently, by specialized satellites designed specifically to map gravitational variations. The Hudson Bay anomaly was discovered when researchers began charting global gravity fields using increasingly precise measurement techniques. The region consistently registered lower gravitational readings than expected, and the discrepancy was large enough to demand explanation. Two main theories emerged, both of which have since been confirmed as contributing factors. The first explanation involves ice. During the last ice age, which ended roughly 10,000 years ago, an enormous ice sheet called the Laurentide ice sheet covered much of North America. This was not a modest glaciation. In most areas, the ice reached nearly 2 miles thick. In some parts of Hudson Bay, it exceeded 2.3 miles. The weight was almost incomprehensible, approximately 10 trillion tons pressing down on the continental crust. Under this immense burden, the crust deformed, sagging into the denser mantle below like a finger pressed into soft bread. When the ice melted, the weight lifted, but the crust did not immediately spring back. The mantle flows slowly, measured in geological rather than human timescales, and the rebounding crust has been rising at less than half an inch per year. Scientists estimate that the land must rise more than 200 meters to return to its original position, a process that will require approximately 300,000 additional years to complete. In the meantime, the Hudson Bay region remains depressed relative to its pre-glacial state, meaning there is less rock beneath it than there would otherwise be. Less rock means less mass, and less mass means weaker gravity. The second explanation involves processes occurring deep within Earth's interior. Beneath the crust lies the mantle, a layer of slowly churning hot rock that behaves somewhat like an extremely viscous fluid over geological timescales. Convection currents in the mantle, driven by heat from the planet's core, can pull the overlying crust downward in some regions and push it upward in others. In the Hudson Bay area, these convection currents appear to be exerting a downward tug, reducing the mass concentration and contributing to the gravitational deficit. Data from the Gravity Recovery and Climate Experiment satellites, known as GRACE, allowed researchers to distinguish between these two effects by measuring gravitational variations with extraordinary precision. The satellites orbited roughly 500 kilometers above Earth, separated by about 220 kilometers, and could detect changes in their relative positions down to a single micron. When the leading satellite passed over regions with lower gravity, its orbit deviated slightly, allowing scientists to map gravitational variations across the entire globe. Analysis of GRACE. Data revealed that the ice sheet rebound effect accounts for between 25 and 45% of the gravitational variation observed in Hudson Bay. The remainder, between 55 and 75%, is attributable to mantle convection and other deep geological processes. This means that even after the crust fully rebounds from the Ice Age compression, Hudson Bay will still have slightly weaker gravity than the global average, a permanent feature created by forces operating hundreds of kilometers below the surface. The research has implications extending well beyond academic curiosity. Understanding gravitational anomalies helps scientists reconstruct what Earth looked like during the Ice Ages, revealing the extent and thickness of ancient glaciers. The rate of crustal rebound provides information about the viscosity of the mantle, which influences everything from volcanic activity to earthquake behavior. And the GRACE satellites have proven invaluable for monitoring modern ice sheets and glaciers, tracking their mass as they melt and predicting how that meltwater will contribute to rising sea levels. Along the coasts of Hudson Bay, evidence of the ongoing rebound is visible to anyone who knows where to look. Former beach levels now sit inland, marking positions where the shoreline once lapped against the land before the rising crust lifted them away from the water. These ancient beach ridges form parallel lines across the landscape, each one representing a former sea level that is now stranded far above the current coast. The bay's sea level is actually falling relative to the land, even as global sea levels rise elsewhere, because the land is rising faster than the water. The gravitational anomaly of Hudson Bay joins a select group of locations where the fundamental forces of physics vary measurably from their average values. The largest known gravity anomaly on Earth is not in Canada but in the Indian Ocean, at a spot called the Indian Ocean Geoid Low. There, the sea surface sits approximately 106 meters lower than the global average, because the gravitational pull is weak enough to create a literal depression in the ocean surface. Water, like everything else, flows toward areas of stronger gravity, leaving a relative deficit where gravity is weakest. These anomalies remind us that the solid ground beneath our feet is anything but static. The planet's surface rises and falls in response to forces we cannot see, pressures that have been relieved for millennia continuing to drive changes that will outlast human civilization. The ice that pressed down on Hudson Bay melted before the first Egyptian pyramid was built, yet its ghost still shapes the land and bends the rules that govern how strongly Earth pulls on everything that rests upon it. The places where physics seems to malfunction thus turn out to be places where physics is operating exactly as it should, just in ways that our limited perceptions fail to anticipate. Rocks slide across desert floors because ice and wind conspire at precise moments to push them. Cars roll uphill because the landscape has tricked our eyes into misidentifying which way is up. Gravity weakens because the rock beneath us is still recovering from burdens that lifted 10,000 years ago. Science has not debunked these mysteries so much as revealed that the real explanations are more interesting than the supernatural alternatives. We began this journey with boiling rivers and killer lakes, then descended into sunken continents and underwater rivers, and now stand in places where the laws governing the physical world bend in surprising directions. The planet we inhabit is far stranger than the simplified version taught in elementary school textbooks, filled with extremes and anomalies and exceptions that challenge our assumptions at every turn. Yet each mystery, once solved, reveals the same underlying truth. The rules are consistent, but the conditions are infinitely varied. What seems impossible usually turns out to be merely improbable, waiting for exactly the right circumstances to occur. The question that remains after considering all these geographical peculiarities is straightforward. What else is out there? We have explored less than 5% of the ocean floor. Vast regions of rainforest, desert, and polar ice remain understudied. Even in well-mapped areas, new discoveries continue to emerge as technology improves, and researchers venture to locations previously considered too remote or too hostile to investigate. If continents can hide beneath the waves for centuries and rivers can flow through the ocean floor, if rocks can wander across dry lake beds when no one is watching, and gravity can vary enough to measure, what other impossibilities might become? Tomorrow's confirmed phenomena? The Earth, despite hosting nearly 8 billion humans and supporting civilizations that span millennia, retains its capacity for surprise. The places described in these chapters represent only what we have found so far. Out there, somewhere, other wonders wait in deserts that swallow travelers, beneath waters that preserve secrets for ages, and in locations where the fundamental forces that shape our existence reveal unexpected behaviors. The planet operates according to its own rules, rules that we are still learning, and it shows no signs of running out of ways to astonish us. From places where the laws of physics appear to take unexpected holidays, we now turn to perhaps the most quietly unsettling geographical deception of all. The maps we have been staring at our entire lives have been lying to us. Not through malicious intent necessarily, but through the unavoidable reality that flattening a spherical planet onto a rectangular piece of paper requires some creative liberties with the truth. The distortions that result are not minor quibbles detectable only by professional cartographers. They are fundamental misrepresentations of reality that have shaped how generations of humans understand the relative sizes and importance of different parts of the world. And once you see the actual proportions, you cannot unsee them. The culprit behind most of this geographical gaslighting is a 16th century Flemish mapmaker named Gerardus Mercator, whose 1569 projection became the default way of displaying the world and remains so in classrooms, boardrooms, and digital navigation systems to this day. Mercator's projection was designed for a specific practical purpose, helping sailors navigate the seas by preserving accurate compass bearings. When you're trying to cross the Atlantic Ocean without crashing into rocks, having straight lines represent constant compass directions is genuinely useful. What Mercator's projection was not designed for, however, was accurately representing the relative sizes of land masses. In fact, it does the opposite, systematically inflating regions near the poles while shrinking those near the equator. The mathematical reasons for this are straightforward enough. Wrapping a sphere onto a cylinder, which is essentially what Mercator's projection does, requires stretching the spherical surface increasingly as you move away from the equator. Near the poles, this stretching becomes extreme, reaching toward infinity at the very top and bottom of the map, which is why Mercator maps simply cannot show the polar regions at all. But the psychological consequences of growing up with these distorted images are profound. Most people who attended school in the Western world carry around mental images of geographical proportions that are wildly incorrect, and correcting these false impressions requires a surprisingly deliberate effort. Consider Greenland, that enormous white mass dominating the upper portion of most world maps. On a standard Mercator projection, Greenland appears roughly the same size as the entire continent of Africa. The visual impression is unmistakable. These two landmasses seem comparable in scale. The reality, however, tells a dramatically different story. Africa covers approximately 30.37 million square kilometres, making it the second largest continent on Earth. Greenland, by contrast, covers just 2.17 million square kilometres. This means Africa is not just somewhat larger than Greenland. It is roughly 14 times larger. You could fit 14 Greenlands inside Africa and still have room for a few smaller countries. The map you grew up with was not just slightly misleading, it was fundamentally deceiving you about the relative importance of different parts of the planet. The distortion extends far beyond this single comparison. On Mercator maps, Alaska appears to be roughly the same size as Brazil, which might lead a casual observer to assume these are similarly scaled territories. In reality, Brazil is approximately 5 times larger than Alaska. Australia, which appears smaller than Alaska on many world maps, is actually 4.5 times larger. The entire country of Canada, which dominates the northern portion of most maps with its imposing pink or orange expanse, appears larger than the continental United States plus Alaska combined. The actual size difference is considerably less dramatic, though Canada does remain the second largest country by land area. The distortion grows more extreme the closer you get to the poles. Russia and Canada seem to occupy roughly half the world's landmass on a Mercator projection, looming over everything else like geographical bullies. While both are indeed enormous countries, the visual exaggeration makes them appear even more dominant than they actually are. Meanwhile, countries straddling the equator, where the distortion is minimal, appear in something closer to their true proportions. But this accuracy comes at the cost of appearing less significant compared to their northern and southern neighbours. Africa, positioned directly on the equator, suffers particularly from this optical diminishment. The continent that could comfortably contain the United States, China, India, Japan, Mexico, and most of Western Europe, combined somehow appears modest and manageable on standard world maps. This is not a minor cosmetic issue. As of 2025, the African Union has officially backed a campaign to replace Mercator maps in educational and governmental contexts with projections that more accurately represent the continent's true scale. The argument is straightforward. When the world's second largest continent appears shrunken compared to much smaller northern territories, the psychological implications for how people perceive African nations, their resources, their populations, and their importance in global affairs cannot be benign. The solution to Mercator's distortions is not straightforward, unfortunately, because no flat map can perfectly represent a spherical surface. Every projection involves trade-offs. The Peters projection, which gained attention in the 1970s and has been adopted by some school districts seeking more equitable representations, preserves the relative sizes of landmasses accurately, but distorts their shapes, stretching countries near the equator vertically while compressing those near the poles. The Equal Earth projection, developed in 2018, attempts to balance these competing concerns while maintaining a pleasing visual appearance. But none can escape the fundamental impossibility of the task. The only truly accurate representation of Earth is a globe, which most people find inconvenient to carry in their back pocket. Modern digital mapping has complicated matters further. Google Maps and similar services default to Mercator projection at higher zoom levels because it preserves the shapes of streets and buildings accurately, which is what most users care about when navigating from point A to point B. When you zoom out to view continents, however, the same distortions that confused geography students for centuries continue to shape how billions of people visualize the world. Google added a globe option for desktop users in 2018, but old habits die hard and most users never bother to enable it. The consequences of these cartographic distortions become most apparent when you start making direct comparisons between geographical features and objects outside our planet. Take Russia, for example, the largest country on Earth by a considerable margin. Its territory spans approximately 17.1 million square kilometres, stretching across 11 time zones from the Baltic Sea to the Pacific Ocean, from the Arctic tundra to the mountains bordering China. This is, by any measure, an absurdly large country. But how large exactly? One comparison that has circulated widely attempts to contextualize Russia's size by comparing it to Pluto, the dwarf planet orbiting at the far reaches of our solar system. Before NASA's New Horizons mission flew past Pluto in July 2015, our estimates of the dwarf planet's size were somewhat uncertain. Based on pre-flyby calculations, Pluto's surface area was estimated at roughly 16.65 million square kilometers, which would indeed make it slightly smaller than Russia's land area. This led to the widely shared factoid that Russia was larger than an entire planetary body, which is a genuinely striking way to conceptualize the country's scale. However, New Horizons provided more accurate measurements, revealing Pluto's diameter to be 2,377 kilometers and its surface area to be approximately 17.65 million square kilometers, making the dwarf planet marginally larger than Russia after all. The comparison remains useful regardless of which territory edges out the other by a few 100,000 square kilometers. The point is that a single nation on Earth occupies roughly the same surface area as an entire celestial body orbiting billions of kilometers away in the coldest reaches of the solar system. Russia could comfortably contain Pluto within its borders, with room to spare in either direction. The dwarf planet, which takes 248 Earth years to complete a single orbit around the Sun, which receives so little solar radiation that its surface temperature hovers around minus 230 degrees Celsius, which humanity did not even discover until 1930, and did not photograph closely until 2015, covers approximately the same amount of walkable, or, in Pluto's case, hypothetically walkable terrain, as the country that stretches from St. Petersburg to Vladivostok. This puts into perspective just how enormous Russia is, but also how surprisingly modest Pluto is by planetary standards. The dwarf planet's demotion from full planetary status in 2006 suddenly seems less like an arbitrary bureaucratic decision and more like an acknowledgement of reality. When a celestial body that was once taught as the ninth planet turns out to be roughly country-sized, perhaps its classification warranted reconsideration. Though residents of Pluto, if any ever exist, might reasonably argue that their world should not be compared unfavourably to a nation that spans merely one planet's surface. The comparison between geographical and astronomical features works in the opposite direction as well, sometimes with equally surprising results. Australia, that vast island continent at the bottom of most world maps, is often underestimated due to the same Mercator distortions that inflate northern territories. The continent spans approximately 4,000 kilometres from its eastern coast to its western shores, a distance that takes commercial flights several hours to cover and driving expeditions several days to complete, assuming you survive the various. Creatures that have evolved specifically to make Australian survival challenging. This east-west measurement turns out to be larger than the diameter of Earth's moon. The moon, that familiar celestial companion that has inspired poetry, religion and space programs throughout human history, measures roughly 3,474 kilometres across its equator. Australia, by contrast, stretches approximately 4,000 kilometres from Cape Byron in New South Wales to Steep Point in Western Australia. This means that if you could somehow place the moon on the ground next to Australia, the continent would extend beyond the celestial body on both sides. The moon would fit comfortably within Australia's borders, with several hundred kilometres to spare. Not that anyone is proposing such an arrangement, given the likely tidal consequences. This comparison requires some careful caveats, naturally. The moon is a three-dimensional sphere, while Australia is essentially a two-dimensional surface. The moon's total surface area, at approximately 37.94 million square kilometres, is nearly 5 times larger than Australia's 7.69 million square kilometres. So while Australia is wider than the moon in one dimension, the moon offers considerably more total terrain, distributed across its spherical surface. You could not fit 5 Australias on the moon simultaneously, but you could theoretically walk across more total ground on our satellite than on the island continent, assuming you brought appropriate footwear for both environments. Still, the comparison serves to illustrate just how large continental landmasses actually are, and how modest celestial bodies can be by comparison. The moon that appears so impressively in the night sky, that humans travelled 384,400 kilometres to reach, that has influenced literature and mythology for millennia, could slip through Australia without touching the coasts. Every time you see the moon rising above the horizon, you're looking at an object narrower than a single continent on Earth. The universe, it turns out, is full of scale inversions that confound our intuitions about what should be large and what should be small. Water provides another category of comparisons that strain the capacity of human minds to comprehend. Lake Baikal, that ancient rift lake nestled in the mountains of Siberia, contains approximately 20% of Earth's unfrozen surface freshwater. This is not a typographical error or an exaggeration for dramatic effect. A single lake in Russia holds 1/5 of all the liquid fresh water available on the planet's surface, more than all 5 of North America's Great Lakes combined, more than every lake in Africa added together, more than most countries could ever hope to access within their own borders. The numbers behind Lake Baikal's water volume are staggering. The lake contains roughly 23,615 cubic kilometers of fresh water, which is a figure so abstract that it requires translation into more relatable terms. If all the rivers on Earth were somehow diverted to drain Lake Baikal simultaneously, flowing at their combined average discharge rates, it would still take over a year to empty the lake completely. The water that would flood out during this hypothetical drainage could supply the entire population of Earth with drinking water for roughly 50 years. The lake is so vast that a single molecule of water entering it will take, on average, 330 years to exit through its sole outlet, the Angara River. Water that entered Lake Baikal when Isaac Newton was formulating his laws of motion is only now beginning to flow toward the Arctic Ocean. Part of what makes Lake Baikal so exceptional is its depth. At maximum depth of 1,642 meters, it is the deepest lake on Earth by a substantial margin, more than a kilometer deeper than any of the Great Lakes, deep enough that you could stack the Eiffel Tower 5 times and still not reach the surface. This depth, combined with its considerable surface area of 31,722 square kilometers, creates a water volume that dwarfs any comparable body of fresh water. The lake is also the world's oldest, having formed approximately 25 to 30 million years ago as a rift valley gradually filled with water. Most lakes, particularly those formed by glacial activity, survive only 10 to 15,000 years before sediment fills them in. Lake Baikal, by contrast, has been collecting water since before the ancestors of modern humans diverged from other great apes. The biological consequences of having so much ancient freshwater concentrated in one location are equally remarkable. Lake Baikal contains over 1,700 species of plants and animals, 2/3 of which are found nowhere else on Earth. The Baikal seal is one of only 2 freshwater seal species in existence, a marine mammal that somehow ended up in the middle of Siberia and stayed. The lake's food chain depends on tiny crustaceans called Episcura that filter the water with extraordinary efficiency, keeping Baikal's waters among the clearest of any lake on the planet. On a clear winter day, you can see objects 40 meters below the surface, deep enough to make out details on a shipwreck or the shape of a swimming seal. The Amazon River presents another case where the numbers seem to have been invented by someone trying to impress rather than inform. By volume of water discharge, the Amazon is not merely the largest river in the world, it is larger than its 7 nearest competitors combined. Its average discharge of roughly 215,000 to 230,000 cubic meters per second represents approximately 20% of all river water entering the world's oceans. Every second, the Amazon delivers more fresh water to the Atlantic than most rivers deliver in minutes. The Mississippi, Nile, and Yangtze, 3 of the world's most famous rivers, could combine their flows and still not match the Amazon's output. The practical consequences of this volume are visible far out to sea. Ships sailing in the Atlantic Ocean more than 160 kilometers from the Amazon's mouth can still lower buckets over the side and retrieve drinkable fresh water. The massive plume of river water pushes so far into the ocean that it creates its own distinct ecosystem, reducing salinity levels and supporting marine life adapted to brackish conditions. Scientists have even discovered coral reefs thriving in the Amazon's plume, a finding that seemed impossible given how much rivers typically discourage reef formation through their sediment loads and freshwater discharge. The Amazon's width varies dramatically with the seasons, but during wet periods it can expand to nearly 30 miles across, earning it the nickname the River Sea. At certain points, standing on one bank, you cannot see the opposite shore. The flooding that occurs annually submerges an additional 140,000 square miles of rainforest, creating a complex aquatic environment where fish swim among treetops and dolphins navigate what was dry land mere months earlier. The river has no bridges along its entire length, partly because of the practical difficulties of spanning such enormous widths, and partly because the populations on either side have never developed enough infrastructure to justify the expense. Yet even the Amazon's scale pales in comparison to some oceanic currents. The Denmark Strait overflow, that invisible underwater waterfall we discussed earlier, moves approximately 175 million cubic meters of water per second. roughly equivalent to 2,000 Amazon rivers flowing simultaneously. The global oceanic conveyor belt, that vast system of currents that distributes heat around the planet, moves water volumes that make even the Amazon seem like a garden hose by comparison. Fresh perspectives on scale emerge constantly the further you investigate. Population comparisons offer yet another category of mind-bending statistics. California, that single American state famous for Hollywood, Silicon Valley, and an apparent inability to avoid catching fire every summer, has a population of approximately 39 million people. This is more people than live in Poland, more than Canada, more than Australia, more than all of Scandinavia combined. A single state in one country contains more human beings than many entire nations that occupy far more geographical territory. The comparison with Canada is particularly striking because of how differently the two territories are distributed. Canada spans 9.98 million square kilometres, making it the second largest country on Earth. California occupies merely 423,970 square kilometres, roughly 4% of Canada's size. Yet for most of modern history, California's population exceeded Canada's. Only recently, driven largely by aggressive immigration policies that have added roughly 1 million people per year to Canada's population, has the northern country pulled ahead of the single American state. Even so, the populations remain remarkably close, with Canada's 41 million only marginally exceeding California's 39 million. The geographical distribution of these populations could hardly be more different. California's residents spread across a diverse terrain of coastlines, mountains, valleys, and deserts, concentrated heavily in major metropolitan areas like Los Angeles and San Francisco. Canada's population, by contrast, huddles within roughly 100 miles of the American border, leaving the vast majority of the country effectively uninhabited. Approximately 90% of Canadians live in that narrow southern strip, meaning the remaining 10% of the population occupies an area larger than the entire European Union. The frozen tundra, endless forests, and scattered northern communities that fill Canadian maps represent more empty space than most nations could imagine. This concentration of population in relatively small areas is not unique to Canada. Russia, despite its massive territorial extent, has a population of only 144 million, roughly comparable to the population of California, Texas, and New York combined. Australia's 26 million people could fit comfortably into a mid-sized Chinese city. These apparent contradictions between geographical and demographic scale reveal something important about how human settlement patterns work. People cluster where the conditions favour survival, near coastlines with temperate climates, along river valleys with fertile soil, in regions where winter temperatures do not routinely kill exposed human beings within hours. The result is a world where population density varies by orders of magnitude between regions. Bangladesh, a country smaller than Iowa, contains roughly 170 million people, making it one of the most densely populated nations on Earth. Mongolia, by contrast, has fewer than 4 million people spread across 1.56 million square kilometres, giving it one of the lowest population densities of any country. You could theoretically walk for days across the Mongolian steppe without encountering another human being. You cannot walk for 5 minutes in Dhaka, Bangladesh's capital, without becoming intimately familiar with several dozen of your fellow citizens. These density variations create peculiar situations where urban areas contain more people than entire countries. The Greater Tokyo metropolitan area, with its 37 million residents, has a larger population than Canada, Australia, Poland, Venezuela, Malaysia, Peru, Afghanistan, or any of roughly 180 other sovereign nations. If Tokyo were a country, it would rank roughly 35th in the world by population, just behind Poland and ahead of Algeria. The city occupies a fraction of Japan's territory, but contains nearly a third of the nation's population, concentrated into apartment buildings, subway cars, and the world's most patient pedestrian crossing formations. Similar dynamics play out in other megacities. São Paulo's metropolitan area contains more people than the entirety of Portugal, the country that colonized Brazil in the first place. Istanbul straddles 2 continents and contains more residents than roughly 70 individual nations. Shanghai's 29 million people exceed the populations of Australia and New Zealand combined. These urban concentrations represent something genuinely new in human history. For most of our species' existence, no single settlement contained more than a few thousand people. Now, individual neighborhoods in major cities house populations that would have constituted respectable empires in previous millennia. The historical comparisons emphasize just how dramatically human numbers have changed. At the peak of the Roman Empire, the entire world population was roughly 300 million people. Fewer than currently live in the United States alone. When Christopher Columbus reached the Americas in 1492, the global population was approximately 500 million, roughly equal to the current population of the European Union. The world's population did not reach 1 billion until around 1800, meaning every human who ever lived before that point was part of a global community smaller than India's current population. The acceleration since then has been extraordinary, reaching 2 billion by 1927, 3 billion by 1960, 4 billion by 1974, 5 billion by 1987, 6 billion by 1999, 7 billion by 2011, and 8 billion by 2022. These numbers are so large that they lose meaning without context. 8 billion is approximately the number of stars visible in the night sky, multiplied by a factor of roughly 4,000. If you tried to count to 8 billion at a rate of one number per second, it would take you approximately 253 years, assuming you never slept, ate, or took breaks to question your life choices. If 8 billion people stood in a line with their arms outstretched fingertip to fingertip, the line would stretch approximately 14.5 million kilometers, enough to wrap around Earth's equator roughly 362 times, or to reach a third of the way to Mars. At its closest approach, the resources required to sustain this population are equally incomprehensible. Humanity collectively consumes roughly 580 million metric tons of meat per year, requiring livestock populations that outnumber humans by factors of 2 or 3 depending on the species. We extract approximately 4.5 billion metric tons of oil annually, enough to fill Lake Superior every 3.5 years if we decided to do something that inadvisable. Global freshwater consumption exceeds 4 trillion cubic meters per year, a volume that would drain Lake Baikal in roughly 6 years if we somehow decided to use only that single source. And yet, despite these staggering numbers, human beings still occupy a surprisingly small fraction of Earth's surface. All 8 billion of us could fit standing shoulder to shoulder within the city limits of Los Angeles. If we gave each person slightly more space, say 1 square meter each, the entire human population would fit within a single large city's boundaries. The perception that the planet is overcrowded reflects not the actual density of human presence, but rather the concentration of our activities in specific areas and our remarkably efficient ability to extract resources from vast territories we never actually occupy. The infrastructure supporting modern civilization spans distances that would have seemed mythological to previous generations. The global network of submarine telecommunications cables stretches approximately 1.4 million kilometers along the ocean floor, enough to circle Earth's equator 35 times. These hair-thin strands of fiber optics carry roughly 99% of intercontinental data traffic, meaning nearly every email, video call, financial transaction, and cat video crossing. An ocean travels through cables thinner than garden. Hoses lying on the seabed. The entire infrastructure of global digital communication depends on physical objects that most people have never seen and could not locate on a map. Pipeline networks are equally extensive. Russia alone has approximately 260,000 kilometers of pipelines for oil, natural gas and related products, enough to circle Earth 6.5 times. The global pipeline network stretches for millions of kilometers, a subterranean and submarine circulatory system pumping hydrocarbons to power stations, refineries, and industrial facilities across the planet. If you somehow illuminated every pipeline on Earth simultaneously, the network would be visible from space, a web of glowing lines connecting production sites to consumption centers across continents and oceans. Transportation statistics reveal similar scales of activity. Commercial aviation operates roughly 100,000 flights per day, carrying approximately 5 million passengers across the planet daily. At any given moment, roughly 500,000 people are airborne, suspended in aluminum tubes at altitudes where unprotected humans would lose consciousness within seconds. The global fleet of automobiles exceeds 1.4 billion vehicles, enough cars that if parked bumper to bumper, they would form a line stretching from Earth to the Moon and back again, with enough remaining to circle the planet several times at the equator. shipping moves the physical goods that make modern life possible. Approximately 50,000 merchant vessels traverse the oceans at any given moment, carrying 11 billion metric tons of cargo annually. The largest container ships can carry over 24,000 20-foot equivalent units, containers that would stretch for roughly 145 kilometers if laid end to end. A single large container ship delivers more cargo in one voyage than the entire British Empire managed to transport across the Atlantic in a typical year during the 16th century. The scale of modern logistics would have appeared supernatural to merchants who spent weeks calculating how to fill a single sailing vessel's hold. Construction and engineering achievements demonstrate similar expansions of scale. The amount of concrete produced annually now exceeds the total amount produced in the entire 19th century. Humans move more earth through construction activities than all the world's rivers combined move through natural erosion. We have created artificial islands, diverted rivers, and leveled mountains to build infrastructure that serves our needs, reshaping the planet's surface in ways that will be visible in the geological record for millions of years. These comparisons ultimately serve to highlight both the achievements and the limitations of human perception. Our brains evolved to operate at scales appropriate for small hunter-gatherer bands navigating territories measured in dozens of square kilometers. We are not naturally equipped to comprehend millions, billions, or trillions of anything. We cannot intuitively grasp the difference between a million and a billion any more than we can distinguish between a billion and a trillion. They all register simply as very large numbers that exceed our cognitive processing capacity. Maps were invented precisely to help us overcome these limitations, to compress geographical information into formats our limited minds could process. But the very act of compression introduces distortions that shape how we think about the world. The Mercator projection that inflates Greenland and shrinks Africa is not merely a technical curiosity. It has influenced how generations of people understood which parts of the world mattered most. The population statistics that show California rivaling Canada or Tokyo exceeding Portugal reshape our understanding of political and economic power. The water volumes that reveal Lake Baikal's dominance or the Amazon's supremacy alter how we think about resource distribution and environmental vulnerability. The numbers themselves are neutral, mere measurements of physical reality. But how we present them, compare them, and contextualize them shapes how billions of humans understand the planet they inhabit. A world where Africa appears smaller than Greenland is psychologically different from one where Africa's true dominance is visible at a glance. A world where Russia seems to extend forever across the northern horizon creates different impressions than one where that same territory is compared to a dwarf planet roughly equal in size. Scale is not just about numbers, it is about meaning, about how we position ourselves relative to the planet and the cosmos beyond. The journey through these comparisons reveals both how much we know and how much remains beyond our intuitive grasp. We can measure the Amazon's discharge to the cubic meter per second, map Lake Baikal's depths to the centimeter, and calculate Pluto's surface area to the square kilometer. Yet these precise numbers fail to convey the experiential reality of standing beside a river that appears to have no opposite bank, or diving into water so clear you can see 40 meters down, or contemplating a country so large that the sun never sets on all of it simultaneously. The numbers describe, they do not capture. Perhaps that is why these comparisons retain their power to surprise. We encounter the statistics, process them intellectually, acknowledge their truth, and yet still feel a jolt of disbelief when we see the visual demonstration. Yes, we knew Africa was larger than Greenland, but seeing them side by side at true scale still produces a reaction. Yes, we understood California had many people, but learning it rivals an entire nation still provokes wonder. Yes, we accepted that water volumes varied enormously, but discovering that one lake holds a fifth of the planet's accessible freshwater still strains credulity. This capacity for surprise at facts we already know suggests something important about human cognition. We operate with multiple models of reality simultaneously. The intuitive model shaped by daily experience and visual impressions, and the intellectual model constructed from data and analysis. These models frequently contradict each other, and the contradictions produce the cognitive dissonance that makes scale comparisons feel surprising even when they reveal nothing technically new. We knew the numbers, we simply had not updated our intuitive understanding to match. The world we inhabit is simultaneously far larger and far smaller than it appears. Larger because single countries span the surface areas of planets, because single lakes hold enough water to sustain civilizations, because single cities contain populations exceeding those of most nations. Smaller because all 8 billion of us could fit within one metropolitan area, because our entire species occupies a thin film on the surface of one modest planet, because the infrastructure connecting our global civilization would fit within vanishingly small fractions of the spaces it serves. Learning to hold both scales in mind simultaneously, the vastness and the modesty, the incomprehensible numbers and the comprehensible implications, may be essential to navigating the challenges ahead. The problems facing humanity operate at scales our ancestors could not have imagined. Climate systems spanning the entire atmosphere, economic networks connecting every inhabited continent, communication systems linking billions of minds in real time. Conversations. Addressing these challenges requires thinking at scales for which evolution did not prepare us, using cognitive tools that strain under the weight of the numbers involved. The maps we consult, the statistics we cite, the comparisons we draw all shape how well we rise to that challenge. A world that understands Africa's true scale thinks differently about African affairs than one that has internalized Mercator's diminishment. A population that grasps how much fresh water Lake Baikal contains approaches water management differently than one that has never encountered the statistic. A civilization that recognizes California and Canada as demographically comparable makes different assumptions about political and economic power than one operating with outdated mental models. Scale, in the end, is not merely about numbers. It is about perspective, about understanding where we fit in a universe that operates across ranges far exceeding human intuition. From the gravitational anomalies that bend physics in Hudson Bay, to the underwater waterfalls that dwarf any cascade on land, from the hidden continents lurking beneath Pacific waves, to the deadly waters that dissolve unwary swimmers, our planet consistently reveals itself to be stranger and more extreme than the simplified versions taught in elementary school. The numbers that describe these extremes are not abstractions. They are measurements of realities that shape everything from geopolitics to personal experience. The next time you glance at a world map, perhaps you will see it differently. The familiar shapes, learned in childhood and reinforced through decades of casual observation, will flicker between their distorted representations and their truer proportions. Greenland will seem to shrink, Africa will seem to expand, Russia will hover somewhere between nation and planet. The numbers you have encountered here will lurk behind the colours and boundaries, reminding you that what you see depends enormously on who drew the map and what they wanted you to understand. Timescales offer another dimension where human intuition fails spectacularly. Lake Baikal, at 25 to 30 million years old, has been collecting water since long before the Mediterranean Sea existed in its current form. The Mediterranean is a relative newcomer, having filled with water only about 5.3 million years ago, when the Atlantic broke through the Strait of Gibraltar in an event known as the Zanclean Flood. Before that, the Mediterranean basin was a desert, occasionally dotted with salt lakes, but mostly dry and inhospitable. The water that currently makes up one of the world's most famous bodies of water arrived essentially yesterday in geological terms, flooding in over a period that may have been as short as a few thousand years. The Atlantic Ocean itself is considerably younger than Lake Baikal. The Atlantic began forming roughly 180 million years ago, when the supercontinent Pangaea started rifting apart. But the opening process was gradual, with the ocean widening at approximately the same rate your fingernails grow. The Amazon River, which now pours such extraordinary volumes of water into the Atlantic, once flowed in the opposite direction, emptying into the Pacific before the Andes rose and forced the drainage pattern to reverse. The Amazon as we know it has existed for only about 11 million years, making it less than half as old as Lake Baikal despite being far more famous. These temporal comparisons extend to human constructions as well. The Great Wall of China, that iconic structure supposedly visible from space, actually cannot be seen from orbit with the naked eye, no matter how many well-meaning teachers have claimed otherwise. The wall is impressively long, but not particularly wide, and from space it appears no more visible than any other road or structure. At roughly 21,196 kilometers in total length, when including all branches and parallel sections, however, it represents one of the longest structures ever built, approximately the distance from London to Sydney, via a particularly indirect route. The total length of paved roads on Earth exceeds 64 million kilometers, enough to reach Mars at its closest approach roughly 140 times. If you drove continuously at highway speeds across all the world's paved roads, stopping only for fuel, the journey would take approximately 73 years. The unpaved roads add many more millions of kilometres, though nobody has precisely catalogued them all. Every day, new roads are paved while others deteriorate beyond usability, making the global road network a constantly shifting infrastructure whose total extent can only be estimated. Railway networks present similar scale challenges. The total length of railway tracks in the world exceeds 1.3 million kilometres, enough to circle Earth's equator roughly 32 times. China alone has added roughly 40,000 kilometres of high-speed rail in the past 2 decades, creating a network that did not exist in any meaningful sense before 2008, and now carries more passengers than the aviation networks of most countries. A Chinese citizen today can travel from Beijing to Guangzhou, a distance of roughly 2,300 kilometres, in about 8 hours by train. The same journey by horse in Imperial China took weeks or months, depending on weather, bandits, and the traveller's tolerance for discomfort. These transportation comparisons emphasize how dramatically modern technology has compressed perceived distances. In 1500, a message from Europe to Asia might take a year or more to arrive, travelling by ship around Africa or by overland caravans across the Silk Road. Today, the same message arrives in milliseconds, limited only by the speed of light through fibre optic cables and the processing delays of routing equipment. The world has not shrunk physically, but it has shrunk experientially, with consequences for everything from commerce to conflict to cultural exchange. The energy comparisons prove equally humbling. The Sun delivers approximately 173,000 terawatts of solar power to Earth continuously, of which humanity currently captures roughly 1 terawatt through solar panels and related technology. This means we harvest about 0.0006% of available solar energy, leaving the remaining 99.9994% to heat the atmosphere, drive weather patterns, support photosynthesis, and generally keep the planet habitable. The total energy consumed by human civilization annually, from all sources combined, represents roughly what the Sun delivers to Earth in about 90 minutes. We are not energy limited in any fundamental sense. We are merely limited by our ability to capture and store what arrives freely every day. Biological scales present their own challenges. The total number of bacteria on Earth exceeds the number of stars in the observable universe by a factor of roughly 1,000. Your own body contains approximately 38 trillion bacterial cells, slightly more than the 30 trillion human cells that constitute your organs and tissues. You are, in a very real sense, more bacterial than human by cell count, though the human cells are considerably larger and account for most of your mass. The microbial ecosystem within your gut alone contains more genetic diversity than the entire human genome, hosting species that have evolved specifically to exploit the ecological niche you provide. Insect populations dwarf even bacterial counts in terms of individual organisms visible to the naked eye. Scientists estimate that roughly 10 quintillion insects exist on Earth at any given moment, which works out to approximately 1.25 billion insects for every human being. Ants alone likely number in the quadrillions, with their combined biomass potentially exceeding the combined biomass of all humans. The weight of all the ants in the world is roughly equal to the weight of all the humans, despite individual ants weighing roughly 1 million times less than individual humans. There are simply that many more of them. These biological numbers raise questions about what it means to dominate a planet. Humans have modified more of Earth's surface than any other species, redirected more fresh water, caused more extinctions, and generally made ourselves the most influential force in the biosphere. Yet by simple population counts, we are vastly outnumbered by creatures we barely notice, and could not eliminate if we tried. The bacteria will outlast us regardless of what we do to the planet. They have survived 5 mass extinctions already, and show every sign of surviving a 6th if we manage to trigger one. Geological timescales make even human civilization seem ephemeral. The oldest known rocks on Earth date to roughly 4 billion years ago, formed when the planet was still cooling from its violent formation. The earliest evidence of life appears around 3.5 billion years ago, meaning biological processes have been operating on Earth for roughly 78% of its existence. Modern humans, by contrast, have existed for roughly 300,000 years, representing about 0.007% of Earth's history. If Earth's history were compressed into a single 24-hour day, modern humans would appear in the final 6 seconds before midnight. The comparisons grow more humbling the further back you look. Dinosaurs dominated the planet for roughly 165 million years, more than 500 times longer than modern humans have existed. The age of mammals has lasted only 66 million years so far, and there is no guarantee it will continue. The conditions that allowed large-brained primates to evolve and eventually develop technology represent a tiny slice of Earth's history, a window that opened recently and could close for reasons entirely beyond our control. And yet, despite our brief existence and modest numbers compared to bacteria and insects, humans have achieved something genuinely unprecedented. We have measured the distances to stars, calculated the age of the universe, and sent robotic explorers to the outer reaches of the solar system. We have sequenced our own genome, photographed the nuclei of atoms, and communicated across continental distances in real time. The scale of our knowledge vastly exceeds the scale of our existence, a fact that might be either inspiring or terrifying depending on your perspective. And perhaps that is the most important lesson these comparisons offer. Reality exists independently of how we represent it, but our representations shape how we think about reality. The maps we choose, the statistics we emphasize, the comparisons we draw, all construct the mental worlds within which we operate. Understanding the gaps between representation and reality, between intuition and measurement, between what we think we know and what the numbers actually show, is essential to navigating a planet whose true proportions continue to surprise even those who have studied it their entire lives. Our planet, it turns out, has been running its own special effects department for billions of years, and frankly, Hollywood should be taking notes. While humans have spent centuries perfecting stage lighting, pyrotechnics, and computer-generated imagery, Earth has been quietly producing light shows that make our best efforts look like someone waving a flashlight in a dark room. From perpetual lightning storms that have been flashing for millennia to beaches that glow like something from a science fiction film, our world contains illumination phenomena so spectacular that if you described them to someone who had never seen evidence, they would assume you were either lying or had consumed something questionable. The universe, it seems, has a flair for the dramatic, and our little blue planet serves as one of its more impressive stages. Consider for a moment what it would take for a film studio to recreate what nature accomplishes nightly in various corners of the globe. You would need teams of electricians, miles of wiring, sophisticated computer systems, and a budget that would make studio executives weep into their spreadsheets. Nature, meanwhile, accomplishes these feats using nothing more than atmospheric conditions, microscopic organisms, chemical reactions, and the occasional contribution from space. The setup costs are zero, the maintenance requirements are handled automatically, and the shows have been running continuously for periods that make even the longest Broadway production look like a brief intermission. Earth, unsurprisingly, does not charge admission, though getting to some of these natural theatres can cost you a small fortune in airfare and guided tours. The phenomenon that perhaps best illustrates Earth's commitment to theatrical excess occurs in northwestern Venezuela, where the Catatumbo River empties into Lake Maracaibo. Here, in a region that the indigenous Bari people appropriately named the House of Thunder, nature has been running what might be the world's longest continuous light show. The Catatumbo lightning, as this spectacular display is known, illuminates the sky approximately 260 nights per year, with storms that can rage for up to 10 hours at a stretch and produce lightning flashes at a rate that would make any disco ball operator feel inadequate. We are talking about up to 28 flashes per minute during peak activity, which translates to roughly 1 bolt every 2 seconds for hours on end. If you have ever complained about a thunderstorm keeping you awake for an hour, imagine living in a region where the electrical activity essentially never stops from sundown to sunrise for most of the year. The statistics surrounding Catatumbo lightning are the sort that make you double-check your sources because they seem too extraordinary to be accurate. NASA satellites have confirmed that Lake Maracaibo receives approximately 233 lightning flashes per square kilometre per year, making it the most electrically active location on the planet by a considerable margin. The second-place finisher, a region in the Democratic Republic of Congo, manages only about 205 flashes per square kilometre annually, which sounds impressive until you realise it is being thoroughly outperformed by a Venezuelan lake. 10 minutes of Catatumbo lightning, according to calculations by atmospheric scientists, could theoretically illuminate all of South America. The phenomenon produces an estimated 1.2 million lightning bolts annually, concentrated in an area small enough that you could theoretically watch the entire show from a well-positioned boat. This is not a storm that occasionally passes through. This is a permanent atmospheric installation. The mechanism behind this perpetual electrical storm involves a confluence of geographical factors that would be nearly impossible to replicate elsewhere. Lake Maracaibo sits in a basin surrounded on three sides by mountain ranges, including segments of the Andes, the Perijá Mountains, and the Mérida Cordillera, which rise to heights exceeding 12,000 feet. This horseshoe arrangement creates what amounts to a natural amphitheatre for weather formation. During the day, the intense tropical sun heats the lake's surface, causing enormous quantities of water to evaporate into the atmosphere. As evening approaches, cool air descends from the surrounding mountains and collides with the warm, moisture-laden air rising from the lake. This collision of contrasting air masses triggers the formation of massive cumulonimbus clouds that essentially become lightning factories. The process repeats with such reliability that sailors have been using the phenomenon as a navigational aid for centuries, earning it the nickname Lighthouse of Maracaibo, or Beacon of Maracaibo. The historical significance of this natural lighthouse proves surprisingly extensive. Italian geographer Agustin Codazzi, who mapped the region in the 1840s, described the phenomenon as like a continuous lightning, and its position such that, located almost on the meridian of the mouth of the lake, it directs the navigators as a lighthouse. Spanish and Portuguese colonial sources referred to it as the Lanterns of St. Anthony, which suggests that even in an era of religious explanations for natural phenomena, people recognized its practical utility for maritime navigation. The lightning is visible from up to 400 kilometers away on clear nights, meaning ships in the Caribbean Sea could orient themselves by looking for the perpetual glow on the southern horizon. In an age before GPS, radar, and electronic navigation systems, having a natural beacon that operated 260 nights per year represented a significant advantage for anyone trying to find their way to the important ports of Maracaibo and Cabimas. The Catatumbo lightning even played a role in military history, though not always in favour of those attempting surprise attacks. In 1595, English privateer Francis Drake attempted a nighttime raid on the city of Maracaibo, presumably hoping that darkness would conceal his approaching fleet. The lightning, unfortunately for Drake, had other plans. The continuous flashes illuminated his ship's silhouettes against the water, alerting the garrison to his presence and spoiling the element of surprise. Spanish poet Lope de Vega immortalized this incident in his 1597 epic poem The Dragontea, describing how flames, which the wings of night cover, revealed the English privateers to the defending forces. The lightning apparently held no particular loyalty to colonial powers, however, because in 1823, during the final naval battle of Venezuela's War of Independence, the same phenomenon illuminated the positions of Spanish ships, allowing Admiral José Prudencio Padilla's fleet to secure a decisive victory. The storm, it seems, was an equal opportunity spoiler of military tactics. Scientists have proposed various theories to explain why this particular location produces such exceptional lightning activity. Early hypotheses suggested that uranium deposits in the bedrock might somehow be responsible, which would have been a remarkable geological coincidence. Later studies in the late 1990s proposed that methane emissions from the massive oil deposits beneath Lake Maracaibo might increase the electrical conductivity of the atmosphere, essentially providing additional fuel for the lightning storms. The Maracaibo Basin sits atop one of South America's largest petroleum reserves, and methane does occasionally bubble to the lake's surface in visible quantities. However, subsequent research has cast doubt on the methane hypothesis, noting that it would predict more lightning activity during the dry season when methane concentrations are higher, whereas the actual peak occurs during the wetter months of September and October. The current scientific consensus attributes the phenomenon primarily to the unique topographical and meteorological conditions, rather than any exotic underground chemistry. The Catatumbo lightning experienced a concerning interruption in early 2010, when the storms ceased entirely for approximately 6 weeks between January and March. This disappearance, apparently caused by an El Niño-driven drought that reduced the moisture available for storm formation, sparked genuine alarm among local residents and scientists alike. The phenomenon had been so reliable for so long that its sudden absence felt almost apocalyptic to communities who had grown up with the nightly light show as a constant feature of their environment. Fortunately, the lightning returned once weather patterns normalized, though the incident served as a reminder that even seemingly eternal natural phenomena depend on specific conditions that climate change could potentially disrupt. The Venezuelan government has been pursuing UNESCO World Heritage status for the Catatumbo lightning, which would make it the first atmospheric phenomenon to receive such designation, though the bureaucratic process for recognizing weather as a cultural treasure has proven predictably complex. While Catatumbo represents nature's most impressive high-altitude light show, some of Earth's most enchanting illumination occurs at sea level, where the ocean itself appears to glow with an ethereal blue radiance. Bioluminescent bays and beaches found in scattered locations around the world create scenes that look like they were designed by the visual effects team of a fantasy film franchise. The Maldives, an archipelago of over 1,000 islands in the Indian Ocean, has become particularly famous for beaches that appear to be covered in glowing stars when visited after dark. Walking along the shoreline at night, each footstep ignites a burst of blue light in the wet sand, and waves breaking on the beach leave trails of luminescence that fade slowly back to darkness. The effect is so surreal that visitors often initially assume they are witnessing some kind of artificial display before realizing that billions of microscopic organisms are responsible for the magic. The creatures creating this bioluminescent display are dinoflagellates, single-celled organisms that occupy the fascinating taxonomic position of being neither fully plant nor fully animal. These organisms, known scientifically by names like Lingulodinium polyedrum and Pyrodinium bahamense, possess the ability to produce light through a chemical reaction involving a compound called luciferin. When dinoflagellates are disturbed by physical agitation, whether from wave action, a swimming fish, a paddling kayaker, or a human foot stepping into wet sand, they emit a brief flash of blue-green light. The biological purpose of this light production appears to be defensive. The sudden illumination may startle predators or attract larger predators that will eat the dinoflagellate's attackers. Evolution, it seems, invented the biological equivalent of turning on a porch light to scare away intruders long before humans developed the concept. Puerto Rico holds the distinction of hosting the world's brightest bioluminescent bay, Mosquito Bay, on the island of Vieques, which received official Guinness World Record recognition in 2006. The name, incidentally, refers to a pirate ship called El Mosquito that allegedly hid in the bay during the colonial era, rather than to any unusual concentration of biting insects, which is good news for visitors hoping to enjoy the glow without becoming a buffet. Mosquito Bay contains an estimated 700,000 to over 2 million dinoflagellates per gallon of water, concentrations so dense that the glow is visible not just when the water is disturbed, but sometimes as a general ambient luminescence throughout the bay. Scientists attribute the bay's exceptional brightness to a perfect combination of factors including shallow water, a narrow entrance that prevents the organisms from washing out to sea, surrounding mangrove forests that provide nutrients, and minimal light pollution that allows the glow to be visible. Puerto Rico actually hosts 3 separate bioluminescent bays, making it something of a world capital for glowing water tourism. The experience of paddling a kayak through a bioluminescent bay at night defies easy description. Each stroke of the paddle creates a burst of light that trails behind the blade like blue fire, while the kayak's hull leaves a glowing wake that slowly fades into darkness. Fish swimming beneath the surface appear as torpedoes of light, their movements traced in luminescent trails. Dipping your hand into the water and watching droplets fall back, as glowing pearls creates the distinct impression that you have somehow entered a world where different physical laws apply. The effect is strongest on moonless nights, when the absence of ambient light allows the bioluminescence to truly dominate the visual field. Tour operators in bioluminescent locations universally advise visitors to avoid sunscreen, insect repellent, and other chemical products that can harm the delicate organisms responsible for the display, which creates the interesting challenge of visiting a tropical location at night without the usual protective measures. The chemistry behind bioluminescence follows a relatively simple formula that nature has reinvented numerous times across the evolutionary tree. The light-producing reaction requires luciferin, a molecule that releases energy in the form of light when it reacts with oxygen, in the presence of the enzyme luciferase. Different organisms produce slightly different versions of these compounds, which accounts for the variation in bioluminescent colours across species, though the blue-green range predominates in marine environments, because these wavelengths travel most efficiently through water. The reaction is sometimes called cold light, because it produces almost no heat, making it remarkably efficient compared to human lighting technologies. A traditional incandescent light bulb converts only about 5% of its electrical input into visible light, with the rest becoming waste heat. Bioluminescent organisms achieve efficiency rates approaching 100%, which means that after billions of years of evolution, fireflies and glowing plankton have developed lighting technology that human engineers still cannot match. At the opposite end of the aesthetic spectrum from the ethereal blue glow of bioluminescent beaches sits one of Earth's most startling geological features, blood falls in Antarctica. Located at the terminus of Taylor Glacier in the McMurdo Dry Valleys, this phenomenon appears exactly as its name suggests, a flow of bright red liquid pouring from the ice face onto the frozen surface of Westlake Bonny below. The sight is so unexpected and so vividly coloured that early explorers who encountered it must have wondered whether they had stumbled upon evidence of some enormous subglacial creature meeting a violent end. The reality, while less dramatic than wounded ice monsters, proves no less fascinating from a scientific perspective. Australian geologist Thomas Griffith Taylor first documented bloodfalls in 1911 during the ill-fated Terra Nova expedition, the same British Antarctic venture that would end in tragedy for expedition leader Robert Falcon Scott and his polar party. Taylor initially attributed the red coloration to algae, a reasonable hypothesis given that various microorganisms can produce reddish pigments. This explanation persisted for several decades until researchers discovered that the actual cause was far more interesting than microscopic plants. The crimson colour results from iron-rich water emerging from beneath the glacier, water that has been trapped and isolated from the outside world for an estimated 2 million years. When this ancient brine, loaded with dissolved ferrous iron, contacts the oxygen in Earth's atmosphere for the first time in geological ages, the iron rapidly oxidizes, essentially rusting before your eyes and staining the ice a vivid blood red. The source of bloodfalls is a subglacial lake sealed beneath approximately 400 metres of ice, a body of water that was cut off from the rest of the world when the Taylor Glacier advanced over it during a past ice age. The lake's water is approximately 3 times saltier than seawater, a concentration high enough to prevent freezing even at temperatures well below the normal freezing point of fresh water. This hypersalinity developed through a process called cryoconcentration, where ice forming at the top of the trapped water expelled dissolved salts into the remaining liquid, gradually increasing the salt concentration over millions of years. The same process that makes sea ice less salty than the seawater from which it forms has been operating in this sealed environment since before humans existed, creating conditions that would be lethal to most forms of life. Most forms of life, but not all. Researchers studying water samples from bloodfalls have discovered a thriving community of extremophile bacteria living in complete darkness, without access to oxygen, at temperatures that would kill any organism accustomed to more hospitable conditions. These microbes have evolved to survive by chemosynthesis rather than photosynthesis, extracting energy from chemical reactions involving sulfur and iron compounds rather than sunlight. The discovery of life surviving under such extreme conditions has significant implications for astrobiology, the study of potential life elsewhere in the universe. If bacteria can thrive in a frozen, sunless, oxygen-free environment sealed beneath Antarctic ice for millions of years, similar organisms might exist beneath the ice-covered surfaces of Europa, Enceladus, or other moons in our solar system. Bloodfalls, in other words, may serve as a terrestrial analogue for conditions on worlds where scientists hope to one day search for extraterrestrial life. The mechanism by which water from the subglacial lake reaches the surface at bloodfalls involves a complex network of channels and fissures within the glacier itself. Unlike most glaciers, where meltwater comes from ice thawing at the surface, Taylor Glacier is cold enough that virtually no surface melting occurs. Instead, the salty brine trapped beneath the ice maintains itself in liquid form through a combination of its extreme salinity and the latent heat released when portions of it freeze. This freezing actually warms the surrounding ice slightly, creating pathways through which liquid water can migrate toward the glacier's terminus. The flow is sporadic rather than continuous, with the red water emerging in periodic pulses that scientists are still working to fully understand. The The phenomenon represents one of the coldest environments on Earth where liquid water consistently flows, a distinction that would seem paradoxical if the chemistry were not so elegantly suited to the purpose. Moving from the frozen Antarctic to the upper reaches of Earth's atmosphere, we encounter light shows of an entirely different character in the form of auroras, the northern and southern lights that have captivated human observers for millennia. These luminous displays, appearing as curtains, ribbons, and waves of coloured light dancing across polar skies, result from a direct connection between our planet and the Sun, a reminder that Earth exists not in isolation, but as part of a dynamic solar system where energy and matter flow continuously between celestial bodies. The aurora borealis in the north and aurora australis in the south represent the visible evidence of our planet's magnetic field protecting us from the harsh radiation environment of space, a shield that we rarely think about but without which life, as we know it could not exist. The process that creates auroras begins approximately 93 million miles away, on the surface of the Sun, where temperatures exceeding 5,500 degrees Celsius maintain a constant state of nuclear fusion and violent activity. The Sun continuously emits a stream of charged particles, primarily electrons and protons, known as the solar wind. This particle flow carries tremendous energy and would be extremely dangerous to any life exposed to it directly. Fortunately, Earth generates its own magnetic field through the circulation of molten iron in its outer core, and this magnetic field deflects most of the solar wind around the planet like water flowing around a rock in a stream. However, some particles manage to enter the magnetic field at weak points near the poles, where the field lines converge and dip toward Earth's surface. These particles then stream down through the atmosphere, colliding with gas molecules as they descend. The colours of an aurora depend entirely on which atmospheric gases the solar particles strike and at what altitude the collisions occur. Oxygen atoms at altitudes between 100 and 300 kilometres produce the green light most commonly associated with auroral displays, while oxygen at higher altitudes generates rarer red emissions. Nitrogen molecules produce blue and purple hues, adding complexity to displays that can include virtually every colour in the visible spectrum depending on conditions. The movements and patterns of auroras result from variations in the flow of particles along magnetic field lines, creating the impression of curtains rippling in an invisible wind or rivers of light flowing across the sky. The phenomenon can be so bright that it casts shadows on the ground below, and so dynamic that observers sometimes describe it as dancing or performing, rather than merely existing as a static display. Ancient cultures developed numerous explanations for the aurora, many of which attributed the lights to supernatural causes. Norse mythology held that the lights represented the gleaming armour of the Valkyries, warrior maidens who escorted fallen heroes to Valhalla. The Sami people of northern Scandinavia called the phenomenon Govsahus, meaning the light that you can hear, referring to a long-held belief that auroras produce audible sounds. This belief was dismissed by scientists for centuries as psychological suggestion or wishful thinking, until recent research at Aalto University in Finland actually recorded crackling and popping sounds associated with auroral displays. The sounds appear to result from electrical discharges in a temperature inversion layer approximately 80 metres above the ground, validating traditional knowledge that modern science had prematurely rejected. Galileo Galilei coined the term aurora borealis in 1619, combining the name of the Roman goddess of dawn, Aurora, with the Greek god of the north wind, Boreas. The choice of the dawn goddess seems slightly peculiar for a phenomenon that occurs at night, but early European observers at lower latitudes often saw auroras only as a faint red glow on the northern horizon, resembling the colours of sunrise or sunset. The true spectacular nature of polar auroras requires travelling to latitudes within or near the auroral oval, the ring-shaped zone centred on the magnetic poles where particles most frequently enter the atmosphere. This zone typically lies between 65 and 72 degrees latitude, encompassing northern regions of Canada, Alaska, Scandinavia, Iceland and Russia in the northern hemisphere. During periods of high solar activity, however, auroras can extend much farther from the poles, occasionally becoming visible from locations as far south as the Mediterranean or the southern United States. Solar activity follows an approximately 11-year cycle, with periods of solar maximum producing more frequent and intense auroral displays at lower latitudes than periods of solar minimum. The current cycle reached its peak phase in late 2024, creating exceptional viewing opportunities that have extended well into 2025 and 2026. During this period, geomagnetic storms triggered by coronal mass ejections from the Sun have produced auroras visible across much of the northern United States and Europe, delighting observers who might normally need to travel to Arctic regions to witness the phenomenon. The increased activity has also created challenges for operators of satellites, power grids, and other technology sensitive to geomagnetic disturbances, demonstrating that the same phenomenon that creates beautiful light shows can also disrupt the technological infrastructure on which modern society depends. Among the most dramatic combinations of light and geological activity occurs during volcanic eruptions, when the chaos of a major explosive event generates lightning within the rising ash column. This phenomenon, sometimes called a dirty thunderstorm, creates images that look like they belong in an apocalyptic film sequence rather than a nature documentary. Bolts of lightning zigzag through billowing clouds of ash and gas, while the mountain below vomits molten rock into the sky, combining two of nature's most impressive displays into a single terrifying spectacle. The earliest recorded observation of volcanic lightning dates to 79 AD, when Pliny the Younger described the eruption of Mount Vesuvius as featuring a most intense darkness, rendered more appalling by the fitful gleam of torches at intervals obscured by the transient blaze of lightning. Nearly 2,000 years later, scientists are still working to fully understand the mechanisms behind this phenomenon. Volcanic lightning forms through processes both similar to and distinct from ordinary thunderstorm lightning. In a conventional thunderstorm, ice crystals collide with each other in the upper portions of clouds, transferring electrons and creating regions of positive and negative charge that eventually discharge as lightning. Volcanic lightning can involve ice-based charging in the upper portions of tall eruption columns, but it also features a mechanism that ordinary thunderstorms lack: triboelectric charging from colliding ash particles. When fragments of rock, glass, and volcanic material are explosively ejected from a volcano and begin rubbing against each other in the turbulent plume, they exchange electrons in the same way that your feet build up static electricity when shuffling across a carpet. The dense concentration of particles in an eruption column means that billions of these tiny charge transfer events occur simultaneously, building up electrical potential that eventually discharges as spectacular lightning bolts. Researchers studying Alaska's Mount Augustine volcano in 2006 observed two distinct phases of electrical activity during eruptions. The initial phase consisted of countless micro-discharges occurring directly above the crater vent as the tephra first emerged from the Earth, suggesting that the volcanic material already carried significant electrical charge from processes occurring within the volcano itself. A second phase, beginning approximately 3 minutes after eruption onset, produced much larger lightning bolts within the rising ash cloud, with some discharges stretching up to 15 kilometers in length. This pattern suggests that the complete story of volcanic lightning involves both initial charging of material during fragmentation within the volcano and subsequent charging through particle collisions in the atmosphere. Some volcanoes, particularly those that produce thick ash-rich eruption columns, generate lightning with remarkable frequency. Japan's Sakurajima volcano, one of the most active in the world, produces lightning so regularly that it has become a favorite subject for photographers seeking to capture the phenomenon. The relationship between volcanic lightning and the origins of life represents one of the more speculative but intriguing areas of scientific inquiry. In 1953, chemists Stanley Miller and Harold Urey conducted a famous experiment demonstrating that amino acids, the building blocks of proteins and life, could form spontaneously when electrical discharges passed through a mixture of gases simulating Earth's early atmosphere. The experiment suggested that lightning could have played a crucial role in generating the organic molecules from which life eventually emerged. Modern versions of this hypothesis point specifically to volcanic environments as likely cradles for prebiotic chemistry, since erupting volcanoes would have provided not only electrical discharges, but also the other necessary ingredients: water, heat, reducing gases, and mineral surfaces for catalysis. Volcanic lightning, in other words, may have helped spark the chemical reactions that eventually led to the evolution of organisms capable of appreciating the spectacle, a pleasing circularity that nature seems to enjoy. Among the more subtle atmospheric light shows, one that often catches observers by surprise is the circumhorizontal arc, commonly but inaccurately known as a fire rainbow. This phenomenon appears as a brilliant horizontal band of spectrum colours, stretching across the sky, looking somewhat like a rainbow that has been straightened out and suspended parallel to the horizon. Despite the popular name, fire rainbows have nothing to do with either fire or rain. They form when sunlight passes through ice crystals in high-altitude cirrus clouds, refracting at specific angles to separate white light into its component colours. The effect can be so vivid and unexpected that witnesses sometimes report feeling as though they are experiencing something supernatural, particularly when the display appears suddenly in an otherwise unremarkable sky. The conditions required for a circumhorizontal arc are precise enough that the phenomenon remains relatively uncommon, despite being well understood scientifically. The sun must be at least 58 degrees above the horizon, which limits viewing opportunities to certain times of day and certain latitudes during certain seasons. The ice crystals in the cirrus clouds must be hexagonal in shape with their flat faces oriented horizontally, allowing light to enter through vertical side faces and exit through horizontal bottom faces. This arrangement produces the same prismatic separation of colours that a glass prism demonstrates in a physics classroom, but on a scale that can span significant portions of the sky. When all conditions align and a patch of cirrus cloud happens to occupy the correct position relative to the observer and the sun, the result is a display of colours purer and more vivid than those in a typical rainbow, since the ice crystal geometry produces particularly clean colour separation. At the extreme upper reaches of Earth's atmosphere, near the boundary between the mesosphere and the thermosphere at altitudes of 76 to 85 kilometres, form the highest clouds known to exist on our planet. Noctilucent clouds, whose name translates from Latin as night shining, become visible only under very specific conditions that create an effect both beautiful and slightly eerie. These tenuous formations consist of tiny ice crystals, only about 100 nanometers in diameter, that form on particles of meteoric dust high in the atmosphere where temperatures drop to below minus 120 degrees Celsius. The clouds themselves are far too faint to see during daylight hours, when they are overwhelmed by the brightness of the sunlit sky. They become visible only during the deep twilight of summer nights at high latitudes, when the sun has dropped below the horizon but still illuminates these extremely high-altitude formations from below, causing them to glow against the darkening sky, like ghostly blue-white wisps. The counterintuitive aspect of noctilucent clouds is that they form during summer rather than winter, which seems wrong given their requirement for extremely cold temperatures. The explanation lies in the dynamics of atmospheric circulation. During summer in the polar regions, air near the ground heats up and rises, setting off a chain of atmospheric motion that ultimately causes downwelling and extreme cooling in the mesosphere directly above. This seasonal pattern means that the mesosphere over the Arctic and Antarctic reaches its coldest temperatures during summer months, creating conditions suitable for ice crystal formation, despite the warm weather at the surface. The effect works in both hemispheres, with Northern Hemisphere observers able to see noctilucent clouds from approximately May through August, and Southern Hemisphere observers seeing them from November through February. Noctilucent clouds were first observed and documented in 1885, just 2 years after the catastrophic eruption of Krakatoa in Indonesia. Early scientists assumed the clouds were simply another consequence of volcanic debris in the upper atmosphere, similar to the brilliant sunsets that followed the eruption. However, the clouds persisted long after volcanic material should have settled out of the atmosphere, and their seasonal pattern suggested a more complex origin. Modern research has revealed that noctilucent clouds have actually become more frequent and more visible over the past century, with sightings now occurring at lower latitudes than historical records indicate were typical. Scientists attribute this change to increasing atmospheric methane, which converts to water vapor in the stratosphere and eventually reaches the mesosphere, providing additional moisture for ice crystal formation. Noctilucent clouds may therefore serve as visible indicators of climate change occurring in atmospheric layers far removed from the surface where humans live. The combination of all these phenomena paints a picture of Earth as a planet far more dynamically illuminated than casual observation might suggest. We live on a world where the sky can suddenly burst into curtains of green and pink light, where beaches can glow as if backlit by some vast underwater lamp, where perpetual lightning flickers on the horizon like a never-extinguishing beacon, and where the very highest clouds shine with borrowed sunlight long after the sun has set. Each of these displays results from physical and chemical processes that, while explicable by science, lose none of their capacity to inspire wonder through being understood. If anything, knowing the mechanisms enhances appreciation. The aurora becomes more impressive when you realize it represents a direct physical connection between Earth and the Sun spanning 93 million miles. Bioluminescence becomes more remarkable. When you understand that tiny organisms have evolved lighting technology more efficient than anything human engineers have produced. These natural light shows also serve as reminders of the broader systems within which our planet operates. The aurora exists because Earth has a magnetic field strong enough to channel solar particles toward the poles, a feature that also protects us from radiation that would otherwise make the surface uninhabitable. Bioluminescence evolved because the deep ocean, where most of it occurs, receives no sunlight, creating evolutionary pressure for organisms to generate their own illumination. Noctilucent clouds form because our atmosphere has distinct layers with radically different temperatures and compositions, a structure that also makes surface life possible by moderating temperature extremes and filtering harmful radiation. Even the Catatumbo lightning depends on the particular configuration of mountains and water bodies in northwestern Venezuela, a reminder that local geography can produce global superlatives. Future observers may witness changes in some of these phenomena as human activity continues to alter atmospheric chemistry, ocean temperatures, and global circulation patterns. Noctilucent clouds appear to be becoming more common, possibly indicating changes in mesospheric moisture content. Coral reef bioluminescence has declined in areas affected by ocean acidification and warming. The Catatumbo lightning temporarily ceased during a severe drought, demonstrating its sensitivity to climate variations that may become more frequent. Even the aurora, while driven primarily by solar activity beyond human control, interacts with an upper atmosphere whose composition we are gradually changing. The light shows that have captivated human observers for thousands of years may look different to observers thousands of years hence, assuming there are any such observers left to appreciate them. For now, these phenomena remain accessible to anyone willing to travel to the right location at the right time under the right conditions, which admittedly involves more variables than planning most tourist activities. Seeing the Catatumbo lightning requires reaching a remote corner of Venezuela that travel advisories often recommend avoiding. Experiencing the brightest bioluminescent displays requires arriving at particular bays during the new moon phase when darkness is maximized. Witnessing a spectacular aurora demands both favorable solar activity and clear skies at high latitudes, conditions that rarely coincide with the schedules of vacationing professionals. Yet for those who manage to experience these phenomena firsthand, the memories tend to be among the most enduring and powerful of their lives. There is something about witnessing Earth produce its own light that touches something deep in human consciousness. Perhaps a recognition that our planet is not merely a passive backdrop for human activities, but an active, dynamic system producing wonders that dwarf our best artistic efforts. The light shows continue, as they have for millions or billions of years depending on the phenomenon in question. The lightning still flashes over Lake Maracaibo, visible from hundreds of kilometers away as it has been since long before humans evolved to appreciate it. The dinoflagellates still glow in warm coastal waters, performing their defensive light display for audiences of fish rather than tourists, but equally spectacular either way. The aurora still dances over polar regions, painted by particles that left the sun days earlier, and travelled 150 million kilometres to create a few minutes of terrestrial beauty. These are not shows staged for human benefit. They are simply what Earth does, part of the normal operation of a planet that happens, almost incidentally, to be spectacularly beautiful. We are merely fortunate enough to have evolved eyes capable of detecting the wavelengths involved, and brains capable of recognizing that what we are seeing deserves attention and appreciation. The ancient humans who first noticed these phenomena and wove them into their mythologies were responding to the same impulses that drive modern scientists to study them and modern tourists to photograph them. We want to understand, to explain, to capture something of what we are seeing, even knowing that photographs and videos never quite convey the experience of being there. The aurora cannot be adequately photographed because cameras cannot capture the movement, the sense of three-dimensional depth, the way the lights seem to come from everywhere and nowhere simultaneously. Bioluminescence photographs inevitably look either too dim to see or artificially enhanced, failing to convey the magic of watching your own footprints glow in the wet sand. Lightning photography freezes individual bolts rather than conveying the endless rhythm of flash after flash after flash, stretching through the entire night. Perhaps these phenomena are meant to be experienced rather than recorded, appreciated in the moment rather than preserved for later, though that has never stopped anyone from trying. What these light shows ultimately demonstrate is that we live on a planet where beauty is not rare but ubiquitous, requiring only attention and sometimes travel to discover. Earth produces light displays rivaling anything human imagination has created, and it does so without any apparent intention or awareness, simply as a consequence of physical and chemical processes operating according to unchanging natural laws. The universe apparently does not require consciousness to generate wonder. It produces wonder automatically, continuously, in quantities so vast that no single human lifetime could experience more than a tiny fraction. The appropriate response to this realization may be gratitude, or it may be determination to see as much as possible before our individual opportunities end. Either way, the shows will continue, as they have always continued, whether anyone is watching or not. When available land runs short, humanity does not politely accept defeat and start living in smaller houses. Instead, we build upward until the clouds become neighbours, downward until we greet the bedrock, and inward until entire civilizations exist within single structures. The result is a collection of settlements that would feel entirely at home in science fiction novels, places where the normal rules of urban development have been thoroughly abandoned in favour of something considerably more creative. These are not hypothetical future cities designed by architects with unlimited budgets and no building codes. These are real places where real people live right now, navigating daily lives that would strike most of us as thoroughly implausible if we had not seen photographs proving their existence. Consider for a moment the standard assumptions we make about towns. Towns have houses, we think. Houses are separate buildings with doors that open onto streets. Streets connect houses, to shops, to schools, to places of worship. You leave your home, walk down the street, perhaps drive somewhere, and eventually arrive at your destination. This model has served humanity reasonably well for several thousand years. It functions adequately in temperate climates with moderate terrain and sufficient horizontal space for spreading out. But what happens when the climate becomes hostile, the terrain becomes vertical, or the space simply disappears? What happens is that humans, being the relentlessly adaptable creatures we are, simply throw out the rulebook and start improvising. The results are frequently astonishing. In the remote wilderness of southern Alaska, about 60 miles southeast of Anchorage, sits a town called Whittier. To reach this settlement by land, you must drive through the Anton Anderson Memorial Tunnel, a 2.5-mile passage through a mountain that holds the distinction of being the longest highway tunnel in North America. The tunnel operates on a schedule, alternating between inbound and outbound traffic, and closes entirely at night. This means that if you miss your window to leave Whittier, you're staying in Whittier whether you plan to or not. The town itself exists in a location that receives approximately 197 inches of precipitation annually, making it one of the wettest places in the entire United States. Winter winds regularly exceed 60 miles per hour, temperatures drop well below freezing, and the general meteorological consensus seems to be that this is simply not an ideal location for human habitation. Yet approximately 270 people call Whittier home, and nearly all of them live in the same building. The structure in question is called Begich Towers, a 14-story concrete edifice that was originally constructed by the United States Army in 1957 during the Cold War. The military wanted a logistics base in this remote but strategically useful location, and they built accordingly, designing a structure that could withstand both enemy bombardment and the considerably more persistent assault of Alaskan weather. When the Army departed in the early 1960s, the building was converted into condominiums, and the residents discovered something remarkable. You could fit an entire town inside a single building if you were sufficiently creative about the definition of what a town requires. The Begich Towers now contains roughly 196 housing units, a post office, a grocery store, a laundromat, a police station, a health clinic, a church in the basement, an indoor playground, and the administrative offices for the entire city government. The local school is not technically inside the building, but is connected to it via an underground tunnel, allowing students to attend classes without ever setting foot outdoors. The residents of Whittier have developed what might be charitably called an indoor lifestyle. Some do not venture outside for months at a time, not because they are reclusive by nature, but because there is simply no compelling reason to brave hurricane-force winds when everything you need is accessible via elevator. The building's hallways resemble those of a high school or a moderately well-maintained hotel, with cinder block walls painted in institutional colours and bulletin boards advertising community events. Neighbours know each other by necessity, since running into the same 200 people repeatedly tends to break down social barriers fairly quickly. One resident described the living situation as resembling a large house where everyone has separate bedrooms, which is a considerably more generous interpretation than the prison comparisons that some outsiders initially suggest. The views, admittedly, are spectacular. From the upper floors, residents can watch whales breaching in the waters of Prince William Sound, mountain goats grazing on distant peaks, and glaciers carving into the sea. Some residents keep binoculars by their windows specifically for wildlife observation, though reportedly others use them to check whether their spouses have stopped by the bar on the ground floor. The other major building the Army constructed in Whittier was the Buckner Building, which was even more ambitious than the Hodge Building, as Begich Towers was originally called. The Buckner was designed to house 1,200 people and included a bowling alley, a theatre and a bakery. Unfortunately, the 1964 Good Friday earthquake, one of the most powerful ever recorded in North America, damaged the Buckner severely enough that it was abandoned and never reoccupied. It still stands today, a 14-story monument to what happens when you try to build civilization in places that actively resist the attempt. The structure is filled with asbestos, which means demolition would cost more than anyone is willing to pay, so it simply remains, slowly deteriorating while tourists photograph it from a respectful distance. Whittier, in essence, was supposed to be a two-building city but ended up as a one-building town, which is still one more building than most towns technically require. The concept of vertical density reaches its historical extreme not in Alaska but in Hong Kong, where humanity has been stacking itself toward the sky with an enthusiasm that borders on obsession. Hong Kong currently holds approximately 570 buildings that qualify as skyscrapers under the standard definition of structures exceeding 150 meters in height. For comparison, New York City, which most people imagine as the definitive skyscraper metropolis, contains approximately 320. Dubai, despite its reputation for architectural excess, manages only about 270. Hong Kong has more skyscrapers than New York and Dubai combined, packed into a territory roughly 1/6 the size of Rhode Island. The reasons for this vertical expansion are primarily geographical. Hong Kong consists largely of mountainous terrain with a limited amount of flat land suitable for construction, and the population has grown far beyond what horizontal development could accommodate. The solution naturally was to build upward until the building started interfering with air traffic. The skyline of Hong Kong Island is so dense with towers that from certain angles the buildings appear to merge into a single continuous wall of glass and steel. The nightly light show called a Symphony of Lights, which illuminates 44 buildings along Victoria Harbour with synchronized laser displays, holds a Guinness World Record as the largest permanent light fixture in the world. More Hong Kong residents live at the 15th floor or higher than in any other city on the planet, which means that for a significant portion of the population, ground level is essentially a distant memory accessible only by elevator. The density creates its own problems, including a phenomenon locals call the wall effect, where the sheer mass of buildings blocks air circulation and traps pollution at street level. But it also creates communities in the sky, with residential towers functioning as vertical villages complete with restaurants, shops, and recreational facilities that residents might never need to leave. Hong Kong's modern verticality, however, pales in comparison to the density once achieved by a settlement that no longer exists, the Kowloon Walled City. This infamous structure, demolished in 1994, represented what happens when urban development proceeds entirely without regulation, oversight, or apparent concern for concepts like fire safety or structural engineering. The walled city began as a Chinese military fort in the 19th century, but a series of diplomatic complications left it in jurisdictional limbo after Britain took control of Hong Kong. Neither the British colonial government nor the Chinese authorities were willing to assert clear jurisdiction over the site, which meant that effectively nobody was in charge. Nature abhors a vacuum, and so does humanity, particularly humanity looking for somewhere to live cheaply and conduct business without governmental interference. By the 1980s, the Kowloon Walled City had grown into a 14-story labyrinth of interconnected buildings occupying about 6.5 acres and housing somewhere between 33,000 and 50,000 residents, depending on which estimate you trust. This made it the most densely populated place on Earth, with a population density approaching 2 million people per square kilometre. For context, Manhattan has a population density of roughly 27,000 people per square kilometre. The walled city was nearly 100 times denser. The structures within were built so closely together that they effectively merged into a single massive building, with narrow corridors snaking between them that never saw direct sunlight. Residents navigated by memorizing routes through what must have been one of the most confusing layouts in architectural history. Electricity was pirated from surrounding grids. Water was pumped from wells and distributed through an improvised network of pipes that residents installed themselves. The Hong Kong government provided mail delivery and eventually some water service, but otherwise the walled city was entirely self-organized. The reputation of the Kowloon walled city as a den of criminal activity was not entirely unearned. Triads operated gambling dens and opium parlours within its walls, and unlicensed doctors and dentists practiced their professions beyond the reach of medical regulations, which was occasionally convenient and occasionally catastrophic depending on the practitioner's actual skill level. But the majority of residents were simply ordinary families seeking affordable housing in an extraordinarily expensive city. They developed their own systems of governance, their own community organisations, and their own methods of maintaining what passed for public order. Kindergartens operated in cramped rooms. Small factories manufactured everything from fish balls to plastic toys. Rooftops became communal spaces where residents could escape the perpetual darkness of the lower levels and enjoy something resembling outdoor recreation. The walled city was, in its peculiar way, a functional community, albeit one that would give any modern building inspector a cardiac event. The demolition of the Kowloon walled city took from 1993 to 1994 and required the relocation of its entire population, a process that took years of negotiation and compensation arrangements. The site is now a pleasant park with traditional Chinese gardens, and visitors can view a scale model of what the walled city looked like at its peak. The structure has achieved a kind of legendary status, inspiring settings in films, video games, and architectural discussions about what cities might look like if regulations were entirely removed. The consensus seems to be that they would look a lot like the Kowloon walled city, which is probably not the endorsement that advocates of minimal government oversight were hoping for. Still, the walled city demonstrated that humans can create functional communities under conditions that would seem to preclude habitation entirely, which is either inspiring or deeply concerning depending on your perspective. At the opposite extreme of density sits Monowee, Nebraska, a town whose population peaked at approximately 150 residents in the 1930s and has since declined to exactly 1. That one resident is a woman named Elsie Eiler, who has been the sole inhabitant since her husband passed away in 2004. As the only person living in Monowee, Elsie serves simultaneously as the town's mayor, clerk, treasurer, librarian, and the owner-operator of the Monowee Tavern, which she runs 6 days a week serving hamburgers, hot dogs, and beer to visitors and locals from surrounding areas. Each year she votes for herself in the mayoral election, which she wins by a margin of 100% with a turnout that also happens to be 100%. She issues herself a liquor license, which she then approves in her capacity as town clerk. She pays approximately $500 in annual taxes to herself, which she uses to maintain the town's 4 streetlights and basic infrastructure. The bureaucratic absurdity of this arrangement has made Monowee something of a tourist attraction, drawing visitors from around the world who want to see what a one-person town actually looks like in practice. Monowee exists because Elsie refuses to let it die. The town was once a stop on a railroad line, but the train stopped coming in the 1970s, and the population drained away as young people left for larger cities with better economic opportunities. Elsie and her husband Rudy stayed, operating the tavern and watching their community gradually disappear around them. When Rudy died, Elsie could have simply moved away and let Monowee become another ghost town dotting the Great Plains, indistinguishable from the hundreds of other communities that have met the same fate. Instead, she chose to remain, partly because Monowee is the only home she's ever known, and partly, one suspects, because she finds a certain satisfaction in defying the forces that have hollowed out rural America. She maintains a library of approximately 5,000 books that her husband collected, housed in a small building and available to anyone who wants to borrow them on the honor system. The library is named after Rudy, a memorial to a man who loved reading, and a statement that even a town of one person can support cultural institutions. The story of Monowai raises questions about what exactly constitutes a town. Is it a matter of infrastructure, of having streets and buildings and the physical apparatus of civilization? Is it a matter of population, of having enough people to form a community? Or is it simply a matter of someone caring enough to maintain the designation, to file the paperwork and keep the lights on? By most definitions, Monowai should not exist. It is not economically viable, it provides no services that could not be obtained elsewhere, and its sole resident is in her 90s, meaning that the town's future is measured in years rather than decades. Yet there it is on the map, population 1, an incorporated municipality in the state of Nebraska, with all the legal standing that implies. When Elsie eventually passes, Monowai will presumably become a ghost town, but until then, it remains proof that a town can exist as long as a single person believes it should. The spectrum of human settlement runs from Monowai's population of 1 to Hong Kong's millions, from Whittier's single building to the sprawling metropolises that spread across hundreds of square miles. What connects these extremes is the fundamental human drive to create places where we can live, places that meet our needs for shelter, community, and meaning. Sometimes those places look like what we expect towns to look like: houses on streets, shops and schools, the familiar infrastructure of civilization. Sometimes they look like 14-story concrete blocks in the Alaskan wilderness, or vertical mazes in jurisdictional grey zones, or single buildings where one elderly woman serves beer to tourists who have driven hundreds of miles to visit a town that barely exists. The form matters less than the function, and the function is always the same: to carve out a space in the world where humans can do the things that humans do. Whether that space accommodates 50,000 people in impossible density or one person in stubborn solitude, it serves the same fundamental purpose. It is home. The phenomenon of vertical cities extends far beyond Hong Kong, though few places have embraced it with quite the same enthusiasm. Singapore, another city-state with limited land area, has similarly built upward out of necessity, though its approach has been considerably more planned and regulated than Hong Kong's organic explosion. Singapore's public housing program, which houses approximately 80% of the population, consists largely of high-rise apartment blocks that would feel familiar to anyone who has visited Hong Kong, though they are generally better maintained and more spaciously designed. The government maintains strict control over housing development, which prevents the kind of anarchic density that characterised the Kowloon walled city, but also means that residents have considerably less flexibility in how they organise their living spaces. The underground equivalent of vertical development can be found in various cities that have built substantial infrastructure beneath their streets. Montreal's underground city, known locally as the Underground City or La Ville Souterraine, consists of over 32 kilometres of tunnels connecting office buildings, shopping centres, hotels, universities, and metro stations. During Montreal's famously brutal winters, residents can conduct most of their daily activities without ever setting foot outdoors, navigating from home to work to shops through climate-controlled passageways that maintain comfortable temperatures, regardless of the blizzard conditions raging above. Helsinki, Finland, has similarly developed an extensive underground network that includes shopping centres, swimming pools, and even a church carved into the bedrock beneath the city. Tokyo presents perhaps the most elaborate example of underground development, with multiple levels of basement floors beneath major commercial districts and an extensive network of tunnels connecting train stations, department stores, and office buildings. The area beneath Tokyo Station and the surrounding Marunouchi district is essentially a city unto itself, with restaurants, shops, and service facilities that could keep someone occupied for days without ever seeing the sky. The Japanese have become particularly skilled at maximizing the utility of underground space, partly because real estate prices on the surface are prohibitively expensive, and partly because underground construction provides some protection against the earthquakes that periodically shake the region. The development of these underground and vertical cities reflects a broader human tendency to adapt our living spaces to whatever constraints we face. When land is expensive, we build upward. When weather is hostile, we build underground. When regulations are absent, we build however we can manage, creating communities in the spaces between what authorities expect and what residents need. The results are sometimes elegant, sometimes chaotic, and frequently astonishing to visitors who have never encountered such intensive use of three-dimensional space. The residents themselves often find their living situations perfectly normal, having grown up navigating elevator banks and underground passages as naturally as people elsewhere navigate streets and sidewalks. Perhaps the most extreme example of adapting to unusual circumstances can be found in the communities that have developed around industrial facilities or in locations that seem actively hostile to human habitation. The town of Norilsk in Siberia exists primarily to support one of the world's largest nickel mining operations, despite being located in permafrost territory where winter temperatures regularly drop below -30 degrees Celsius and the sun does not rise for 2 months of the year. Approximately 175,000 people live in Norilsk, making it one of the largest cities in the Arctic region, and they do so in a landscape so contaminated by decades of heavy metal processing that the surrounding area is essentially devoid of plant life. The snow sometimes falls black due to industrial emissions. The city is not connected to any other city by road. Residents who wish to leave must do so by air or, during the brief summer shipping season, by water. Yet people live there, raise families there, and presumably find aspects of the experience worthwhile despite conditions that would strike most outsiders as intolerable. The human capacity for adaptation is perhaps nowhere more visible than in these extreme settlements, places where the normal assumptions about what makes a location suitable for habitation have been thoroughly abandoned. We live in towers that scrape the clouds and tunnels that burrow into bedrock. We live in deserts and frozen wastes, in swamps and on mountainsides, in places with no roads and places with no ground-level access. We live alone in dying towns and packed together in densities that seem physically impossible. And in each case, we find ways to make our impossible circumstances work, creating communities and cultures and daily routines that make sense to those who participate in them, even if they bewilder outside observers. The future will undoubtedly bring new variations on this theme. Architects have proposed floating cities for rising seas, underground cities for hostile climates, and even space habitats for those willing to leave Earth entirely. Some of these proposals are more realistic than others, but all of them share the same fundamental assumption: that humans will continue to find ways to live wherever we decide to live, adapting our built environment to our needs rather than accepting the limitations that geography might seem to impose. The residents of Whittier, navigating their 14-story building through the Alaskan winter, are in this sense pioneers of a sort, demonstrating that the traditional model of separate houses on separate streets is merely one option among many. The town may be strange by conventional standards, but convention is merely what we have grown accustomed to, and what we grow accustomed to can always change. The abandoned Buckner building across from the still inhabited Begich Towers serves as a constant reminder of what happens when maintenance stops and nature begins reclaiming human structures. The Buckner was designed to be even more self-sufficient than its neighbour, incorporating recreational facilities that the Begich Towers lacked. But abandonment came swiftly once the military departed, and the building has spent the past 6 decades slowly deteriorating, while asbestos contamination makes demolition prohibitively expensive. Visitors to Whittier can photograph the Buckner from outside, its broken windows and crumbling facade standing in stark contrast to the still functional Begich Towers next door. The two buildings together tell a story about the fragility of human infrastructure, how quickly our creations can fail when we stop caring for them, and how much effort is required to maintain habitation in places that resist human presence. The community dynamics within vertical towns like Whittier differ fundamentally from those in traditional settlements. When you share not just a street but an entire building with your neighbours, privacy becomes a scarce commodity, and social interactions become unavoidable. Residents report both advantages and disadvantages to this arrangement. On the positive side, there is a strong sense of community, a certainty that your neighbours will notice if something is wrong and will help in emergencies. Crime is essentially non-existent because everyone knows everyone, and strangers are immediately apparent. Children can be given more freedom to explore because the building functions as a controlled environment, where dangers are limited and supervision is collective. On the negative side, gossip travels fast, personal conflicts are difficult to avoid, and the sense of being constantly observed can wear on those who value solitude. Some residents describe Whittier as feeling like a large family, which is either appealing or horrifying depending on your experience with your own family. The seasonal population swing in Whittier adds another layer of complexity to the community's functioning. During summer, tourists arrive by the thousands, some on cruise ships that dock at the harbour, others driving through the tunnel to photograph glaciers and wildlife. The population can briefly double or triple, putting strain on infrastructure designed for a couple hundred year-round residents. Local businesses that barely survive during the quiet winter months make most of their annual income during these few hectic months. Then winter arrives, the tunnel closes earlier each night, the cruise ships stop coming, and Whittier settles back into its peculiar isolation. The residents who choose to stay year-round must be comfortable with this rhythm of crowded summers and empty winters, with the transition from being overrun by strangers to being alone with the same neighbours they will see every day until the spring. Thaw brings the outside world back. Similar seasonal dynamics affect many extreme communities around the world. McMurdo Station in Antarctica, the largest human settlement on that continent, houses over 1,000 people during the summer research season, but dwindles to fewer than 200 during the dark winter months when supply flights become impossible. The International Space Station maintains a continuous human presence, but sees regular rotation of crew members who cannot stay indefinitely in the hostile environment of low Earth orbit. Oil platforms in the North Sea and elsewhere operate with rotating crews who spend weeks or months at a time in isolated facilities before returning to families and normal life ashore. These are not towns in the traditional sense, but they are communities, groups of people who must figure out how to live together in confined spaces under unusual circumstances. The skills and social structures they develop may become increasingly relevant as climate change, population growth, and technological capability drive humans to inhabit places that previous generations would have considered uninhabitable. The persistence of places like Monowee, meanwhile, speaks to the opposite end of human settlement. The stubborn refusal to let communities die even when demographic and economic forces have rendered them obsolete. Across the Great Plains of North America, hundreds of small towns are slowly fading, their populations aging and declining as young people leave for cities that offer better opportunities. Some of these towns will eventually become ghost towns, their buildings collapsing, their streets returning to prairie. Others will hold on for decades more, sustained by a handful of residents who refuse to leave the only homes they have ever known. Monowee is simply the extreme case, a town reduced to its absolute minimum, one person maintaining the legal fiction of municipal existence through sheer determination and the willingness to file paperwork that no one else cares about. The question of what makes a place worth preserving is ultimately unanswerable in any general way because the answer depends entirely on who you ask. For the residents of Whittier, their town is worth preserving because it is home, because the spectacular scenery compensates for the challenging weather, because the tight-knit community provides something that larger, more anonymous settlements cannot match. For Elsie Eiler, Monowee is worth preserving because it contains her memories, because walking away would mean admitting that the place where she lived her entire life no longer matters. For the people who once inhabited the Kowloon-walled city, their chaotic maze of a neighbourhood was worth preserving because it was where they had built their lives, even if outsiders saw only squalor and danger. In each case, the value of the place is inseparable from the people who give it meaning, and the loss of the place would be the loss of something more than just buildings and infrastructure. Human beings have been drawing lines on maps for as long as we have had maps to draw on, and the results have been, shall we say, inconsistent. Some borders follow natural features like rivers and mountain ranges, which makes a certain amount of intuitive sense. Others follow lines of latitude and longitude, which at least have the virtue of being straight even if they occasionally bisect villages or separate farmers from their fields. And then there are the borders that seem to have been designed by cartographers who had either consumed questionable substances or were actively trying to make future generations miserable. These are the borders that create enclaves within enclaves, that run through the middle of buildings, that force entire nations to pretend the sun rises 3 hours later than it actually does. They are monuments to the proposition that political boundaries and geographical reality need not have anything to do with each other. The United States contains exactly one location where 4 state boundaries meet at a single point, and Americans being Americans, they have naturally turned this geographical curiosity into a tourist attraction. The Four Corners Monument marks the quadrupoint where Arizona, Colorado, New Mexico, and Utah converge, allowing visitors to stand with limbs in 4 different states simultaneously and photograph the resulting contortion for social media purposes. The monument itself consists of a bronze disc embedded in granite, surrounded by the flags of the 4 states and the tribal nations whose territory the site occupies. Approximately 250,000 visitors make the pilgrimage each year, despite the fact that the nearest town of any size is Farmington, New Mexico, some 60 miles distant, and the surrounding landscape consists primarily of high desert that is photogenic in photographs but brutally hot in person during summer months. The Four Corners Monument exists because of a peculiarity in how the western United States was divided into territories during the 19th century. When Congress created the Colorado Territory in 1861, it defined the territory's southern border as the 37th parallel north. When Arizona was split from New Mexico Territory in 1863, Congress took the unusual step of defining the boundary not as a line of latitude or longitude, but as an extension of the existing Colorado-Utah border, specifically the 32nd meridian west of Washington. This decision ensured that the four territories, and eventually the four states, would meet at a single point regardless of any surveying errors that might occur. And surveying errors did occur, because surveying in the 1870s involved dragging heavy equipment across difficult terrain, using 19th century transportation, and hoping your measurements were close enough. The actual marker, placed in 1875, is not precisely where the intersection of the 37th parallel and the 32nd meridian would theoretically fall, but this technicality was resolved by simply declaring the marker's location to be the legal boundary, regardless of its astronomical accuracy. The lines on the map now follow the lines on the ground rather than the other way around. The Four Corners also marks the intersection of 6 governmental jurisdictions, the 4 states plus the Navajo Nation and the Ute Mountain Ute tribe, whose reservations include portions of the monument area. This creates interesting jurisdictional questions that lawyers presumably enjoy contemplating. If you were to commit a crime while standing precisely at the monument's centre, which state would have jurisdiction to prosecute? The answer is probably whichever state could prove that the criminal act occurred within their quarter of the marker, though one imagines that the actual law enforcement response to most crimes at Four Corners involves Navajo Nation police, since the entire monument is on tribal land and is administered by the Navajo Nation Department of Parks and Recreation. The tribal government charges an admission fee to visit the monument, which some visitors find unexpected given that they are technically standing on United States soil, but which is entirely consistent with tribal sovereignty over reservation land. The Four Corners at least has the virtue of being a clean intersection, a single point where 4 boundaries meet without any overlap or ambiguity. The same cannot be said for the border between Belgium and the Netherlands in the region around the twin municipalities of Baarle-Hertog and Baarle-Nassau. This border is widely regarded as the most complicated in the world, and after examining it in any detail, one quickly understands why. The situation involves 22 Belgian exclaves surrounded by Dutch territory, plus 7 Dutch counter-exclaves located within the Belgian exclaves, creating a cartographic nightmare that looks less like an international boundary and more like someone spilled coffee on a map and decided to formalize the stain pattern. The origins of this geographical absurdity trace back to medieval land agreements between local nobles who apparently had no concept of what future generations might have to deal with. The Dukes of Brabant, who controlled what would become Belgian territory, and the Lords of Breda, aligned with what would become the Netherlands, swapped land parcels over several centuries based on criteria that made sense at the time but make no sense whatsoever in retrospect. When Belgium declared independence from the Netherlands in 1830, the diplomats tasked with defining the border encountered Baarle and essentially threw up their hands. The Treaty of Maastricht in 1843 formally acknowledged that the situation was too complicated to resolve and declared that the status quo would be maintained. This meant that thousands of individual land parcels had to have their nationality determined one by one, based on medieval ownership records that were often incomplete or contradictory. The process was not fully completed until 1995, 165 years after Belgian independence. Today, the border in Baarle is marked by white crosses set into the pavement, allowing residents and tourists to track exactly which country they are standing in at any given moment. Some houses are split between the two countries, with the nationality of the residents determined by the location of the front door. This has led to creative solutions when residents wanted to change their nationality for tax or regulatory purposes. They simply moved their front door to the other side of the building. Restaurants that straddled the border once faced the challenge of different closing times in Belgium and the Netherlands, meaning that patrons on one side of the dining room could be kicked out, while patrons a few meters away continued their meals. During the COVID-19 pandemic, different national lockdown rules created situations where one side of a shop required masks while the other side did not, and enforcement was presumably both confusing and entertaining for everyone involved. The practical implications of living in Bâle are mostly managed through cooperation and common sense, rather than strict adherence to which patch of soil belongs to which nation. Both Belgium and the Netherlands are members of the European Union and the Schengen area, meaning that there are no immigration controls and goods can move freely across the border, which in this case would mean moving freely across a kitchen or living room. The two municipalities share a library with staff from both countries, and residents have generally figured out how to navigate the bureaucratic complexities of dual nationality, double taxation systems, and multiple school districts. Fireworks shops in the Belgian sections do brisk business since Belgian regulations are more permissive than Dutch ones, and the ability to walk a few metres to legal fireworks is apparently a significant draw for Dutch citizens preparing for New Year's celebrations. The situation in Bâle represents one type of border absurdity, the organic accumulation of historical accidents that nobody has bothered to fix because fixing them would require confronting centuries of property rights and legal precedent. The border between Sweden and Norway represents a different type, the deliberate creation of an unmistakable boundary through sheer physical effort. The two Scandinavian countries share approximately 1,630 kilometres of border, and for most of that length, particularly through forested areas, the boundary is marked by a cleared strip of land approximately 6 metres wide. Trees are cut down, vegetation is removed, and the border is maintained as a visible corridor running through the landscape. From above, it appears as a continuous line carved through the forest, stretching from the Skagerrak Strait in the south to the Barents Sea in the north. This border vista, as it is called, exists because marking a boundary through wilderness areas is genuinely difficult when there are no rivers or mountain ridges to follow. The alternative to clearing a visible strip would be relying on boundary markers that could become buried under snow, obscured by vegetation, or simply lost in the vastness of the Scandinavian forest. The cleared strip provides an unambiguous demarcation that anyone can see and recognise, which is useful for hikers, reindeer herders, and the occasional bear or wolf that wanders across national boundaries without bothering to check its passport. The maintenance of the border vista requires ongoing effort, as forests have an inconvenient tendency to regrow when left unattended, but both countries consider this effort worthwhile for the clarity it provides. The border is visible from space, or at least from high-altitude aircraft, which is either an impressive feat of international cooperation or a somewhat excessive response to the problem of distinguishing Sweden from Norway. Both Sweden and Norway are members of the Schengen area, but not both members of the European Union, which creates certain complications at the border. Sweden is an EU member while Norway is not, meaning that customs checks are theoretically required for goods crossing between the two countries. In practice, these checks are sporadic and typically involve automatic license plate recognition systems, rather than actual border stations staffed by officials inspecting every vehicle. The relationship between the two nations is friendly enough that the border functions more as an administrative formality than a genuine barrier, but the customs distinction means that prices for certain goods can vary significantly on either side, leading to the time-honoured tradition of cross-border shopping. China presents perhaps the most dramatic example of political boundaries overriding physical reality, specifically in the matter of time zones. The country spans approximately 5,000 kilometres from east to west, which would naturally suggest 5 different time zones if China followed the same conventions as most other geographically large nations. The United States, which is roughly similar in east-west extent, has 4 major time zones plus additional zones for Alaska and Hawaii. Russia, the world's largest country by area, has 11 time zones. China, since 1949, has had exactly 1. Every clock in the People's Republic, from the eastern coast near Shanghai to the western reaches of Xinjiang, near the borders of Kazakhstan and Kyrgyzstan, is set to Beijing time, which is UTC plus 8. The practical implications of this decision become apparent when you consider what UTC plus 8 means in different parts of the country. In Beijing and the eastern provinces, Beijing time corresponds reasonably well to local solar time. The sun rises in the morning, sets in the evening, and the hours of daylight align with the hours that people are typically awake. In Xinjiang, however, the situation is considerably more peculiar. The sun does not rise in Kashgar until approximately 10 a.m., Beijing time during winter months. It does not set until nearly midnight during summer. This means that the official workday, which nominally begins at 8 or 9 a.m., throughout China starts in western Xinjiang when it is still completely dark outside. Schools open before dawn. Offices operate under artificial lighting during what the clock insists is the middle of the morning. Evening activities extend well past official sunset times because the actual sunset has not yet occurred. The response to this situation has been the development of an unofficial parallel time system known as Xinjiang time, which runs 2 hours behind Beijing time and corresponds more closely to local solar conditions. The use of Xinjiang time is roughly correlated with ethnicity. The Han Chinese population, which has increased substantially in the region over recent decades as part of government settlement policies, generally uses Beijing time, while the Uyghur population and other local ethnic groups tend to use Xinjiang time. This creates complications when members of different groups attempt to schedule meetings or appointments, as the question, what time, must be followed by Beijing time or Xinjiang time. Businesses may operate on one system or the other depending on their clientele, and even television channels are scheduled according to different time standards depending on which language they broadcast in. The political dimension of this time zone situation should not be overlooked. The decision to maintain a single national time zone was made in 1949, shortly after the establishment of the People's Republic, as a deliberate assertion of national unity. Before 1949, China used 5 time zones, with the western regions operating on their own schedules. The consolidation to a single time zone was part of the broader project of centralizing authority and emphasizing that China was a unified nation rather than a collection of disparate regions. In Xinjiang specifically, where the Uyghur population has historically maintained a distinct cultural identity and where tensions with the central government have sometimes been severe, the enforcement of Beijing time carries symbolic weight. Using Xinjiang time can be seen as a minor act of cultural resistance, an assertion that local conditions should take precedence over directives from the distant capital. Whether this interpretation is correct or overwrought probably depends on whom you ask. The arbitrary nature of national boundaries becomes even more apparent when you consider places where borders have been drawn through existing communities with no regard for the people living there. The partition of India in 1947 created one of the most complicated border situations in history, with the region of Bengal and the former princely states of Cooch Behar and Rangpur generating over 200 enclaves and counter-enclaves that persisted until 2015. The most extreme case was a piece of Indian territory inside a Bangladeshi enclave, inside an Indian enclave inside Bangladesh, creating a third-order enclave that would be essentially impossible to access without crossing multiple international boundaries. The origins of this situation lay in the peculiar way that the princely states were carved up during partition, combined with the entertaining fact that the local rulers had apparently spent previous centuries gambling away parcels of land to each other during card games and chess matches. The enclaves were finally exchanged between India and Bangladesh in 2015, with residents given the choice of which nationality to adopt, ending decades of jurisdictional limbo for people who'd been effectively stateless. The tendency of borders to ignore the people they divide is perhaps nowhere more visible than in places where the same ethnic group, speaking the same language and practicing the same customs, finds itself split between multiple nations due to historical accidents entirely beyond their control. The Kurds are spread across Turkey, Iraq, Iran and Syria. The Basques straddle Spain and France. The Sami people's traditional territories span Norway, Sweden, Finland and Russia. In each case, the borders that divide these populations were drawn by external powers with little consideration for who actually lived in the affected territories, and the results continue to shape political realities generations later. The borders persist not because they make any particular sense, but because changing them would require confronting questions that most governments would prefer to avoid. What all these border peculiarities reveal is that the lines on maps are fundamentally human creations, subject to all the irrationality, inconsistency and historical accident that characterizes human decision-making. We draw borders based on treaties negotiated under duress, on surveys conducted with imprecise instruments, on administrative convenience, on ethnic prejudice, on the outcome of wars, and occasionally on the results of gambling sessions between minor aristocrats. We then treat these lines as if they were immutable features of the landscape, building institutions and identities around them, fighting wars to defend or change them, and generally behaving as if they were handed down by some higher authority, rather than cobbled together by fallible humans making decisions under imperfect circumstances. The absurdity of some borders should not obscure the genuine importance that borders can have for the people who live with them. Borders determine which laws apply to you, which government collects your taxes, which army might conscript you, which language your children will be educated in. They can separate families, divide communities, and create barriers that persist for generations. The residents of Bâle have mostly figured out how to live with their complicated border, but that is largely because both Belgium and the Netherlands are prosperous democracies, with open borders and similar legal systems. The same cannot be said for borders in regions of conflict, where crossing from one side to the other might be impossible, dangerous, or fatal. Yet there is also something reassuring about the absurdity of borders, a reminder that the divisions between nations are human constructions rather than natural facts. The line running through a kitchen in Bâle is ridiculous, but its ridiculousness demonstrates that with sufficient goodwill, even the most complicated borders can be managed peacefully. The single time zone covering all of China is an assertion of political power, but it is also an acknowledgement that time itself is a human convention rather than an unchangeable reality. The Four Corners Monument, where tourists can taught themselves to stand in 4 states simultaneously, is a celebration of the arbitrary lines we draw and the games we play with geography. These absurdities remind us that the world did not have to be divided the way it is, that the boundaries separating us are the products of specific historical moments that could have gone differently, and that perhaps, with enough creativity and cooperation, we might someday redraw them in ways that serve us better. In the meantime, we live with the borders we have inherited, navigating their complications as best we can. We clear strips through forests to mark where one country ends and another begins. We set our clocks to times that bear no relationship to the position of the sun. We maintain enclaves within enclaves, filing paperwork in multiple languages and dealing with multiple bureaucracies. We build monuments at arbitrary intersections and charge admission to stand on them, and somehow, despite all the absurdity, we make it work, because that is what humans do. We draw lines on maps and then figure out how to live with the consequences, adapting to whatever complications our ancestors' decisions have bequeathed to us. The borders may be absurd, but our ability to function despite them is perhaps the most human thing of all. Consider for a moment the peculiar situation of the Diomede Islands in the Bering Strait, where the international date line passes between 2 small rocky outcrops separated by just under 4 kilometers of water. Big Diomede belongs to Russia, Little Diomede belongs to the United States, and the date line runs between them, meaning that you can literally see tomorrow from today, depending on which island you stand upon. In winter, when the strait freezes over, you could theoretically walk from one day to the next, though doing so would also constitute an illegal border crossing that neither country would appreciate. The residents of Little Diomede, who number fewer than 100, can see their Russian neighbours on clear days, but have essentially no contact with them due to the political barriers that accumulated during the Cold War and have never fully dissolved. The Hotel Arbès on the French-Swiss border offers a rather more hospitable version of cross-border living. The building straddles the international boundary so precisely that the line runs through several rooms, including a honeymoon suite where guests can sleep with their heads in one country and their feet in another. The hotel's bar is in France, while some of its dining facilities are in Switzerland, which apparently created complications during various historical periods when the 2 countries had different regulations regarding alcohol service. During World War II, the building's Swiss portions provided a refuge that German occupation forces could not legally enter, reportedly sheltering resistance members and refugees who knew exactly which side of the property line offered protection. Today, the border's main significance is conversational rather than practical, as both countries are members of the Schengen area, and the hotel operates as a single establishment, regardless of which nation any particular room technically occupies. The shortest international border in the world connects Peñón de Vélez de la Gomera, a tiny Spanish possession on the Mediterranean coast of Morocco, to the African mainland. The border measures approximately 85 metres in length, connecting a rocky outcrop that Spain has held since the 16th century to a sandbar that has gradually accumulated over time, linking what was once an island to the shore. Morocco surrounds the Spanish territory on the landward side, while the sea surrounds it on the other, creating a peculiar enclave that has no permanent civilian population and is maintained primarily for historical and military reasons. The Spanish military garrison stationed on the rock must receive all supplies by helicopter or boat, since walking across the border to Morocco for groceries would presumably raise diplomatic complications. Pheasant Island in the Bidassoa River between Spain and France holds the unique distinction of changing sovereignty on a regular schedule, alternating between the two countries every 6 months. From February to July, the island belongs to Spain. From August to January, it belongs to France. This arrangement dates to the Treaty of the Pyrenees in 1659, which ended decades of warfare between the two powers and used the island as a neutral meeting ground for negotiations. The island is uninhabited and rarely visited, but its alternating nationality makes it the world's oldest surviving condominium, a territory jointly administered by two nations, according to a schedule that has continued uninterrupted for over 350 years. Neither country seems particularly interested in asserting exclusive control, apparently finding the traditional arrangement more charming than troublesome. The India-Bangladesh border, prior to the 2015 exchange agreement, contained what may have been the most extreme enclave situation ever to exist on the planet. The region around Cooch Behar, a former princely state, included Indian enclaves within Bangladesh, Bangladeshi enclaves within India, and counter-enclaves nested within those, creating a cartographic situation so complicated that residents of some territories had to cross international borders multiple times simply to reach their own country's contiguous territory. The most extreme case involved a piece of Indian land completely surrounded by Bangladeshi territory, which was itself completely surrounded by Indian territory, which was itself completely surrounded by Bangladesh, creating a third-order enclave that had no practical access to India except through multiple border crossings. Residents of these territories existed in legal limbo for decades, often unable to access government services from either country, before the two nations finally agreed to swap the enclaves and regularize the border. The concept of borders becomes even more complicated when you consider aerial rights and the sovereignty of airspace. International law generally recognizes that a nation's territory extends upward into the air above its surface, but the practical limits of this sovereignty have never been clearly defined. Aircraft flying at commercial altitudes are subject to the jurisdiction of the country whose airspace they occupy. But what about satellites orbiting hundreds of kilometers above? The Outer Space Treaty of 1967 declares that space is the province of all mankind and cannot be claimed by any nation, but it does not specify where airspace ends and outer space begins. The generally accepted boundary is the Kármán line at 100 kilometers altitude, but this has never been formally adopted by international treaty, leaving a zone of ambiguity that has not yet caused significant problems, but presumably will eventually, as more countries and private companies develop capabilities to operate at the boundary between atmosphere and vacuum. Underwater borders present their own complications, particularly in regions where multiple countries claim overlapping portions of continental shelf or exclusive economic zone. The South China Sea has become notorious for the competing claims of China, Vietnam, the Philippines, Malaysia, Brunei, and Taiwan, all of whom assert sovereignty over various islands, reefs, and the waters surrounding them. The disputes involve not only the immediate territory but also the fishing rights, mineral resources and shipping lanes that control of these waters would confer. Some of the disputed features are barely above water, leading to the surreal situation of nations building artificial islands and military installations on what would otherwise be submerged sandbars, apparently hoping that construction activity will somehow strengthen their legal claims to sovereignty. The Arctic presents similar challenges as climate change opens new shipping routes and reveals resources that were previously inaccessible beneath permanent ice. Russia, Canada, the United States, Denmark, via Greenland, and Norway all have competing claims to portions of the Arctic seabed, based variously on continental shelf extensions, traditional use, and the somewhat circular argument that planting a flag on the ocean floor establishes sovereignty. The legal framework for resolving these disputes exists in theory through the United Nations Convention on the Law of the Sea, but the practical application of this framework to a rapidly changing polar environment is anything but straightforward. All of which serves to remind us that borders are not merely lines on land but complex legal constructions that extend in 3 dimensions, encompassing not only the surface of the Earth, but the air above and the water and earth below. The simplest border situation, a clearly marked line between two friendly countries, is actually quite rare. Most borders involve some degree of ambiguity, dispute, or practical complication that the clean lines on maps fail to convey. The Four Corners Monument, where tourists stand in 4 states simultaneously, represents an unusually tidy arrangement, the result of deliberate planning and fortunate geography. The tangled enclaves of Baal, the contested waters of the South China Sea, and the uncertain boundaries of outer space represent the more common reality, a world where sovereignty is constantly negotiated, where borders are as much legal fiction as physical reality, and where the human tendency to draw lines on maps perpetually runs up against the messiness of the actual Earth those lines attempt to describe. Perhaps the ultimate lesson of absurd borders is that our divisions are our own creations, subject to change whenever we collectively decide to change them. The enclaves of Cooch Behar, which seemed permanent features of political geography for decades, disappeared in an afternoon when India and Bangladesh signed an agreement exchanging them. The Berlin Wall, which divided a city for nearly 30 years, came down when the political will to maintain it evaporated. The boundaries we treat as immutable are merely the current state of an ongoing negotiation, the latest draft of a document that has been revised countless times before and will be revised countless times again. The absurdity of some borders reminds us that the entire enterprise of dividing the world into separate nations is, in some fundamental sense, absurd, a human invention that we maintain because we have not yet figured out a better alternative. Until we do, we will continue drawing lines on maps, maintaining cleared corridors through forests, setting our clocks to times that make no local sense, and generally muddling through the complications that our ancestors' decisions have bequeathed to us. The borders may be ridiculous, but they are our borders, and we make them work because that is what humans have always done. The phenomenon of borders changing without warning has affected millions of people throughout history, sometimes dramatically altering lives overnight. When Germany reunified in 1990, residents of East Berlin woke up one morning in a different country, with different laws, different currency, and different opportunities. The physical border that had divided the city for nearly 3 decades was suddenly irrelevant, and people who had been separated for decades could walk across streets that had previously been impassable. Similar transformations occurred when the Soviet Union dissolved in 1991, creating 15 new nations from what had been a single state, with internal administrative boundaries suddenly becoming international frontiers. Citizens who had lived their entire lives in the USSR found themselves unexpectedly classified as foreigners in places that had previously been merely other regions of their country. The Yugoslav wars of the 1990s demonstrated the human cost of border disputes at their most violent, as ethnic communities that had lived together for generations were suddenly divided into hostile camps, defined by newly significant national boundaries. The borders that emerged from that conflict remain contentious in some areas, with Kosovo's declaration of independence from Serbia in 2008 still unrecognised by many nations and creating ongoing diplomatic complications. The memory of how quickly peaceful coexistence can collapse into violence serves as a reminder that borders, for all their absurdity, represent something fundamentally serious: the delineation of who belongs where, who has power over whom, and who will defend what territory against whom. The evolution of the European Union has created yet another category of border experience, where international boundaries exist but have been deliberately stripped of most practical significance. Citizens of Schengen area countries can travel freely across borders that once required passports and visas, work and live in countries other than their birth nationality, and generally treat the continent as a single territory for most purposes. The external borders of the Schengen area have become correspondingly more significant, the line dividing those who enjoy free movement from those who must navigate the traditional complexities of immigration control. This arrangement has created its own absurdities, such as the situation during the COVID-19 pandemic, when countries reimposed border controls that had been dormant for decades, suddenly separating communities that had grown accustomed to ignoring national boundaries entirely. The question of what borders will look like in the future remains genuinely uncertain. Climate change will likely render some regions uninhabitable, while making others newly attractive, potentially triggering mass migrations that will test existing border regimes. Technological changes may make borders either more enforceable through surveillance and biometric tracking, or less relevant as economic activity becomes increasingly digital and location independent. The rise of regional blocs like the European Union suggest a possible trend toward the softening of internal borders, while the persistence of nationalist movements suggests equally strong pressure to maintain and strengthen traditional territorial divisions. What seems certain is that borders will continue to evolve, that today's arrangements will eventually seem as antiquated as the medieval treaties that created the Baal enclaves, and that future generations will have their own border absurdities to navigate and laugh about. For now, we live with the borders we have, accepting their complications as the price of organising the world into distinct political units. We stand at monuments marking arbitrary intersections, photographing ourselves in 4 states simultaneously. We navigate the patchwork boundaries of towns divided between countries, checking which nation our front door faces. We set our clocks to times that bear no relationship to the sun's position in our local sky. We maintain cleared corridors through forests to mark where one sovereignty ends and another begins. These absurdities are the visible symptoms of a deeper truth, that the world is not naturally divided into nations, that every border is a human decision that could have been made differently, and that the lines on our maps represent agreements, rather than facts. Understanding this does not make the borders less real in their effects, but it does remind us that what humans have created, humans can change. The borders that seem permanent today are merely the current arrangement, subject to revision whenever we collectively decide to revise them. Until then, we navigate their absurdities as best we can, finding humour where possible and accommodation where necessary, because that is what living with borders requires. The surface of our planet is, when you think about it, merely a very thin wrapper on an extraordinarily complicated gift. Most of us spend our entire lives walking around on this wrapper, occasionally digging a hole to plant tomatoes or install a swimming pool, never quite grasping that beneath our feet exists an entirely different universe. A universe of stone labyrinths, crystalline cathedrals, boiling rock, and life forms that have been quietly minding their own business for millions of years without ever receiving a single text message or being invited to a single meeting. Not exactly the neighbourly type, these underground dwellers, but then again, nobody has ever accused bacteria living 6 kilometres down of being social butterflies. In Kentucky, beneath rolling hills that look about as dramatic as a sleeping cat, there exists a cave system so vast that it makes most human construction projects look like children playing with building blocks. The Mammoth Cave system stretches for over 680 kilometres of surveyed passages, which is roughly the distance you would cover driving from New York City to Detroit, except instead of highway rest stops you would encounter complete and total darkness, underground rivers, and the occasional eyeless fish that evolved to navigate its world without ever having seen anything at all. These fish gave up on vision entirely, which some might argue is a perfectly reasonable response to living in a place where there is absolutely nothing to see. The name itself is a bit of a misnomer that confuses visitors every year. Despite what you might expect from a place called Mammoth Cave, no woolly mammoths have ever been found there. Not a single tusk. Not a single hair, not even a fossilized mammoth footprint expressing disappointment about the lack of mammoths. The name refers not to ancient elephants, but to the mammoth proportions of the cave itself. This is perhaps the earliest recorded instance of what we might call misleading marketing, though given that humans have been visiting these caves for at least 5,000 years, the statute of limitations on false advertising has probably expired. Besides, calling it Really Big Cave would have been accurate but considerably less impressive on the tourism brochures. The earliest known human visitors to Mammoth Cave were prehistoric Native Americans who ventured inside around 5,000 years ago, armed with nothing more than reed torches and what must have been considerable courage. They explored at least 19 miles of passages, mining gypsum from the walls for use as ceremonial pigment. These ancient explorers left behind footprints, torch marks, and occasionally themselves, as several mummified bodies have been discovered deep within the cave system. The cave's constant temperature and low humidity preserved these unfortunate individuals remarkably well, which is more than can be said for the experience that led to their preservation. The story of how we came to understand the true extent of Mammoth Cave is itself a testament to human curiosity and the occasionally maddening nature of underground exploration. For centuries, people knew about the cave's entrance and the passages that branched out from it. They mined bat guano during the War of 1812, using it to make gunpowder, which seems like an appropriately dramatic use for a substance collected from the ceiling of an underground cathedral. The workers who harvested this guano were largely enslaved people, because apparently scraping excrement off cave ceilings in total darkness was not a job that attracted a lot of volunteers. Not exactly a highlight in the history of American labor relations. The cave later served as a tuberculosis hospital, operating on the theory that the constant temperature and humidity might benefit patients with lung diseases. This theory turned out to be spectacularly wrong. The damp conditions actually accelerated the patient's decline, and the experiment was abandoned after several died. The stone huts built for the patients still stand inside the cave, monuments to 19th century medicine's enthusiasm for trying things that seemed like they might work, consequences be determined later. Good luck finding informed consent forms or clinical trials in this century. But the cave kept secrets. Just beyond walls that seemed solid, behind rubble that appeared impenetrable, existed chambers and corridors that no human eye had seen. In the 1950s and 1960s, cave explorers began to suspect that several separate cave systems in the area might actually be connected. Proving this required the kind of dedication that borders on obsession. Teams of spelunkers spent years crawling through muddy passages, squeezing through gaps that would make a claustrophobic person weep, all in pursuit of connections that might or might not exist. This wasn't exactly a hobby for the faint of heart, or for anyone who valued clean clothing. One of the most significant figures in Mammoth Cave's exploration was Stephen Bishop, an enslaved man who became the cave's most famous guide in the 1840s. Bishop possessed an extraordinary ability to navigate the underground maze and an equally extraordinary memory for its passages. Working by the light of a lard oil lamp that produced approximately as much illumination as a particularly optimistic candle, he discovered major features including vast chambers that now bear names like Mammoth Dome and the ruins of Karnak. He created one of the first accurate maps of the cave system, a document that remained useful for over a century. Bishop described the cave as a grand, gloomy and peculiar place, which is the kind of understated assessment that only makes sense when you consider he was navigating it with technology that was already ancient by his time. He died in 1857 and is buried in the Old Guides Cemetery near the cave entrance, which seems appropriate for a man who spent most of his working life underground. His grave, like his life, remains part of Mammoth, a permanent resident of the place he knew better than perhaps anyone. The breakthrough in understanding Mammoth Cave's true extent came in September of 1972, when explorers from two different cave systems found signatures left by earlier cavers in a passage they called the Lost River. A week later, during an unusually low water table that left normally flooded passages temporarily dry, a team of 6 cavers made history. They entered through one cave system and emerged from another, proving that what had been considered separate caves were actually one interconnected labyrinth. The combined system measured over 140 miles at that moment, instantly becoming the longest known cave on Earth. Since then, the cave has only grown longer as explorers continue to find new passages. In 1979, connections were established to caves beneath Joppa Ridge. In 1983, the system expanded again when it was connected to Roppel Cave, pushing the total surveyed length toward 300 miles. As of recent surveys, over 426 miles have been mapped, with scientists projecting the system may eventually prove to be over 560 miles long. Every year, explorers add more miles to the total, and every year the cave proves that it still has secrets to reveal. What makes Mammoth Cave particularly fascinating is not just its length, but what it reveals about the nature of underground spaces. The cave exists because of a geological fortunate accident. 2 layers of rock underlie the Kentucky hills, a limestone layer that dissolves in acidic water, and above it a layer of sandstone and shale that acts as a protective cap, sometimes reaching 50 feet thick. Water seeps through cracks in this cap and slowly, over millions of years, carves out the limestone below. The result is a 5-level system of passages that represent different stages of water, table levels throughout geological history. The cave maintains a constant temperature of around 12 degrees Celsius year-round, which is pleasant for visiting but rather chilly for extended stays. Good luck finding central heating or thermal underwear in this environment. The humidity hovers near 87%, which does interesting things to your hair, and even more interesting things to electronic equipment. The darkness is absolute in a way that surface dwellers rarely experience. Turn off your light in Mammoth Cave and you will discover what total darkness actually means. Your eyes will never adjust because there is nothing to adjust to. Not exactly the romantic underground adventure you see in movies. Life has found ways to exist even here, which should surprise exactly no one who has studied life's remarkable ability to colonize every available niche. Eyeless fish swim in underground rivers, their ancestors having abandoned vision as an unnecessary luxury millions of years ago. Cave crickets navigate by touch, their antennae serving the function that eyes serve for surface creatures. White spiders hunt in the perpetual darkness, their bodies having shed the pigmentation that their surface cousins use for protection and communication. There are over 130 species living in Mammoth Cave, making it one of the most diverse cave ecosystems ever documented. These creatures represent an entirely different approach to existence, one that reminds us that life will find a way to fill almost any niche, even one that seems, from our sun-loving perspective, fundamentally inhospitable. The eyeless fish in particular have become subjects of intense scientific study. Their ancestors had perfectly functional eyes. When populations became isolated in caves, those eyes became not just unnecessary but actually harmful. Eyes are metabolically expensive to maintain and provide entry points for infection. In an environment without light, fish that invested less energy in eyes could invest more in other survival mechanisms. Over thousands of generations, the cave populations lost their eyes entirely, gaining enhanced senses of touch and taste in compensation. But if Mammoth Cave represents the horizontal extreme of underground exploration, Vietnam offers something entirely different. A cave so large that it has developed its own weather system, which is the kind of sentence that sounds like it should be, followed by a punchline but is actually completely accurate. Sun Dun Cave, which translates roughly to Mountain River Cave, is the largest known cave passage in the world by volume. To give you a sense of scale, the main passage is over 5 kilometers long, 200 meters high in places, and wide enough that a Boeing 747 could fly through it without touching the walls. You could fit an entire New York City block inside, complete with skyscrapers, and still have room for a modest park. Not that anyone has tried this, though the mental image is admittedly entertaining. The cave was discovered in 1990 by a local forager named Ho Khan, who was seeking shelter from a storm in the jungle of Bong Na Ke Bang National Park. He noticed clouds billowing from an opening in a limestone cliff and heard the roar of a river somewhere inside. Wisely deciding that exploring strange holes in cliff faces during thunderstorms was perhaps not the safest recreational activity, he noted the location and moved on. Then, somewhat inconveniently, he forgot exactly where it was. This is the cave exploration equivalent of forgetting where you parked your car, except the parking lot is a dense tropical jungle, and the car is a hole in a mountain. For the next 18 years, Ho Khan tried to find the entrance again. The jungle in this part of Vietnam is dense, hot, and remarkably good at hiding things. It's the kind of vegetation that swallows ancient temples whole and digests them over centuries. He made multiple attempts, marking trees, consulting his memories, and presumably becoming increasingly frustrated with the entire situation. Finally, in 2008, he rediscovered the entrance and led a team of British cave explorers to the site the following year. One imagines the satisfaction of finally locating something you had lost for nearly 2 decades, combined with the mild embarrassment of having lost a cave in the first place. What they found inside defied expectations, and the expectations were already fairly high given the dramatic clouds and river sounds emanating from the entrance. The main passage was so large that the explorers' lights could not reach the ceiling. Their progress was eventually halted by a massive flowstone wall, 60 meters high, which they named the Great Wall of Vietnam because naming things after famous walls is apparently what you do when you encounter unexpected walls in caves. 2 massive skylights called dolines have formed where the cave roof collapsed, allowing sunlight to stream into the underground world. These openings have created something unprecedented, actual jungles growing inside the cave. Trees 30 meters tall rise from the cave floor, their roots anchored in soil that has washed in over millennia. Ferns and mosses carpet the ground. Flying foxes navigate between the cavern walls and the forest canopy. Scientists identified 7 species found nowhere else on Earth, including white fish, white spiders, and white centipedes that have adapted to life in this strange twilight world. Not exactly your typical ecosystem, but then nothing about Son Doong is typical. The cave is so large that it generates its own localized weather. Clouds form inside the main passage as temperature and humidity create the conditions for condensation. Explorers report walking through mist that has formed underground, watching it rise toward the distant ceiling like some sort of geological magic trick. The effect is surreal, like stepping into a world where the normal rules of above and below have been temporarily suspended. The cave even has its own beaches, sandy areas along the underground river where explorers can camp for the night, which sounds considerably more pleasant than it probably is. Reaching Sondung requires commitment that borders on the unreasonable. The journey involves a 2-day trek through dense jungle, including river crossings and steep climbs. The cave itself can only be entered during certain months when water levels are low enough to permit safe passage. A maximum of 1,000 visitors per year are allowed inside, and the experience costs several $1,000s. This is not exactly a casual weekend trip, and it serves as an effective filter ensuring that only the genuinely dedicated actually make it inside. The stalagmites inside Sondung are among the largest ever documented, some reaching 80 meters in height. Cave pearls the size of baseballs lie scattered across the floor, formed over countless millennia as minerals slowly accreted around tiny nuclei. A formation called the wedding cake resembles exactly what its name suggests, a massive layered structure of flowstone that could serve as the centerpiece for a celebration attended exclusively by geology enthusiasts and people with extremely unusual wedding venue requirements. The cave is only about 3 million years old, which makes it relatively young in geological terms, something of a teenager by cave standards. The limestone through which it was carved, however, dates back roughly 400 million years. This temporal disconnect is typical of cave systems. The rock exists for unimaginable periods before the right conditions conspire to hollow it out. The cave formed when 2 rivers, the Kei Rai and the Rao Thuong, joined together and began dissolving the limestone along a major fault line, eventually creating a passage large enough to fly aircraft through, though this remains inadvisable. There was briefly discussion of building a cable car through Sondung, a proposal that would have cost between $112 and $211 million and would have allowed mass tourism to reach the cave's interior. Environmental groups and locals opposed the plan, pointing out that mass tourism and delicate cave ecosystems tend not to mix well. The proposal was shelved, preserving Sondung's status as one of the most exclusive and least accessible tourist destinations on Earth, which is probably for the best. But if Vietnam offers us caves of unimaginable volume, Russia provides a different kind of extreme, depth that challenged everything scientists thought they knew about what exists beneath our feet. The Kola Superdeep Borehole is not technically a cave, but it represents humanity's most ambitious attempt to penetrate the Earth's crust, and what it discovered challenges many assumptions about the underground world. Located on the Kola Peninsula near the Norwegian border, in a region so remote that the nearest significant civilization is quite far away, this Soviet-era project began drilling in 1970 and continued with various interruptions until 1994. Not exactly a weekend project. The goal was straightforward in concept if mind-bogglingly difficult in execution. Drill as deep as possible into the continental crust and see what you find. The project was partly scientific curiosity and partly Cold War competition. The Americans had attempted something similar in the 1960s with Project Moholy, which aimed to drill through the oceanic crust beneath the Pacific. That project was abandoned due to funding issues, which was probably convenient for the rocks that were about to be violated. Drilling from a ship pitching in the open ocean turned out to be exactly as difficult as it sounds. The Soviets chose a different approach. Instead of drilling through thin oceanic crust, they would penetrate thick continental crust on land. This meant drilling through much more rock, but it also meant not having to conduct operations from a ship, which greatly simplified the logistics, if not the engineering. They selected a site on the Kola Peninsula where ancient Precambrian rock was exposed at the surface, providing access to some of the oldest crust on the planet. The drilling required technological innovations that had never been attempted before. At conventional depths, you can spin the entire drill string to turn the bit at the bottom, but the Kola borehole was so deep that the drill string weighed over 1 million pounds. Spinning that much weight would have twisted the drill pipe like a pretzel. Instead, Soviet engineers invented a rotary bit that spun at the end of the drill string while the pipe itself remained stationary, an elegantly simple solution to an enormously complex problem. What the team discovered as they drilled deeper, fundamentally changed our understanding of the Earth's interior. At 7 kilometers down, they expected to find a sharp boundary between granite and basalt, a feature called the Conrad discontinuity that seismic studies had suggested should exist. The seismic waves had indicated a clear change in rock properties at this depth, which geologists had interpreted as the transition from one rock type to another. It wasn't there. Instead, the rock simply changed gradually, the granite becoming denser and more metamorphosed with depth. The seismic data had been misinterpreted, which is a polite way of saying that our models were wrong. Not exactly a confidence booster for geological theory. Even more surprising was the discovery of water. Lots of water. At depths where pressure should have squeezed out any liquid, mineralized water was found flowing through fractures in the rock. Scientists described the drilling mud flowing from the borehole as boiling with hydrogen gas, a phenomenon nobody had predicted. This water had been trapped for billions of years, slowly interacting with the surrounding stone, creating conditions that no one had anticipated would exist. The water was apparently created by intense pressure forcing hydrogen and oxygen atoms together in the rock itself, a process that continues even today. And then there was the life. At 6 kilometers down, in rock that was 2.7 billion years old and had never seen sunlight, scientists found microscopic fossils of plankton. 24 different species of ancient single-celled organisms had been preserved in conditions of extreme heat and pressure, their organic compounds somehow surviving transformations that should have destroyed all traces of their existence. Finding fossils at such depth suggested that the deep biosphere, the realm of underground life, might be far more extensive than anyone had imagined. Not exactly what you expect to find several miles beneath your feet. The drilling stopped at 12,262 meters, which is about 40,000 feet or roughly 12 kilometers. This is deeper than Mount Everest is tall, deeper than the Mariana Trench, the deepest point in the world's oceans. If you could somehow place the borehole vertical to the ocean floor, it would extend into the mantle. The borehole penetrated rock that formed 2.7 billion years ago, near the beginning of the Archean Eon when Earth was a fundamentally different world. Why did they stop? Temperature, that most mundane of obstacles. As you drill deeper into the Earth, temperatures rise at a rate of roughly 25 to 30 degrees Celsius per kilometre. At 12 kilometres, the temperature reached 180 degrees Celsius, far higher than models had predicted. The models had suggested perhaps 100 degrees Celsius at this depth. The difference was significant because at 180 degrees, the rock behaves less like solid stone and more like thick plastic, slowly flowing and deforming in ways that make drilling nearly impossible. The drill bits would essentially be trying to bore through warm putty, and the putty was winning. Today, the Kola Superdeep borehole sits abandoned in the Russian Arctic, sealed with a rusted metal cap that looks comically inadequate given what lies beneath it. The site has fallen into disrepair, the drilling tower long since dismantled, the facilities crumbling. Visitors report an eerie atmosphere, standing above a hole that penetrates deeper into the Earth than any other place on the planet, while surrounded by the ruins of a project that, for all its success, ultimately failed to achieve its goal of reaching the mantle. Not exactly a tourist hotspot, though it does attract a certain kind of curious visitor. The borehole did, however, produce one memorable hoax. In the late 1980s, a story began circulating that Soviet scientists had drilled into hell itself, capturing audio recordings of tortured souls screaming in the depths. This story was entirely fabricated, apparently created by a Finnish Christian newsletter, and then amplified by American religious broadcasters who found it theologically convenient. The actual discoveries from Kola were fascinating enough without supernatural embellishment, but apparently ancient plankton fossils are less compelling to some people than imaginary demons. The scientists who actually worked on the project found the hoax bemusing, having spent decades doing actual science only to be overshadowed by a fictional recording of hell. Moving from Russia to Mexico, we find perhaps the most visually spectacular underground environment ever discovered. A cave so hostile to human life that it can kill you in minutes, yet so beautiful that people have risked their lives to document it. The Cave of Crystals, or Cueva de los Cristales, sits 300 meters beneath the Sierra de Nica mountain in the Chihuahuan Desert. It was discovered in the year 2000 by two miners, the Sanchez brothers, who broke through into a horseshoe-shaped chamber filled with the largest natural crystals ever documented. These selenite beams, a transparent form of gypsum, reach lengths of over 11 meters and weights of up to 55 tons. Some are wider than a human is tall. Walking through the cave, if you could survive long enough to walk, would be like navigating through a frozen forest of translucent logs. Not that walking is particularly easy when the air temperature is trying to cook you. The crystals grew to such incredible size because of conditions that existed for about 500,000 years, which is the kind of patience that makes even the most dedicated long-term investor look impulsive. The cave sat filled with mineral-rich water maintained at a constant temperature just above 56 degrees Celsius. At this temperature, a mineral called anhydrite dissolves while gypsum remains stable, allowing the crystals to grow at an almost impossibly slow rate. Scientists calculated the growth rate at roughly 1 nanometer per century, which means the largest crystals took approximately 1 million years to reach their current size. Not exactly rapid development. The catch, because there is always a catch with anything this beautiful, is that the cave remains at this temperature even without the water. When the mine began pumping water out of the mountain to access ore deposits below, the cave drained, exposing the crystals to air for the first time since they began forming. The air temperature hovers around 50 degrees Celsius with humidity near 100%. For humans, this combination is lethal, essentially turning the cave into a very scenic sauna with no exit. At 50 degrees Celsius, your body cannot dissipate heat through sweating because the air is already saturated with moisture. Sweating works by evaporation, and evaporation cannot occur when the surrounding air is already at maximum humidity. Your core temperature begins to rise rapidly. Without protection, you would experience heat stroke within 10 to 15 minutes. Even with specialized cooling suits and ice packs, researchers could only spend about 30 minutes inside before needing to evacuate. The BBC documentary team that filmed the cave for Planet Earth spent 2 years obtaining permission, and only managed brief shooting sessions before their equipment began to fail. Not exactly comfortable working conditions. NASA researchers found something remarkable inside the crystals, microbial life forms that had been dormant for perhaps 50,000 years. When revived in laboratory conditions, some of these organisms became active again, proving that life can survive in suspended animation for geological timescales. The implications for astrobiology are significant. If life can survive for tens of thousands of years inside crystals on Earth, perhaps it could survive similar conditions on other worlds. The cave that kills humans in minutes had preserved microscopic life for millennia. In 2017, the mining company that had been pumping water out of the mountain ceased operations. The cave began to refill, slowly submerging the crystals that had taken 500,000 years to grow. This was probably good for the crystals, which had begun to deteriorate in the air, but disappointing for anyone who had hoped to study them further. The crystals now sit beneath the water table, visible only to those willing to navigate flooded mine shafts in extreme conditions. Their beauty persists, witnessed only by the darkness. Another underground marvel exists in New Mexico, though it trades deadly heat for scientific significance. Lechuguilla Cave sits within Carlsbad Caverns National Park, though it receives far less attention than its famous neighbour. For most of its known history, it was considered insignificant, a 90-foot entrance pit leading to a few hundred feet of dead-end passages. Miners had extracted bat guano from it in the early 20th century and moved on, having found nothing else of interest. Nobody expected anything significant to be hidden behind the rubble at the back of the cave. In 1986, a team of persistent cave explorers dug through a blockage and broke into what turned out to be one of the most significant cave discoveries in American history. Beyond the rubble lay more than 240 kilometers of passages decorated with formations found nowhere else on Earth. 20-foot gypsum chandeliers hang from the ceiling. Crystal formations called helictites twist in directions that seem to defy gravity. The cave contains hydromagnesite balloons, cave pearls, and formations so delicate that a careless footstep could destroy structures that took hundreds of thousands of years to form. Not exactly the kind of place where you want to trip. Access to Lechuguilla is strictly controlled, more restricted than some military installations. Only approved scientific researchers and exploration teams are permitted entry. No tourists, no casual visitors, no documentary crews except on extremely rare occasions. The cave is simply too pristine and too scientifically valuable to risk contamination. This policy has preserved an environment that offers a window into conditions that existed on Earth billions of years ago. The bacteria living in Lechuguilla have proven particularly fascinating. Isolated from the surface for at least 4 million years, these microorganisms have evolved without any exposure to human medicine. Yet when researchers tested them against modern antibiotics, they found something remarkable. The cave bacteria were resistant to almost every drug in our pharmaceutical arsenal, including last resort medications like daptomycin. 70% of the strains resisted 3 to 4 different antibiotic classes. 3 strains could shrug off 14 different types. This discovery was not cause for alarm but for hope, which is not the reaction you might expect when discovering antibiotic-resistant bacteria. The bacteria had not evolved resistance in response to human antibiotic use. They had developed these defenses over millions of years as part of their natural competition with other microorganisms. Antibiotic resistance, it turns out, is not a new phenomenon created by medical overuse. It is an ancient survival strategy that bacteria have employed since long before humans existed, much less invented penicillin. For pharmaceutical researchers, this means that somewhere in the caves of the world, there may exist microorganisms that have already solved the puzzle of antibiotic resistance. By studying how cave bacteria defend themselves and attack their competitors, we may discover new classes of antibiotics, new mechanisms of action, new ways to treat infections that currently resist all known treatments. The caves beneath our feet may literally hold the keys to saving human lives, which is considerably more valuable than bat guano. The underground world also hosts life that has taken evolution in directions that challenge our surface-dwelling assumptions. In caves across the world, organisms have adapted to total darkness by abandoning features that their ancestors spent millions of years developing. Vision becomes useless when there is nothing to see, and maintaining eyes requires energy that could be better spent elsewhere. Cave crickets lost their ability to chirp because sound provides no advantage in lightless environments, where potential mates cannot see elaborate displays anyway. Cave spiders lost their pigmentation because camouflage is pointless when nothing can see you. Crustaceans extended their antennae far beyond what surface relatives maintain because touch became their primary sense. These creatures remind us that evolution does not have a direction. It does not march toward complexity or capability. It simply responds to conditions. In environments where certain features provide no advantage, those features tend to disappear, their maintenance costs no longer justified. The caves beneath our feet are laboratories of regression, places where evolution runs in what we might perceive as reverse, stripping away adaptations that took millions of years to develop. The blind fish in Mammoth Cave lost eyes that their ancestors had refined over hundreds of millions of years. The white spiders of Lechuguilla shed pigments that had protected their surface ancestors for eons. These losses were not failures. They were adaptations, proof that evolution optimizes for current conditions rather than preserving past achievements. The deep biosphere, as scientists call this realm of underground life, may contain more biomass than all the life on Earth's surface combined. This is a staggering concept if you pause to consider it. The familiar world of forests and oceans, of elephants and whales and all the creatures we consider abundant, may represent only a fraction of the planet's total living material. The rest exists in the dark, in rock, in sediment, in places where no light has ever penetrated and no photograph could ever be taken. These deep-dwelling organisms live on timescales that make surface life seem frenetic by comparison. Some bacteria in deep rock formations may divide only once every few centuries, their metabolism so slow that what we consider a single generation could span the rise and fall of human civilizations. They extract energy from chemical reactions, from the slow decay of radioactive elements, from any source that provides enough to sustain the most minimal form of existence. Not exactly living in the fast lane. The implications extend beyond Earth. If life can exist kilometers below the surface, surviving on chemical energy and completely independent of the sun, then similar life might exist beneath the frozen surfaces of other worlds. The moons of Jupiter and Saturn, with their ice shells covering liquid water oceans, suddenly become more interesting as potential habitats. Mars, with its subsurface ice and possible liquid water at depth, might harbour microbial communities that would look familiar to researchers who study Earth's deep biosphere. The caves beneath our feet may be preparing us to understand life throughout the solar system. There is something humbling about contemplating worlds that exist entirely without our awareness or involvement. The blind fish in Mammoth Cave does not know that humans have visited its domain. The bacteria in Lechuguilla Cave have no concept of the surface world above them. The crystals in nacre grew for 500,000 years without any witness at all. These places existed before us and will continue after us, indifferent to our presence or absence, monuments to time and geology that dwarf human concerns. The underground world extends even to places we would not typically think of as caves at all. Beneath the permafrost of Siberia, ancient methane trapped in ice is slowly escaping as temperatures rise. Some of this gas has been frozen for hundreds of thousands of years, a time capsule of atmospheric conditions from eras long before human existence. As it escapes, it creates sinkholes and craters that appear seemingly overnight, new holes in the earth that remind us how little we understand about what lies beneath our feet. In Helsinki, planners have created an entirely different kind of underground world, a deliberately designed subterranean city. Tunnels connect shopping centres, swimming pools, churches, and hockey arenas. You can travel for kilometres without ever seeing daylight. In winter, when the Finnish sun barely rises above the horizon, these underground spaces provide warmth and light that the surface cannot offer. It is a reminder that humans too can adapt to life beneath the ground, even if we require considerably more infrastructure than blind fish. The next time you walk across solid ground, consider what might be beneath your feet. Perhaps nothing but rock and dirt, or perhaps a cave system yet undiscovered, a crystal chamber waiting millions of years for someone to find it, or an ecosystem of organisms that have never seen the sun and never will. The surface is just the beginning. The real world extends downward into darkness, into depths we have barely begun to explore, into secrets that may take centuries more to uncover. If the present state of our planet seems fixed and permanent, that is merely because human lives are too short to notice otherwise. We suffer from a kind of temporal provincialism, assuming that the world we see around us represents how things have always been and always will be. This assumption is spectacularly wrong. The Earth changes. It changes dramatically, repeatedly, and often in ways that would make the current occupants of any given location profoundly uncomfortable. The deserts of today were the gardens of yesterday. The ice sheets of the poles once covered continents that are now temperate, and places we consider inhospitable have hosted some of the most abundant life in planetary history. Not exactly a stable real estate market. Consider the Sahara Desert. 9 million square kilometres of sand, rock, and extreme temperatures that currently support about 2.5 million people, most of them concentrated in oases and river valleys. The Sahara receives less than 25 millimetres of rain per year in its driest regions, which is barely enough moisture to keep sand damp, much less grow crops. Temperatures can exceed 50 degrees Celsius during the day and drop below freezing at night. It is, by any reasonable measure, one of the least welcoming places on Earth for human habitation. Not exactly prime vacation destination, unless you have very specific ideas about what constitutes a good time, except that 10,000 years ago, it was not a desert at all. During a period that climatologists call the African humid period, the Sahara was a vast grassland dotted with lakes, crossed by rivers, and populated by elephants, giraffes, hippopotamuses, and crocodiles. Human settlements flourished in what is now the most barren portion of the African continent. People fished in lakes that no longer exist, hunted game that could not survive there today, and left behind rock art depicting a world so different from the current Sahara that early European explorers refused to believe the paintings were authentic. Surely, they reasoned, these were fantasies, artistic imaginings of abundance created by people who knew only harsh desert conditions. The idea that the paintings were simply documenting reality seemed preposterous. The evidence for this green Sahara is overwhelming and comes from multiple independent sources. Rock art discovered across the region depicts pastoral scenes, cattle grazing, people swimming, hippopotamuses wallowing in rivers. A German explorer named Heinrich Barth became the first European to document these paintings in the mid-1800s while crossing from Tripoli to Timbuktu, a journey that took months and must have offered plenty of time to contemplate why anyone would paint swimming scenes in the middle of a desert. These images are not the product of overactive imagination. They were created by people who were simply documenting their world, a world that happened to look nothing like the desert we see today. Lake Chad, currently a shrinking body of water that provides critical resources for millions of people in Central Africa, was once 10 times its present size. Scientists call this ancient version Lake Megachad, a name that sounds like it should belong to a particularly large fraternity member rather than a body of water. At its maximum extent, Megachad covered an area roughly the size of the Caspian Sea, perhaps 8% of the entire Sahara region. It measured approximately 1,000 kilometers from north to south, and 600 kilometers from east to west. Rivers fed into it from mountains that are now bone dry. Fish swam in its waters that are now found only hundreds of kilometers to the south. It was, briefly on geological timescales, one of the largest lakes on Earth. A wooden boat discovered in northern Nigeria in 1987 provides perhaps the most tangible evidence of this vanished world. The Dufuna canoe, as it came to be known, dates to approximately 8,500 years ago and is considered the second oldest boat ever discovered. It is over 8 meters long and represents sophisticated boat-building technology, not the rough dugout you might expect from prehistoric peoples. The question is, why would anyone build a sophisticated boat in what is now the southern edge of the Sahara Desert? The answer is that when the boat was built, there was water to sail it on. Rivers and lakes that have been dry for millennia once provided highways for travel and trade. Not exactly a detail you want to overlook when reconstructing ancient history. What caused this dramatic transformation from grassland to desert? The answer lies in the wobble of the Earth's axis, which sounds like it should be a problem requiring a very large mechanic, but is actually a normal part of our planet's motion through space. Our planet does not spin perfectly upright. Its axis is tilted at approximately 23.5 degrees relative to its orbital plane, which is why we have seasons. But this tilt is not constant. Over a cycle of roughly 23,000 years, the Earth wobbles like a spinning top, a phenomenon called precession. This wobble affects how much solar energy reaches different parts of the planet at different times of year. The effect is subtle but significant, especially when accumulated over thousands of years. During certain phases of this cycle, the northern hemisphere summer receives more intense solar radiation. This intensified heating strengthens the West African monsoon, pulling moisture-laden air further north into regions that are currently too dry to support vegetation. The increased rainfall allows plants to grow. Plants release moisture through transpiration, which increases cloud formation and rainfall. The system feeds on itself, transforming desert into grassland through a positive feedback loop that continues as long as the orbital geometry supports it. Then the cycle shifts. The wobble continues, the monsoon weakens, the rains retreat southward, the plants die, the lakes dry up. The people who live there are forced to migrate or adapt to increasingly harsh conditions. Within a few thousand years, the Green Sahara becomes the Desert Sahara, and only the rock art remains to testify that things were ever different. Not exactly a gradual transition by human standards, though geological processes rarely consult our preferences. The transition happens surprisingly quickly by geological standards, much faster than the orbital changes alone would suggest. Core samples from ocean sediments off the coast of West Africa show that dust levels, which indicate desert conditions, increase dramatically over just a few centuries. The Green Sahara did not fade slowly into sand. It collapsed relatively suddenly into the arid state we know today. Some researchers believe that human activity, particularly overgrazing by early pastoralists, may have accelerated this transition. Domesticated cattle and goats could have stripped vegetation faster than it could regenerate, removing the plants that recycled moisture back into the atmosphere. The orbital changes would have caused desertification eventually regardless, but human activity may have pushed the system over the edge sooner. This cycle is repeated many times throughout Earth's history with the regularity of a very slow clock. Scientists have identified over 230 instances of Saharan greening over the past 8 million years, roughly one every 35,000 years. Each time, the desert blooms. Each time, it withers again. The current Sahara is simply the latest iteration of a pattern that has been playing out far longer than humans have existed, much less started arguing about climate change. Which raises an interesting question. Could the Sahara become green again? The answer is yes, probably in about 10,000 years when the orbital cycle brings conditions favourable to North African rainfall once more. Whether humans will still be around to see it, and whether the transformation will be welcomed or catastrophic for whatever civilization occupies that part of the world, are questions that cannot be answered from our current vantage point. Future residents of North Africa may look forward to the change, or they may have built their entire civilization around desert conditions and find the arrival of grassland highly inconvenient. History does not record preferences. If the Sahara represents a desert that was once green, Greenland represents ice that was once sold as green, which brings us to perhaps history's first documented real estate scam, perpetrated by a Norse outlaw with anger management issues and a gift. For marketing, Erik Thorvaldsson, better known as Erik the Red due to his hair colour and possibly his temperament, was exiled from Iceland around 982 CE for killing several of his neighbours. This was not his first offence. His father had been exiled from Norway for similar reasons, suggesting that anger management issues ran in the family. With 3 years of exile to kill and nowhere else to go, Erik sailed west and discovered a large, mostly ice-covered island that previous Norse sailors had spotted but never settled. Finding a new continent was apparently easier than not getting into fatal arguments with neighbours. Erik spent his exile exploring the coastline, identifying areas suitable for settlement in the southwestern fjords, where the climate was slightly less brutal than the rest of the island. When his exile ended, he returned to Iceland with a plan. He needed settlers to join him in establishing a colony on this new territory. The problem was that the territory in question was roughly 80% covered in permanent ice, offered limited agricultural opportunities, and featured a climate that made Iceland seem balmy by comparison. Not exactly an easy sell. His solution was elegant in its simplicity: lie. Erik named the island Greenland, according to the sagas, because he believed people would be more likely to come if the place had an attractive name. This is literally what the historical sources say. It was not a misunderstanding or a translation error. The Icelandic sagas record Erik's own reasoning. People would be attracted to go there if it had a favourable name. Erik the Red deliberately chose a misleading name to lure settlers to an ice-covered rock in the North Atlantic. Not exactly truth in advertising. Remarkably, it worked. In 986 CE, Erik led a fleet of 25 ships carrying several hundred settlers toward Greenland. Only 14 ships arrived. The others were lost to storms or turned back, which was probably the appropriate response to discovering that Greenland was not, in fact, particularly green. The survivors established 2 settlements on the southwestern coast, which they optimistically named the Eastern Settlement and the Western Settlement. These colonies would persist for over 400 years before mysteriously disappearing in the 15th century. To be fair to Erik, Greenland was not entirely false advertising. The southwestern fjords where the Norse settled did have grassland suitable for grazing livestock, at least during the medieval warm period that coincided with the early centuries of Norse settlement. Conditions were somewhat more favourable than they would later become when the Little Ice Age made life increasingly difficult. The settlers could raise cattle and sheep, produce dairy products, and supplement their diet with fish and marine mammals. It was not exactly a tropical paradise, but it was survivable, which by Viking standards probably qualified as attractive. But the name Greenland was and is fundamentally misleading in ways that Erik surely understood. The Greenland ice sheet covers about 1.7 million square kilometres and contains enough frozen water that if it melted completely, global sea levels would rise by roughly 7 metres. The ice reaches depths of over 3 kilometres in places. It is not a green land. It is a white land, occasionally grey around the edges where rock is exposed, with small patches of actual vegetation confined to coastal margins during brief summer months. Calling it Greenland is like calling Antarctica tropical beach paradise. The contrast with Iceland, which was named honestly if pessimistically, is instructive. Iceland received its name from an early Norse explorer named Floki Vilgerdarson, who arrived during winter, saw a fjord filled with ice, and apparently decided to commemorate the experience in the island's name. Iceland is actually far more hospitable than Greenland, with extensive green areas during summer, hot springs, and a climate moderated by the Gulf Stream. Its name undersells it dramatically. Greenland's name oversells it dramatically. The Norse apparently had a complicated relationship with truth in geographical naming. Erik the Red presumably did not anticipate that his marketing strategy would confuse people for over 1,000 years, but here we are. Tour companies still have to explain to visitors that Greenland is not, in fact, particularly green. The name has become a classic example of the gap between branding and reality, proving that the first rule of real estate applies even to ice-covered Norse colonies. Location, location, location matters less than the story you tell about it. Erik would have made an excellent advertising executive. While Greenland acquired a deceptive name from a Viking with questionable ethics, Antarctica simply sat at the bottom of the world, unnamed and unknown, hosting one of the most dramatic climate reversals in planetary history. Today, Antarctica is the coldest, driest, windiest continent on Earth, a collection of superlatives that sounds impressive until you realize they all relate to making life miserable. The lowest temperature ever recorded on the planet's surface occurred at the Soviet Vostok station in 1983, minus 89.2 degrees Celsius, cold enough to make exposed flesh freeze within seconds. The interior of the continent receives less precipitation annually than the Sahara Desert, making it technically the world's largest desert, though nobody goes there for the sand. Winds can exceed 300 kilometers per hour. It is, by almost any measure, the most hostile environment for life on the planet's surface. Not exactly a vacation destination, and yet 90 million years ago Antarctica was covered in temperate rainforest. This fact, discovered through analysis of sediment cores extracted from the ocean floor near the continent, fundamentally changed our understanding of what climate conditions were possible on Earth. Scientists found fossilized pollen and spores from plants, including flowering plants, in sediments that had been deposited within a few hundred kilometers of where the South Pole was located at the time. CT scans revealed dense networks of fossilized roots, the remnants of forests that had grown in what should have been, according to previous models, permanently frozen ground. The preservation was so extraordinary that researchers could distinguish individual cell structures. The forests of Cretaceous Antarctica were not tropical jungles, but they were surprisingly lush for their latitude. Mean annual temperatures hovered around 12 degrees Celsius, comparable to present-day Seattle or London. Summer temperatures reached the high teens. Even during the 4 months of polar winter when no sunlight reached this part of the world, temperatures remained above freezing. Plants somehow survived extended darkness, then flourished when the sun returned. Not exactly normal growing conditions, but plants have proven remarkably adaptable. How is this possible at a latitude that should have been frozen solid? The answer is greenhouse gases, specifically carbon dioxide. During the mid-Cretaceous period, atmospheric CO2 concentrations were dramatically higher than they are today, perhaps 4 to 5 times current levels. This intense greenhouse effect raised global temperatures to the point where ice sheets could not form even at the poles. Without reflective ice to bounce solar energy back into space, the planet absorbed more heat, creating a feedback loop that maintained warm conditions from equator to pole. Not exactly the climate stability we've grown accustomed to. The implications of this ancient Antarctic climate are significant for understanding our own future. If carbon dioxide levels rose high enough, the ice sheets would melt. Antarctica would become vegetated again. Sea levels would rise by 60 meters or more, redrawing the coastlines of every continent. Cities that are currently major population centers would be underwater. This is not speculation about what might happen. It is documentation of what did happen repeatedly throughout Earth's history. The past is a laboratory for testing what the future might bring. Fossil discoveries in Antarctica continue to reveal the diversity of life that once existed there. Dinosaurs roamed Antarctic forests during the Cretaceous period. A crested theropod nicknamed the Elvosaurus for its pompadour-like head crest hunted plant-eating dinosaurs in landscapes that would later be buried under kilometers of ice. Marine reptiles swam in seas that are now frozen solid for most of the year. The Antarctic Peninsula, specifically Seymour Island, has proven to be one of the most important fossil sites on Earth, preserving remains from the period immediately before and after the mass extinction that ended the age of dinosaurs. British explorer Robert Falcon Scott discovered fossilized plant remains during his ill-fated expedition to the South Pole in 1912. He and his crew collected specimens of Glossopteris, an ancient tree, even as they were dying from exhaustion and cold on their return journey. The samples were found with their bodies months later, testament to the expedition's scientific commitment even in dire circumstances. Those fossils helped confirm that Antarctica had once supported plant life, though the full extent of past Antarctic warmth would not be understood for decades. The transformation from forested Antarctica to frozen Antarctica began roughly 34 million years ago, when the continent separated from South America and Australia, completing its isolation at the South Pole. Ocean currents that had previously brought warm water from the tropics were blocked by the newly opened passages. The Antarctic circumpolar current formed, isolating the continent within a ring of cold water. Temperatures dropped. Snow began to accumulate. Over millions of years, the ice sheets grew to their present enormous extent. This transition was not smooth or uniform. The climate oscillated, with warmer periods allowing temporary retreats of the ice and cooler periods causing advances. As recently as 12 million years ago, tundra vegetation similar to that found in northern Canada or Siberia may have persisted on parts of the Antarctic peninsula. The final freezing of the continent, the complete disappearance of anything resembling terrestrial ecosystem, occurred relatively recently in geological terms. What remains today is a continent almost entirely devoid of the complex life that once flourished there. Antarctica is the only continent without reptiles, amphibians, or terrestrial mammals. The largest permanent land animal is a flightless insect called the Antarctic midge, less than a centimetre long, which has adapted to survive freezing solid during winter and thawing out each summer. Penguins and seals breed on the coast but spend most of their lives in the surrounding seas. The interior is essentially sterile, a frozen desert where almost nothing can survive. Not exactly a welcoming ecosystem. The absence of snakes in Antarctica is sometimes noted as a curiosity, but it reflects a broader truth about reptiles and cold that deserves examination. Snakes, like all reptiles, are ectothermic. They cannot generate their own body heat and must rely on external sources of warmth. In environments where temperatures remain below freezing year-round, where there is no sun to bask in and no warm rocks to lie upon, snakes simply cannot survive. Their metabolism would slow to nothing. They would freeze solid without the ability to revive. Some reptiles in temperate regions can survive cold winters by entering a dormant state called brumation, seeking shelter in underground burrows where temperatures remain above freezing. But Antarctica offers no such refuge. The ground is frozen solid, in some places to depths of hundreds of meters. There is nowhere to hide from the cold, no warm season to wait for, no opportunity for the kind of temperature regulation that reptilian life requires. Good luck finding a warm rock to bask on in this environment. The same logic applies to all reptiles, which is why Antarctica is the only continent completely without them. Even Alaska and northern Canada, which have brutally cold winters, experience warm enough summers for some reptile species to survive. Antarctica does not. The interior of the continent can experience summers where temperatures barely rise above -20 degrees Celsius. This is not reptile weather by any reasonable definition. The irony is that reptiles, including dinosaurs, once dominated Antarctica. Their extinction from the continent was not caused by a single catastrophic event, but by the gradual cooling that made their way of life impossible. As temperatures dropped, the reptiles that had thrived in Antarctic forests either died out or migrated to warmer regions. By the time the ice sheets fully formed, the only reptilian legacy was fossils buried deep in rock that would not be exposed again for tens of millions of years. The dinosaurs that once hunted beneath Antarctic trees are now represented only by bones and footprints, waiting beneath the ice for someone to find them. Climate reversals of this magnitude happen throughout Earth's history, with a regularity that would be alarming if we had the perspective to notice. The planet cycles between greenhouse conditions with high CO2 and minimal ice, and icehouse conditions with low CO2 and extensive glaciation. We currently live during an icehouse period, specifically during an interglacial phase within a longer ice age. Compared to most of Earth's history, our current climate is relatively cold and dry, not exactly the stable baseline we assume it to be. The last glacial maximum, about 20,000 years ago, saw ice sheets covering much of North America, northern Europe and parts of Asia. The ice reached depths of over 3 kilometers in places like present-day Hudson Bay. So much water was locked up in ice that global sea levels dropped by roughly 120 meters, exposing land bridges between continents and allowing human migration to the Americas. The world map looked dramatically different than it does today. The glaciers retreated rapidly, geologically speaking, over about 10,000 years. Sea levels rose, flooding coastlines where people had lived for generations. The land bridges disappeared beneath the waves. Entire ecosystems shifted northward to follow the retreating ice. The world we live in today is the product of this relatively recent transformation, a brief moment of warmth between ice ages. Not exactly ancient history in geological terms. Whether the current interglacial period will continue, extend, or give way to another glacial advance remains uncertain. The natural orbital cycles that drive ice age timing suggest that cooling should eventually return. But human alteration of atmospheric chemistry has introduced a wild card that makes predictions unreliable. We have added so much carbon dioxide to the atmosphere that we may have effectively cancelled the next glacial period, committing the planet to extended warming instead of cooling. Future geologists may look back at this moment as the point where human activity became a geological force. The ice cores extracted from Greenland and Antarctica provide a record of past atmospheric conditions stretching back hundreds of thousands of years. Air bubbles trapped in ancient ice contain samples of the atmosphere as it existed when the ice formed. By analysing these bubbles, scientists can determine what carbon dioxide levels were during past warm periods and past ice ages. The current CO2 concentration, over 400 parts per million, exceeds anything found in the ice core record. We have pushed atmospheric chemistry into territory that has not existed for millions of years, back to periods when sea levels were dramatically higher and ice sheets did not exist on Antarctica. What this means for the future is still being determined, but the geological record suggests that significant changes are not merely possible, but probable. The Earth does not care about human preferences. It does not consult us before rearranging its climate, raising or lowering sea levels, turning deserts into gardens or forests into ice fields. It simply responds to forcing mechanisms, whether those are orbital wobbles, volcanic eruptions, continental drift, or the activities of one particular species of primate that discovered how to burn fossilized sunlight. The past contains no shortage of climate surprises. Crocodiles once basked on the shores of the Arctic Ocean. Palm trees grew in what is now Alaska. The Mediterranean Sea dried up completely about 6 million years ago, becoming a vast salt flat thousands of meters below the surrounding land before refilling catastrophically when the Atlantic broke through at Gibraltar. These events happened not in some incomprehensibly distant past, but in time periods that, while long by human standards, are recent in geological terms. The lesson of climate history is not that change is coming. Change is always coming. The lesson is that the current state of the world, which we tend to assume is normal and permanent, is neither. It is a snapshot of a planet in constant motion, a momentary configuration that will inevitably give way to something different. The Sahara will probably bloom again, in about 10,000 years. Greenland may eventually justify its name, though not in any way that Eric the Red intended. Antarctica might return to forests, given enough time and enough greenhouse gas. The question is not whether these changes will occur, but whether they will happen on timescales that matter to human civilization, and whether we will be prepared for them when they do. For now, we walk on ground that was once ocean floor, beneath skies that were once filled with volcanic ash, on continents that have wandered across the globe like slow-moving ships. The world beneath our feet and above our heads has been many things before it became what it is now. It will be many things again after the current arrangement has passed into the geological record, becoming just another layer of sediment waiting to be studied by whatever curious intelligence comes along to wonder what the world was like, back when. Things were different. We have a tendency, as humans, to think of the Earth as a large rock hurtling through space. A stable, predictable ball of stone and metal that does nothing particularly interesting except spin on its axis and orbit the sun with the kind of mechanical regularity that would bore a Swiss watchmaker. Mountains are mountains. Oceans are oceans. Continents are continents. Everything sits where it has always sat, and nothing changes except the weather and the fashion. This view of our planet is remarkably comforting, deeply intuitive, and almost entirely wrong. The Earth is not a rock. It is a living, breathing, constantly shifting organism on a scale so vast that we cannot perceive its movements with our limited human senses. Mountains grow taller while we sleep. Forests exhale oxygen across entire hemispheres. The largest living creatures on the planet stretch for thousands of kilometers along coastlines, their constituent parts communicating through chemical signals we have only begun to understand. The ground beneath your feet is not solid in any permanent sense. It is merely slow, moving at velocities measured in millimeters per year rather than kilometers per hour. Not exactly the kind of motion that shows up on your morning commute, but motion nonetheless. Consider Mount Everest, that famous pile of frozen rock that has attracted mountaineers, adventurers, and people with questionable decision-making skills for over a century. Most visitors to Everest concern themselves with its current height, which stands at 8,849 meters above sea level, making it the tallest mountain on Earth when measured from the ocean surface. What they do not generally consider is that Everest is taller today than it was yesterday, and it will be taller tomorrow than it is today. The mountain is growing at a rate of approximately 4 millimeters per year, which does not sound impressive until you do the math across geological timescales. Since Edmund Hillary and Tenzing Norgay first reached the summit in 1953, Everest has grown by roughly 20 centimeters. That is approximately the height of a large hardcover book, added to the top of a mountain that was already the tallest thing on the planet. Not exactly a dramatic change by human standards, but the mountain is not operating on human standards. The cause of this perpetual growth is the same collision that created the Himalayas in the first place. The Indian subcontinent, that massive triangular chunk of land that juts into the Indian Ocean, is not content to stay where it is. It has been moving northward for approximately 50 million years, having broken off from the ancient supercontinent of Gondwana and set sail across what was then the Tethys Ocean. Around 40 to 50 million years ago, India slammed into the underside of Asia, with all the subtlety of a freight train hitting a stationary wall. The collision created the Himalayan mountain range, pushing up ancient seafloor sediments to heights where they have no business being. This is why you can find marine fossils near the summit of Everest, remnants of creatures that lived in shallow seas now stranded nearly 9 kilometers above the ocean that spawned them. The fish of the Tethys certainly never anticipated ending up as conversation pieces for mountaineers. What makes this collision particularly interesting is that it never stopped. India continues to push northward at a rate of roughly 5 centimeters per year, which sounds slow until you consider that it adds up to 50 kilometers every million years. The pressure from this ongoing continental crash continues to push the Himalayas upward, adding those precious millimeters to Everest's summit annually. This growth is not uniform or smooth. Earthquakes periodically release accumulated stress, sometimes dropping the mountain by a few centimeters before the steady pressure pushes it back up again. The 2015 Nepal earthquake, which killed thousands of people and devastated entire villages, may have temporarily reduced Everest's height before geological forces resumed their upward pressure. The mountain shrugs off such setbacks with the patience of a process that has been operating for 50 million years and shows no signs of stopping. Some researchers have discovered an additional factor contributing to Everest's unusual height. A nearby river system appears to have captured drainage from another watershed roughly 90,000 years ago, carving away rock that was weighing down the region. As this mass was removed, the mountain essentially bounced upward in response, a phenomenon geologists call isostatic rebound. The same principle explains why Scandinavia is still rising after being freed from the weight of Ice Age glaciers. Everest, it seems, is not just being pushed up from below, it is also floating higher because someone removed weight from its shoulders. The mountain grows roughly 2 millimeters per year faster than expected, and scientists now believe this river capture explains the anomaly. Not exactly the kind of factor you consider when planning an expedition. The rocks that make up Everest's summit are themselves a record of geological violence. They consist primarily of limestone and marine sediments that formed on the floor of the Tethys Ocean hundreds of millions of years ago. When India collided with Asia, these rocks were crumpled, folded, and thrust upward along massive fault lines. The yellow band visible near Everest's summit, a feature that mountaineers use as a landmark, consists of marble that was once limestone, transformed by the heat and pressure of continental collision. Every footstep climbers take across that rock is a footstep across an ancient seafloor, relocated by forces that make human engineering projects look like children playing with blocks. Erosion works against this upward growth, of course. Wind and water constantly scour the mountain's surface, washing sediment into streams that eventually reach the Ganges and Brahmaputra rivers. These rivers carry the debris of Himalayan erosion thousands of kilometers to the sea, depositing it in the largest river delta on Earth, the low-lying land that forms most of Bangladesh. In a very real sense, Bangladesh is made of eroded Himalayas, mountain fragments relocated by water over millions of years. The mountains lose mass through erosion while gaining it through tectonic uplift, locked in a slow-motion battle that will continue for millions of years into the future. Currently, the tectonics are winning, which is why Everest continues to grow despite the weather's best efforts to tear it down. Future generations will inherit a taller Everest, assuming the tectonic forces maintain their current rates. In 1,000 years, the mountain will be roughly 4 meters higher. In 1,000,000 years, it could be nearly 4 kilometers taller, though by then erosion and other factors will likely have altered the equation in ways we cannot predict. The Himalayas may eventually rival the height they achieved during their maximum extent, or plate movements may slow, allowing erosion to gradually wear them down. Geologists can model various scenarios but cannot predict which will actually occur. The mountain, meanwhile, continues growing at its steady 4 mm per year, indifferent to human curiosity about its future. If Everest represents the growth of individual mountains, the Great Barrier Reef represents something far more conceptually challenging: the growth and potential death of the largest living thing on Earth. Stretching for approximately 2,300 kilometres along the northeastern coast of Australia, the reef is not a single organism in the way that a whale or an elephant is a single organism. It is a colony, a vast interconnected community of billions of tiny creatures called coral polyps that have been building their limestone homes for thousands of years. Each polyp is individually unremarkable, a small tube-shaped animal related to jellyfish and sea anemones. Collectively, they have constructed the only living thing visible from space, a structure so massive that it covers an area roughly the size of Italy. The reef consists of approximately 3,000 individual reef systems and 900 islands, all interconnected through ecological relationships that scientists are still working to understand. Over 1,500 species of tropical fish call it home, along with 400 types of coral, hundreds of bird species, 6 of the world's 7 species of sea turtle, and more than 30 species of whales and dolphins. It is one of the most biodiverse ecosystems on the planet, a riot of colour and life that attracts millions of tourists annually. The economic value of the reef has been estimated at billions of dollars, supporting approximately 60,000 jobs in tourism, fishing, and related industries. Not exactly a minor economic footnote. The organisms that build the reef are engaged in one of nature's most remarkable partnerships. Coral polyps cannot survive on their own. They depend on microscopic algae called zooxanthellae that live within their tissues, providing them with nutrients through photosynthesis. The algae give corals their vibrant colours and provide up to 90% of their energy needs. In return, the corals provide the algae with shelter and access to sunlight. This symbiotic relationship has evolved over hundreds of millions of years and represents one of the most successful partnerships in the history of life on Earth. Unfortunately, this partnership is exquisitely sensitive to temperature. When water temperatures rise above a certain threshold, typically around 1 degree Celsius above the normal summer maximum, the corals become stressed and expel their algae partners. This process, known as coral bleaching, leaves the corals pale and ghostly, stripped of both their colour and their primary food source. Bleached corals are not immediately dead. If temperatures return to normal quickly enough, they can recover, gradually reacquiring the algae they need to survive. But if elevated temperatures persist, the corals starve to death, leaving behind only their white limestone skeletons. A bleached reef looks like an underwater cemetery, rows of pale structures that were once vibrant with colour and life. The Great Barrier Reef has experienced 5 mass bleaching events in the past 8 years alone, a frequency that would have seemed impossible just a few decades ago. The events of 2016 and 2017 were particularly devastating, killing roughly half of the shallow water corals across vast stretches of the reef. Surveys have documented coral mortality exceeding 70% in some northern sections, with the most vulnerable, fast-growing species suffering disproportionately. The corals that grow quickly and reproduce prolifically are often the first to bleach and die, while slower-growing species may survive but take decades to reach reproductive maturity. The composition of the reef is shifting, its ecology reorganizing in response to repeated thermal stress. Between 1995 and 2017, the reef lost more than half of its total coral cover. The decline is not evenly distributed. Northern sections, which experience the warmest temperatures, have suffered the most severe losses. Southern sections have fared somewhat better, but are not immune to bleaching. Crown-of-thorns starfish, whose populations periodically explode to destructive levels, have accounted for roughly 42% of coral losses. Tropical cyclones have destroyed another 48%. Bleaching, while receiving the most media attention, has historically caused a smaller proportion of losses, though its frequency is increasing as ocean temperatures rise. The reef's future depends on factors that extend far beyond Australian waters. Ocean temperatures are rising globally, driven by greenhouse gas emissions from every nation on Earth. Reducing those emissions might slow the warming enough to give the reef time to adapt, though even the most optimistic scenarios project continued thermal stress for decades. Scientists are exploring interventions ranging from selective breeding of heat-tolerant coral strains to cloud-brightening schemes that might shade portions of the reef from intense sunlight. Whether any of these interventions can operate at the scale needed to protect a structure covering over 344,000 square kilometres remains to be seen. Good luck deploying cloud generators across an area larger than many European countries. Australian researchers discovered that their satellites could detect coral bleaching at depths of up to 10 metres, offering the possibility of monitoring the reef's health on a global scale. The technology that allows us to observe the reef from space also allows us to document its decline in unprecedented detail. Every bleaching event is mapped, every recovery tracked, every death recorded in databases that future generations will study to understand what happened to one of the natural wonders of their world. Whether those records will document a tragedy or a recovery remains uncertain. The reef has survived previous climate shifts, though not on the timescales modern warming is occurring. What took thousands of years in the past is happening in decades today, which does not leave much time for coral evolution to catch up. If the Great Barrier Reef represents the most famous living structure on Earth, the taiga represents the most overlooked. When people think of forests, they typically think of tropical rainforests, particularly the Amazon, that vast green expanse that has been nicknamed the lungs of the Earth. The Amazon certainly deserves its fame. It is the largest tropical rainforest on the planet, covering approximately 5.5 million square kilometres and housing 10% of all known species. But the Amazon is not the largest forest on Earth. That distinction belongs to the taiga, also known as the boreal forest, a biome so vast and so unfamiliar that most people have never even heard of it. The taiga stretches across the entire northern hemisphere like a green halo encircling the Arctic. It covers roughly 17 million square kilometres, making it more than 3 times the size of the Amazon. It spans across Russia, Canada, Alaska, Scandinavia, and portions of northern Asia, crossing continents and time zones without regard for political boundaries. The taiga accounts for approximately 29% of the world's forested area, making it the largest land biome on the planet. Only deserts cover more territory, and deserts are not exactly competing in the oxygen production category. The trees of the taiga are predominantly conifers, pines, spruces, larches, and firs that have adapted to survive brutally cold winters and short-growing seasons. These are not delicate tropical plants that wilt at the first hint of frost. These are hardy survivors that can endure temperatures of -50 degrees Celsius in Siberian winters, their needle-like leaves designed to minimize water loss and maximize cold tolerance. The larch trees of Siberia actually drop their needles each autumn, a deciduous strategy unusual among conifers, allowing them to survive winters that would kill most other trees. The taiga's contribution to global oxygen production and carbon storage is enormous, though difficult to quantify precisely. Some estimates suggest that the boreal forest produces roughly 30% of the world's oxygen, a figure that would make it far more important to atmospheric chemistry than the Amazon. Other researchers dispute this number, arguing that the Amazon's greater biodiversity and faster growth rates make it more productive per unit area. What is not disputed is that the taiga contains approximately 18% of Earth's total biomass and stores vast quantities of carbon in its trees, soil, and particularly its peat bogs. The cold climate means that dead organic matter decomposes slowly, allowing carbon to accumulate rather than returning quickly to the atmosphere. This slow decomposition has created one of the largest carbon reservoirs on the planet. Permafrost underlying much of the taiga contains ancient organic material that has been frozen for thousands of years. As long as it remains frozen, this carbon stays locked away, harmless. But warming temperatures are beginning to thaw the permafrost, releasing methane and carbon dioxide that had been stored since the last ice age. Scientists estimate that permafrost contains roughly twice as much carbon as the entire atmosphere, a reservoir that could dramatically accelerate warming if released. The taiga, in this sense, is both a solution to climate change and a potential accelerant, depending on how temperature trends develop over coming decades. The boreal forest also influences global climate through its effect on surface reflectivity. Snow-covered ground is highly reflective, bouncing solar energy back into space rather than absorbing it as heat. Dark forest canopy absorbs more solar energy, warming the local environment. As the taiga expands northward in response to warming temperatures, it replaces reflective tundra with darker forest, creating a feedback loop that may accelerate warming beyond what greenhouse gases alone would cause. The trees that sequester carbon also warm the planet through their physical presence, a complexity that makes climate modelling considerably more challenging than simple carbon accounting might suggest. Despite its enormous size and ecological importance, the taiga receives far less attention than tropical rainforests. Conservation efforts focus disproportionately on the Amazon and other tropical ecosystems, while logging and resource extraction continue across vast stretches of boreal forest with relatively little international concern. Russia alone contains roughly half of the world's boreal forest, an area so vast that monitoring it presents significant logistical challenges. Illegal logging occurs across remote regions where enforcement is difficult, and economic incentives favour extraction over conservation. The forest continues providing its services, filtering carbon dioxide and producing oxygen, whether anyone pays attention or not. The taiga demonstrates that our understanding of the planet's vital systems remains incomplete. The most important forest for atmospheric chemistry is not the one that appears in nature documentaries and conservation campaigns. It is a vast, largely unknown expanse of conifers that most people could not locate on a map. This pattern repeats across many aspects of Earth science. The things we think we know often turn out to be oversimplifications or outright errors, while the things that actually matter operate in obscurity, unexamined and underappreciated. The Earth breathes through its forests, grows through its mountains, and constructs itself through the patient labour of organisms so small that millions fit within a single coral colony. These processes operate on timescales that human attention spans cannot easily accommodate. A mountain growing 4 millimeters per year is invisible to anyone watching. A forest producing oxygen is performing chemistry that occurs at molecular scales far beneath perception. A reef dying from thermal stress collapses over years, not hours, allowing each individual event to slip from news cycles before the cumulative damage becomes apparent. The living planet is not a metaphor. It is a description of actual processes that transform rock into mountain, seawater into reef, and atmospheric carbon into forest. These transformations have been operating for billions of years and will continue long after human observation ceases. Whether humanity will remain present to witness the ongoing growth of Everest, the potential recovery or collapse of the Great Barrier Reef, or the continued evolution of the taiga depends on decisions being made now, in conference rooms and legislatures far removed from the geological and biological forces that shape our world. The planet, meanwhile, continues its slow breathing, growing and changing at rates too gradual to notice but too consistent to ignore. After travelling through geological wonders, climatic reversals, underground empires, and living landscapes, you might be forgiven for thinking that we have thoroughly explored our planet. We have satellites capable of photographing every square metre of Earth's surface. We have submarines that have descended to the deepest trenches in the ocean. We have drills that have penetrated 12 kilometres into continental crust. We have instruments sensitive enough to detect gravitational variations at the level of individual milligauss. Surely by now we must have found everything there is to find. This assumption could not be more spectacularly wrong. Consider that scientists officially recognized an entire continent in 2017. Not a small island or an underwater mountain, but a continent, the 8th on Earth, covering approximately 5 million square kilometres, roughly half the size of Australia. This landmass, now called Zealandia or Te Reo Maui in Maori, had been hiding in plain sight for centuries, submerged beneath the Pacific Ocean, with only New Zealand and New Caledonia poking above the waves like the tips of vast underwater peaks. The idea of Zealandia had circulated among geologists for decades. Various researchers had noticed that the seafloor surrounding New Zealand was not typical oceanic crust. It was thicker, composed of different materials, and behaved geologically like continental rock rather than ocean floor. But the scientific community requires more than interesting observations to recognize a new continent. Zealandia had to meet specific criteria regarding elevation, geological composition, crustal structure, and area. In 2017, a team of 11 geologists from New Zealand, New Caledonia, and Australia published a paper arguing that Zealandia satisfied all these requirements. The landmass broke away from the ancient supercontinent Gondwana roughly 80 million years ago, drifted into its current position, and subsequently sank beneath the waves. Today, 94% of it remains underwater, making it the thinnest, youngest, and most submerged continent on Earth. The discovery was not sudden in the sense that someone found something nobody had ever seen. It was gradual in the sense that accumulated evidence eventually became impossible to ignore. Dutch explorer Abel Tasman sailed above Zeelandia in 1642, never suspecting that the islands he spotted represented the visible fraction of something much larger. For centuries afterward, cartographers depicted the South Pacific without any indication that a continental mass lay hidden beneath its waters. Satellite technology, improved seafloor mapping, and decades of geological sampling eventually provided enough evidence to reclassify what had been considered ocean floor as submerged continent. The Earth had an eighth continent all along. We simply had not recognized it. In 2023, scientists completed the first full geological mapping of Zeelandia, making it the first continent ever to have its geology entirely documented to its underwater edges. The work revealed a 4,000-kilometre granite backbone stretching the length of the continent, volcanic regions covering an area the size of New Zealand itself, and evidence that the landmass was stretched and thinned like pizza dough before, sinking beneath the waves. The mapping also showed that Zeelandia is far older than previously thought, possibly exceeding 1 billion years in age based on recently discovered rock fragments. A continent larger than Greenland, older than most known continental cores, hidden underwater for all of human history until a few years ago. One wonders what else might be down there. Deep in the Peruvian Amazon, far from any active volcano or known geothermal region, a river runs so hot that it can kill anything that falls into it. The Shani-Timpishka, known locally as the Boiling River, stretches for approximately 6 kilometres through dense jungle, reaching temperatures of nearly 100 degrees Celsius at its hottest points. Small animals that stumble into the water cook alive, their eyes turning milky white as proteins denature in the scalding heat. The riverbanks are too hot to walk on in certain areas, and the steam rising from the surface creates a perpetual mist that obscures the surrounding forest. Not exactly a refreshing place for a swim. For most of scientific history, this river was considered a legend. Local indigenous peoples knew about it naturally, as they had been visiting its shores for spiritual ceremonies for generations. The Ashaninka people called it Mayantuyaku and considered it a place of great power, protected by spirits that only the most powerful shamans dared to approach. Spanish conquistadors heard stories of boiling waters deep in the jungle, but presumably had enough actual problems without chasing geothermal phenomena through unmapped rainforest. The stories persisted for centuries without any Western scientists bothering to verify them. A Peruvian geologist named Andrés Russo grew up hearing tales of the boiling river from his grandfather. As a child, he assumed they were myths, the kind of exaggerated stories that families passed down without much concern for scientific accuracy. When he later studied geothermal systems professionally, he encountered the same problem that had stumped previous researchers who considered the legend. Geothermal features of this magnitude typically occur near active volcanoes or major fault lines. The Peruvian Amazon has neither. The nearest volcanic activity is hundreds of kilometers away, far too distant to heat a river to near boiling temperatures. The river, according to standard geological models, should not exist. In 2011, Russo decided to find out for himself. With the help of his aunt, who had connections in the region, he made the journey to Mayantuyaku and discovered that the legends were not only true but understated. The river was real, it was hot, and it was far larger than casual descriptions had suggested. At its widest point, the Shani-Timpishka stretches roughly 30 metres across. At its deepest, it reaches 4.5 metres down. The hottest temperature Russo ever recorded was 99.1 degrees Celsius, essentially boiling at the elevation of the Peruvian lowlands. The river flows too fast and too hot for standard life to survive, yet microorganisms have adapted to exist in its mineral-rich waters, extremophils thriving in conditions that would kill virtually any other organism on the planet. The source of the heat remains not entirely settled, though the most accepted theory involves rainwater that penetrates deep into the Earth's crust through fault systems, gets heated by the normal geothermal gradient as it descends, and then rises back to the surface through other fault-fed springs. The water may travel tens or even hundreds of kilometers underground before emerging at the Shani-Timpishka, picking up heat along the entire journey. This explanation accounts for the high temperatures without requiring nearby volcanic activity, though it raises questions about why similar features do not exist in other geologically similar regions. The boiling river, for now, remains a largely unique phenomenon, a geological feature that was discovered only in 2011 and is still not completely understood. The Earth does not even have uniform gravity across its surface, a fact that would probably alarm anyone who assumed that falling happens at the same rate everywhere. The planet is not a perfect sphere. It is an oblate spheroid that bulges at the equator due to rotational forces, and even that description is a simplification. The actual shape, called a geoid, looks somewhat like a lumpy potato when gravitational variations are exaggerated for visualization purposes. Some regions have stronger gravitational pull than others, depending on the density and distribution of mass beneath the surface. You weigh slightly less at the equator than at the poles. You weigh slightly less standing above low-density rock than above high-density rock. The differences are tiny, unnoticeable in daily life, but measurable with sufficiently sensitive instruments. The largest gravitational anomaly on Earth sits in the Indian Ocean, south of India and west of Sri Lanka. This region, officially called the Indian Ocean Geoid Low, experiences gravitational pull roughly 0.005% weaker than the global average. That percentage sounds trivially small until you consider its effects on sea level. Because gravity is weaker there, the ocean is not pulled as strongly toward the Earth's surface. The water level in the Indian Ocean Geoid Low sits approximately 106 meters below where it would be if gravity were uniform. That is a depression in the ocean surface deeper than a 30-story building is tall, covering an area of roughly 3 million square kilometers. The sea literally sags in this region, pulled less forcefully than the water elsewhere on the planet. Dutch geophysicist Felix Andries Venning-Meines discovered this anomaly in 1948 during a ship-based gravity survey, but explaining why it existed proved far more difficult than documenting that it existed. For 75 years, scientists proposed various theories without reaching consensus. A breakthrough came in 2023 when researchers from the Indian Institute of Science used computer models to simulate how the region developed over the past 140 million years. Their simulations suggested that as India separated from Africa and collided with Asia, the ancient Tethys ocean floor sank into the Earth's mantle. This sinking material displaced hotter, lighter magma from beneath Africa, which rose toward the surface in plumes. The low-density material beneath the Indian Ocean Geoid Low creates weaker gravitational pull, explaining the observed anomaly. The gravity hole is essentially the ghost of an ancient ocean, its effects persisting 20 million years after it disappeared from the surface. Hudson Bay in Canada presents a similar puzzle on a smaller scale. Gravity there is measurably weaker than expected, roughly 0.3% below average in certain areas. Part of the explanation involves the last ice age. The Laurentide ice sheet once covered most of Canada, pressing down on the continental crust with billions of tons of frozen water. When the ice melted roughly 10,000 years ago, the crust began slowly rebounding, a process called isostatic adjustment that continues today. The land around Hudson Bay is still rising by about 1 centimetre per year, recovering from weight it shed millennia ago. But ice sheet rebound explains only about 25 to 45% of the gravitational anomaly. The remainder likely results from convection currents deep in the Earth's mantle, which pull down on the overlying crust and reduce the local mass. You weigh fractionally less standing on Hudson Bay than you would standing elsewhere at the same latitude. The effect is unmeasurable without specialized equipment, but the principle that gravity varies geographically is a reminder that even fundamental forces are not constant across our planet. The inventory of recent discoveries extends far beyond continents, rivers, and gravitational anomalies. Sundung Cave in Vietnam, the largest cave passage by volume anywhere on Earth, was not explored until 2009. A local farmer had discovered its entrance in 1990, lost it in the jungle for 18 years, rediscovered it in 2008, and only then guided scientists to a cavern so vast that it contains its own weather system, its own underground jungle, and stalagmites taller than many buildings. The cave had existed for millions of years before anyone catalogued its dimensions. It still has not been fully explored. The patterns of discovery suggest that Earth conceals far more than it reveals. We have mapped the surface comprehensively but understand only a fraction of what lies beneath it. We have catalogued millions of species but estimate that millions more remain undescribed, particularly in deep oceans, cave systems, and tropical canopies where human access is limited. We have measured gravitational variations but cannot fully explain all of them. We have drilled deep into the crust but have penetrated only a trivial fraction of the distance to the mantle. The Kola Superdeep borehole, the the deepest human penetration of the Earth's crust, reached only 12.2 kilometers down. The mantle begins at roughly 30 kilometers beneath continental crust. The core lies nearly 3,000 kilometers below. We have not even scratched the surface in any meaningful sense of that phrase. The Earth continues to surprise us because we have not been looking very long. Modern geology is barely 2 centuries old. Plate tectonics, now the foundational theory of Earth science, was not accepted until the 1960s. Satellites capable of mapping gravitational variations have only operated for a few decades. DNA analysis, which has revolutionized our understanding of biodiversity, became practical only within the past generation. We are still in the early stages of understanding a planet that has existed for 4.5 billion years and will continue existing for billions more. The proportion of Earth's history that overlaps with human scientific investigation rounds to approximately 0. We have barely begun to ask the right questions, let alone find the answers. From boiling rivers that should not exist to continents that hid underwater for centuries, from mountains that grow while we sleep to forests that breathe across hemispheres, from reefs that may be dying faster than they can adapt to cave systems. Larger than cities, from gravitational holes that warp the ocean surface to crystals that grew for 500,000 years in chambers hot enough to kill humans in minutes, our planet has proven stranger than any fiction we could have invented. The writers who imagined lost worlds, hidden continents, and impossible geographies were not being creative enough. Reality, it turns out, is considerably weirder than imagination. What other secrets does the Earth keep? What remains hidden in the ocean depths, where light has never penetrated and pressure would crush most vessels? What lives in the deep biosphere, kilometers below the surface, in conditions we assumed were sterile until microbes proved us wrong? What lurks beneath the Antarctic ice sheet, in lakes that have been sealed from the atmosphere for millions of years? What geological processes are occurring right now in places we have not thought to look, that will one day be recognized as significant as plate tectonics or thermal vents? We cannot answer these questions with our current knowledge. We can only acknowledge that previous generations were equally confident that they understood their world, and they were consistently proven wrong by subsequent discoveries. The confidence that we have found everything worth finding is the same confidence that people expressed before continental drift was accepted, before deep-sea vents were discovered, before extremophile bacteria were identified living in conditions that were supposed to be lethal. That confidence has never been justified, and there is no reason to believe it is justified now. The Earth will continue revealing itself for as long as curious people continue asking questions about it. Every generation finds something that previous generations missed, often things that were hiding in plain sight, waiting to be noticed by someone who thought to look. Zealandia sat beneath the waves for millions of years before anyone recognized it as a continent. The boiling river flowed through the jungle for millennia before a geologist decided to check if the legends were true. Sondung waited patiently in the Vietnamese limestone for anyone who cared to squeeze through its entrance and document what lay within. The planet is patient. It does not care whether we understand it or ignore it. The mountains will continue growing whether anyone measures them. The forests will continue breathing whether anyone appreciates their contribution to the atmosphere. The gravitational anomalies will persist whether anyone explains them. The caves will remain dark and vast whether anyone explores them. The reefs will live or die according to temperature trends that operate indifferently to human hopes or conservation efforts. The Earth was here before us and will be here after us, still hiding secrets, still growing and changing, still being stranger than our best attempts to describe it. This documentary has barely scratched the surface of our planet's mysteries. Every topic we have covered could fill entire libraries with additional details, complications, and discoveries that there simply was not time to include. The geography of extreme climates could occupy years of study. The geology of cave formation could fill entire careers. The biology of coral reefs has occupied thousands of researchers for decades and still yields surprises. The stories we have shared are introductions, not conclusions. They are invitations to curiosity, not satisfactions of it. The next discovery could come tomorrow. Someone hiking through remote jungle might stumble across a geological feature that challenges current theories. A researcher analyzing satellite data might notice an anomaly that everyone else overlooked. A cave explorer squeezing through a narrow passage might emerge into a chamber that rewrites our understanding of underground ecosystems. A student reading about some obscure phenomenon might wonder why nobody has investigated it properly, and decide to become the person who finally does. The history of discovery is not a history of organized expeditions and funded research programs. It is a history of curious individuals who refused to accept that everything had already been found. What fact from this journey surprised you most? Which revelation challenged assumptions you did not even know you held? What questions arose that you would like to pursue further? The comment section awaits your responses, your own discoveries, your own moments of astonishment at the strangeness of the world we all share. Like this video and subscribe if you want to continue exploring the secrets of our planet. We have covered much ground, but we have only begun to reveal what Earth conceals. And now, as the hour grows late and the stories of our living, breathing, constantly surprising planet draw to a close for tonight, may your dreams be filled with the wonders we have explored together. From the peaks of growing mountains to the depths of hidden caves, from the lungs of vast forests to the heartbeat of dying reefs, from rivers that boil without volcanoes to continents that hid beneath the waves for centuries, our Earth remains the most extraordinary place we know in the entire universe. Sleep well, knowing that tomorrow the planet will continue its ancient processes, adding millimeters to mountains, growing crystals in darkness, cycling water through fault lines and back to the surface, breathing through forests that span continents. The Earth never rests, but you should. Good night, and pleasant dreams of all the mysteries still waiting to be discovered.